How did your, so Basile, is that what you said? Okay. Good morning. I think it's probably time to get started. It's a little early, but well, I guess technically it's a little late, but you could say it's early and late. Well, good morning. I'm Larry Birnbaum from Northwestern University. I thought yesterday's session of the symposium was fantastic, and I look forward to a lot of other great presentations and discussion today. This morning we have a panel, a set of papers on automation in the newsroom and beyond. And our first paper is by Matt Shearer, Basile Simon, and Clement Geiger on data stringer. So, welcome.
Thank you. If I just get a couple of minutes to set up the presentation so we can get started. Go. Not found. Great. Here you go. Thank you very much for everybody. I apologize for being absent yesterday. My flight was an absolute nightmare, and I managed to come here. So my name is Basile Simon. I work for BBC News Labs, and we're here to talk about, we talked a lot, and probably yesterday, about data journalism. Journalists having to learn to code, but I think there's something more to it, and that's the new hacks and hacker paradigm. News organizations such as the BBC, the New York Times, the FT, the Guardian, and many others in the world are creating labs to pursue innovation in news, and I do think, of course I'm working in one of these labs, so I do think that's the right solution, and that's probably better than to expect our journalists to know coding as much as we could. These labs are usually populated with hackers, engineers, people with beards, PhDs, rather than journalists with proper shirts and cameras always with them. What we do, I'm going to show you, I'm going to start with presenting just for a sec the BBC News Labs. We try to be nice. Do presentations for the web, as say. There you go. There you go. So at BBC News Labs, we try to be in this sweet spot between journalism, data, and technology, and basically to help journalists do their job with the assistance of people like us, so hackers, developers, designers, and engineers. We do a lot of quick prototyping. We have this huge freedom to experiment and to do a whole range of stuff with the latest news technology. And yeah, without too much constraints, which I think is the right solution if you want proper experiment and innovation. We have a very fluid collaboration between great journalists from the BBC who field test our products, and also, I would say, good engineers and good developers, so we can test the thing. But our job is not to go to production. We are a sort of incubator. That's a bit corporate-ish, but that was a slide from another presentation. We are this kind of incubator, so we have projects commissioned from executives from the newsroom, but also a lot of experiments. As I said, we don't go into production. That's not what we're looking for. We're pretty much here to experiment and to pass on the good ideas to other BBC departments, including BBC R&D, which is the bigger departments above us. And we presented 2 papers to this symposium, and we've been selected for automation in the newsroom, our idea being to leverage the skills that developers and engineers have and to apply them to a journalistic point of view to make journalists' lives easier. With several postulates. The first one is the machine is excellent at executive repetitive tasks, whereas humans get bored. The second one is that coding is a sort of superpower, allowing us to handle things that a human just couldn't. I'm talking about data sets which are millions rows long. You cannot ask that from a human. And the third one is that the hacks and hacker paradigm seems to generate excellent results. We saw that at the New York Times in particular. So the two papers, yeah, major good news. I brought another Englishman with me. The two papers we submitted to this symposium are two approaches, in my opinion, of this computer-assisted journalism idea. The first one is computer-assisted journalism can help journalists talk to their audiences, and that's the first example I'm going to take. It's linked data. I'm going to define that in a second. And the second one is it can help journalists find stories, which is pretty much the heart of a journalist's job, isn't it? Getting stories. So let's start with linked data. Back in 2012, we had a team of data architects, engineers, and people who were very smart who got together and considered that linked data was a very good thing for the future, in particular for journalists who are looking for better ways to surface their content and to distribute it. They created the Juicer, which is semantic web and semantic tagging engine, which does this simple thing. So it gets the content from BBC and other publishers. I'm talking about articles, pieces of video, pieces of radio. Extract concepts, David Cameron, smoking, Leicester, people, places, organization, and also intangibles. Then matches them to DBpedia, so we have this sort of universality of a database because we can collate the databases together, annotate the content, and expose everything through our API. For those who don't know linked data, the whole purpose of linked data is to build a more sensible web, so people and machines can make better sense of it. To do that, we promote links and associations between concepts and pieces of content to tell the reader, to tell Google, and to tell other machines like ours that this particular piece of content is about David Cameron, the Prime Minister of the United Kingdom, and not just some guy named David Cameron. As I said earlier, these databases of fact can be linked together and combined, so you can make high-level and complex requests, such as show me all the articles published about Conservative MPs about the topic of smoking, and then show me these MPs voting records about smoking, so I can compare who's telling something and voting in another way. A common criticism about linked data is that it remains an academic exercise. I disagree with that, and I would like to show you some examples of linked data pushed towards production and audience-facing products. So the first example is the Vote 2014 platform we put for the local election and European election we had in May this year. So that's an example of one constituency, Sheffield, which has its map, council results for Northern Ireland, but also the results for the constituency, some background around the council, and if you click more, I can't show that here, but if you click more, you will see plenty of news about the candidates, the local news. That's an example of how we can use linked data to accomplish something that a human just couldn't. I'm going to give you an example a bit later about what we're going to do in the future. But these aggregation pages are a way to use linked data in a production context. I took another example, which dates from 2012, and the Olympics coverage. I don't know if you can read, but that's an American sportsman, Michael Phelps, probably one of the best in history. And you can see, so we have this sort of bio, which is pulled from DBpedia, medals, records, news about him, including creative works, video and radio, also news about the US team in the Olympics. And that's only created by the machine, by a computer, which is nice because we had a bunch of people competing in the Olympics, a whole lot of countries competing with the Olympics, and we had these ad hoc pages for each and every one of them, just by creating and collating tags together. Another example I could show is the prototype, and that's the object of the paper I submitted here, which is 100% linked data coverage of the UK EU election in 2014, once again. There is no journalistic point here. That was just an experiment. And you can see, I hope you can read once again, it surfaced interesting results. We studied the media coverage of the candidates in the election, and you can see huge disparity between the number of candidates running by party, when we have 70, 70, 70, 69, so sort of balance, and the media coverage given to these parties, which is hugely imbalanced and misrepresented, with huge domination of Labour, UKIP, the anti-European Union party, being more covered by the Conservatives, which is one of the running ruling parties in the UK. So it surfaced quite interesting results. That's another example of this prototype. I took Nigel Farage, who is the head of the UKIP party, and he's associated with intangibles, which are kind of weird. So you have, for example, racism, right British as an ethnicity. If you take Roger Helmer, who was the head of the British National Party, is associated with Adolf Hitler 11 times. He's also associated with tea and Earl Grey, because he made a comment in a very prominent paper about that, and it caused a huge row, because who likes Earl Grey in the first place? About the future, I'm just going to go back for a second. About the future, we have a huge, no, not huge, we have a bunch of new apps for smartphone coming into production around Christmas, which will rely heavily on linked data to surface local news, and the coverage of the 2015 general election will also rely heavily on that to maintain a set of 350 pages, one per constituency. And I have only 5 minutes left, so I'm going to jump into the second part, and the Data Stringer project, which is tailored dataset monitoring to find stories for journalists. I'm going to go a bit quickly. The idea being that you don't need technical proficiency to use these tools, because you have a bunch of nerds behind the scenes who can help you set up such things. The goal of Data Stringer was to make the monitoring of datasets easier and to apply a journalistic way of thinking towards the monitoring of datasets. It was built in JavaScript and Node for reusability, and you basically parameterize the headline you will want, put that in a program, and then it's going to monitor behind the scene without you knowing that it's here. It's going to try to every day compare what's happening. I'm going to give an example, and I'm going to try to be quick. So we're testing Data Stringer with BBC London, the local station, and we wanted something to monitor crime statistics because we were tired of giving a call to the police every 2 weeks to know the stats. So what I did for them is I'm taking each London borough, 33 at the moment, I'm querying the crime statistics for this GPS polygon, then I do a big old addition. I sort everything by month, by category, so that's bicycle theft, larceny, antisocial behavior, store that in a big array, and then take the latest data, compare it to a yearly average, and they told me they would like to write a paper if there is a rise or fall of a crime for more than 25%. If this difference between the latest data and the average is minus 25% or plus 25%, then you get an email alert of a sort. On today's run, Crime Stringer generated an alert, theft from a person plus 31% in September 2014. So you have an article to write. If you take this bit, so burglary was minus 12%. It's not significant enough, not newsworthy enough for a journalist, so they decided not to run the story. However, they ran the theft from a person on the rise as a story. I'm going to jump to the conclusion, and just note that the limit of Data Stringer is that you define an event, precise event. If the event doesn't happen, you can't be surprised, whereas you can be surprised if you analyze the data set. It's maybe too hard, too much to ask for a journalist to know how to handle such complicated and weird sources of data. So these projects are experiments and should be seen as such. However, we believe, and I believe strongly, that the newsroom have a lot to earn by associating hackers, nerds, engineers, developers, and even designers with journalists. And I do believe in this association between hacks and hackers. So Nick and I decided to join these two talks together about linked data and data stringer. I hope it made a bit of sense. I strongly encourage you to go have a look at the papers. I think they are published on the AGR website or the Symposium website to give more background and catch me today if something unclear. Thank you very much. And if you do have questions.
Thank you. Although you spent some time with you, I appreciate that. We have 5 minutes for questions.
I was just curious how you handled.
I'm not sure I can hear you clearly, sorry.
I was curious how you handled problems with underlying data. So, for example, in Seattle, when we pulled crime statistics, we often found that it was mapped incorrectly, and so that it wasn't very accurate. And I know that that's been an issue in other police departments as well.
So, I don't know how it is in Seattle. In the UK, so the statistics are produced by police.uk, which is the open government API and source of data, and police.uk publishes every single arrest made by British forces with a set of parameters. So you have GPS coordinates, you have the motive of the arrest, what happened after the arrest, so why was the guy or the lady released, did they go to court, if they went to court, how much was he or she fined. You have a whole set of statistics. So we do believe, and that's maybe too much of an assumption from my part, but I consider, and for this stringer in particular, I consider the statistics entirely accurate. How is it done in Seattle? I would be curious to know that.
Well, in Seattle, and I think in other cities in the U.S., it's usually the police department collects incident-level crime data. Then they summarize that and send that up to the federal government, which is, useful for summary, but not useful for block-by-block kind of analysis. When we've gotten, and I've done it in a number of cities, when we've gotten block-level crime data, if a police officer on the beat is in a hurry, he may just, put it down to a certain 100 block all the time if he's not sure of the address. Or if in LA, the police department mapped all the crimes that were reported at the main headquarters to the headquarters address, not to where the crime actually occurred.
All right. That's a bit sloppy from them.
You said something about minus 12% wasn't newsworthy, and so I wanted to sort of prompt you to comment on, you're building obviously editorial criteria into these tools, yet you're sort of operating as a prototyping lab, which is maybe talking to the newsroom, but you're not. I think you said you're not journalists, or you're working with journalists, but I don't know, comment on that. What does it mean to be making these kinds of editorial decisions and embedding them in computing when you don't really consider yourself a journalist?
Well, I do consider myself a journalist, but I don't publish for BBC. I don't publish with them. Here, for this example, so we decided that 25% and 25% only was...
When you say we, who's we?
And I'm going to get to that.
Okay.
So that was done in association with BBC London, and they actually answered this question themselves, and they defined the editorial parameters themselves. The question I asked them is, if you were to run a good paper, good story on crime, what would be your headline? And they told me a huge rise, or a huge fall in crime in the capital. Define huge. And they said plus or minus 25% would be nice enough. So I coded 25%. So I didn't make the editorial decision about this number, which is pretty much arbitrary. This is just a test. But I insist that's the association between the guy who's going to build the little JavaScript to do that and the journalist who give me the parameters which led to this 25% number. I don't know if that answered the question.
I'd like to follow up on that. It seems like maybe you could have helped the journalists to figure out what would be a good threshold. Perhaps by looking at the month-to-month variability, it may be that once a year, there's always a month with a 25% higher or lower, and that's just from random variation. And that they really ought not to be writing a story about it when you hit the random month. So did you have any discussions about that?
Well, I do think you're completely right. Data analysis would be required to enlighten the journalistic point of view on what they are asking me to build. You're completely right. And I insist on the fact that DataStringa is still prototype. We're not even launching the 1.0 version. So that was the first test we're doing. We're running other tests with both the BBC London and other local antennas in northern England. And I think you're right. I think providing insights for journalists before they decide what are the parameters would be a very nice addition. I do agree with you completely. Thank you.
Thank you very much.
Thank you for inviting me.
Next up, we have Hilla Vendrapa and Emil Kramer on credibility of machine-written news. Topic for the while. I hope the answer is credible. Sure it is. Then we'll have 15 minutes and then 5 minutes for questions.
There it is. So good morning, and thank you for having me today, and thank you for giving me the possibility to talk about the perception of on machine-written news. So my name is Hille van der Ka, and I'm from the south of the Netherlands. I'm from a little town called Tilburg, and I do actually have 2 jobs. I work at Tilburg University, where we run a program on data journalism, which is part of our Communication and Information Sciences department. And we are closely related to the Department of Human Aspects of Information Technology. So we're actually not a journalism school, but we still do data journalism. So my other job is at the University of Applied Sciences, which is a convenient walk of 15 minutes, so that's great. And there I run the Future Media Lab. And this is an interdisciplinary institute of the departments of communication, journalism, ICT, economics, and arts. And what we do at this university is that we study the influence of technology on storytelling. And to be more precise, we now run a project on the automated newsroom. And we are interested to find out if algorithms can help a journalist or even take over some of his job. And therefore we question ourselves, like, can algorithms be used to collect information, analyze information, and transform data into a story? So in this project we do 2 things. On the one hand, we build tools, and on the other hand, we want to reflect on these tools. So we ask questions like, what is the influence of this tool on the work of a journalist? Or how does this tool influence the perception on news? And what does this mean for the education of journalists? So a few of the tools we are working on right now is, the first one is a project on censored journalism, so thank you so much on sharing your insights yesterday. So we have a project on censored journalism related to sports reporting. And on the left side, you see a second screen application we made with Arduinos. And this is actually a project we do on measuring a bicycle race. So the bikers are wearing this technology, and we also use GPS trackers to find out how fast they ride, and we try to find the differences between the different cyclists. So this is a project we do together with TMG, Telegraaf Media Group, which is one of the leading news companies in the Netherlands. Another project we do is a project on darts, and we use an APOC, which is a sensor system, to find out what the emotions are of a dart player. And we also use this information for a second screen application. We actually have 5 of this type of projects right now. So another tool we are working on is a social network analysis tool. And with this tool, which is called the journalistic dashboard, a journalist can upload different data sets like Chamber of Commerce data, and this system tracks named entities. So it tracks, for example, names or locations or the names of companies. And it looks for new relations between these named entities. So therefore, a journalist can use this system to look for new patterns in large data sets. So one last project we are currently working on is a text-to-text generator, and we do this in collaboration with the Dutch press agency ANP. And what we do right here is that we build a text simplifier. So a journalist can upload a news article, and the system will give you new versions with different type of levels. So you can easily make news items for readers who have the Dutch language as their second language, for example. So in all our projects, we like to work with a technique called natural language generation, which is actually the process of automatically creating natural language text-based on non-linguistic input. And this technique or this field in academics is actually really old, but the use of it in news or the use of it in journalism is actually quite new. And I know that the situation in the United States is somewhat different than the Netherlands, because of course in the United States you have great companies like Narrative Science, but you don't have an office in the Netherlands yet, do you? No. So we still have to work on this on our own at a university. So I used to work as a journalist for several years, and when I found out about these systems a few years ago, it kind of struck me how similar the work of such a system is related to the work of a journalist. Because if you look at how an NLG system works, it kind of reflects the work of a journalist. So first, an NLG system, when it starts to generate a text, it must decide which information will be expressed, which is kind of related to the research part of the work of a journalist. And after that, an NLG system must organize the available information and determine a structure for the text, which is really comparable to the work of a journalist when he or she selects news. And furthermore, an NLG system should determine which information is placed in any sentence, and it should choose the right words to express the information in the right way. So that's called sentence planning. And it's really similar to structuring in the work of a journalist. And finally, an NLG system must create expressions to display as well as grammatical sentences, which is of course comparable to the writing process of a journalist. So if you look at these systems, and if you look at these systems when they were first created in the Netherlands, at least in the late 90s, they produce very simple text. So they're really the robot written text. But if you look at NLG systems right now, if you look at the text produced by Narrative Science, it's really hard to see the difference between an NLG written text and a journalist written text. So therefore it's interesting to see if robot writers can replace journalists. And according to Reiter and Van Daal, this is mainly a decision based on economics. Is it cheaper to hire and train a person or to create and maintain a software? But others might look at this from a different perspective. So there is an interesting research of Clerval from this year, and he asked journalists what they think of automated journalism. And they actually really liked it, or at least some of the journalists he questions, because they thought that robot journalism will free resources, allowing reporters to do the things they really want to do. So this is a very positive outlook towards automated journalism. But on the other hand, there are also people who dislike this type of systems. So, for example, from a research of Van Dalen in 2012, he states that machines do not have the creativity to avoid cliches and add humor, although others might disagree. But moreover, he says, they do not have the flexibility to write non-routine stories. So you can't use a system like this for every story you like to write. So, but to end with a positive comment, this is actually the point of view of the researchers at my university, that energy techniques are great because they increase accuracy and reduce updating time, or because they guarantee conformance to standards. And also from the research of Van Dalen, he adds that journalists see the advantages of an algorithm as an unbiased reporter. But what you can see in this type of research is that it is mainly done to find out what the view of a journalist is on this automated journalism. But we were interested to know what the audience thinks of this. So does the audience agree? And to answer these questions, we digged into previous research on NLG system, which was mainly on with a focus on the text quality. But we also looked at previous credibility studies with a strong focus on human written stories. And we tried to look for research which was somewhere in between, and we found that in the research of Fock and Tseng from 1999, who state that in discussing the credibility of a computer product, one is actually discussing the perception of credibility. So within our research, we should focus on trustworthiness and expertise, because they think these two are key elements to determine the credibility of a computer product, in our case, a machine-written text. So in this research, we took a look into the perceived trustworthiness and the expertise of robot-written news articles, and we wanted to see what journalists think of it, as well as a general news audience. So we had 232 Dutch participants in this research, among them 64 journalists, and we asked them to read one of the articles we produced with an NLG system called DS2. And this is actually a great sports report in Dutch, as we used a sports report as well as a financial report as the stimuli in our research. And all the sports reports people were asked to read were the same. So the only thing we manipulated was the news source. So with some of the respondents, we told them that this was written by a machine, and we told the others that it was written by a journalist. And we asked to indicate the level of trustworthiness and expertise by evaluating this with 12 items on a 5-point Likert scale. And to jump into the results, we found that within the group of news consumers, there was no difference in the perceived credibility of a news source. So further, they were neutral about the level of expertise of a computer writer and a journalist. And this was somewhat different from the perspective of a journalist, because within the group of journalists, we did find a significant difference in the perceived credibility of the news source. Journalists perceived the credibility of a journalist higher. So after we looked into the different groups, we compared both groups, and there we find that journalists perceived the expertise of a computer writer as greater than it was perceived by news consumers. So finally, also one of the other things we found is that the topic of a news article is of any influence, because overall respondents perceive the trustworthiness of the sports article to be lower than that one of the finance article. So we were really surprised about the results of this research, and it did bring us new questions. So one of the new questions we now have is the question if journalists do overestimate the level of trustworthiness compared to a computer writer. And this is really something which worries me, because it kind of has the risk that journalists outplace themselves with these kind of techniques. Another question we have is, why do journalists differ from news consumers in their perception on the level of expertise? Is it because of their training? Is it something else? We didn't ask journalists this question, so yeah, I have my own thoughts about this, but we didn't really ask them, so I really don't know from an academic perspective. So one of the main questions, or one of the questions we find most important is, since the topic of the text seems to be influence the results, what subjects do people perceive algorithmic approaches as having more credibility? So this is the starting point of 2 new experiments we are currently running to, actually we kind of do the same research, but we now do it with news articles from the field of entertainment. So automatically generated news articles based on rumors of social media. But we also create tech-related news items based on reviews of different websites. And we try to find out if there is a difference in the perception of trustworthiness of hard versus soft news. And what we try to do is to find out if there is a repetitive effect. So do people get bored in the end if they read a lot of machine-written text, and does that influence their perception on trustworthiness? So we will finish this research in January, and again, we hope to share the results. So if you're interested in this research, please visit the AGR website where all our papers are on. And if there are any questions, I'm happy to answer them. Thank you.
Thank you very much. We have a few minutes for questions.
Hi, thank you for the interesting presentation. I'm a little bit confused or troubled by the use of the word algorithmic journalism or, robot journalism. Journalism isn't just writing. Journalism is reporting. And it seems to me you're mostly talking about writing here and not reporting. So could you comment on that?
Yeah, in this case, like with our full research, we focus on robot journalism, and we tried not only to create news articles, but also use other algorithms to kind of do the same work as a journalist. But this latest research, I fully agree, it's mainly on text production. So that's just a part of the bigger field of robot journalism. Yeah, absolutely.
Yeah, hi, thanks for the talk. Coming from an NLP perspective, I'm wondering if the difference between the topics is not, because due to the topic that people are more, relaxed to trust finance or sport or whatever, but because of reporting standards that make completely different writing style. So if you, you parse the sentences, you get different structures, and the generator just, are not built by this model, but by that model. So that's why you get different results. And if you train them on the right text, maybe you'll get, similar results or something like that.
Yeah.
So,
yeah.
Did you try that, or?
Not yet, but it's really an interesting thought. Yeah, absolutely. Thanks.
I'm Dan Keating from the Washington Post. I assume this technology is already being widely used in the public relations field. Most of the press releases we're getting are computer written these days, I'm guessing.
Yeah.
But actually, I am wondering, is this used for writing in other fields, in other areas of writing, that we could kind of see more what it's producing in that?
You mean besides journalism?
Not
or-
journalism, yeah.
Not journalism. Maybe I should ask you to answer this question. Because you know more about this. Yeah.
Actually, I would say at this point, most of the companies, the story generator companies are not published in any normal sense. They're based on proprietary data from companies, and they are actually returning to companies for typically distribution to their customers in some way, which I guess you could call publishing, but they're not media stories. So that's the primary, that's sort of the primary customer base in data science at this point. We do still do stories for media organizations as well, of course, but that's not usually so.
Thank you. Yeah.
Thank you. I should say, by the way, that one of the co-inventors of the technology, John Kemp, is in the house also, is currently at BuzzFeed.
I just wanted to thank you for that presentation. I thought it was super interesting. Positing is, sort of computers versus journalists. But isn't there a space in between for augmentation of the journalist practice? Being able to actually mine, say, a company's financials reports to surface 10 key bullet points through the actual system to write a story, right? Is there maybe a space in between to think about it? And also, just to react to the previous question, so I used to work in a financial technology company, and we actually would generate company research reports based on actual weighted trees that would actually surface key points based on changes in the actual financials. So I think that, and in that case, it actually tied very closely to good analytic practices, right? So you're actually taking out some of the subjective choices to actually sort of have more objective choices around what the actual what a good investment is. So I think it depends on what you're codifying and also what data you have to support it as well.
Yeah.
So that may be something.
Yeah, that's great work. Yeah, to comment on what you said before that, like, is there something in between? Yes, I do think so. Like, what I'm really interested in is if you are in between, what is exactly the work of a journalist, or what are the main tasks of a journalist? And I'm really interested to find out what this journalist 2.0 or 18.0, I don't know, is doing actually. But I do think there is a lot in between, yeah.
Sort of live there.
Yeah.
Thanks.
Thank you very much.
Okay.
Okay, our final talk in this session is by Ewan Kwok and Jisun An on the understanding the major deterrents of global news coverage of disasters. Welcome.
So the lecture note seems like not working. And okay.
Take your time.
Yeah, but it's not. Why is it freezed? Okay. Ah, is this one? No. Cancel.
By the way, for those of you who are not familiar with QCRI, which is where Jisun is from, it's a really actually quite a fascinating place.
Well, it seems like it's not properly working, but I will do my best.
Can I pull something for you, or
Where should I put this, though?
just put it on top? Just put it
Oh,
on top of it.
is it? It's okay. All right.
Yeah, yes, smash it.
Oh, oh. Hello. Sorry for the other messes. Yes, still. Okay.
Just relax, don't have So Larry, we can't really hear you at the back, so. I'm sorry. Project. I was going to say.
Yeah, it's like.
I was going to say, I would go with you, but I know this makes it
Yeah,
worse.
I'm using PowerPoint. Yeah. No, sorry. Sorry. Like. My laptop. Okay. Yes. No. Yeah, it's okay.
Just unplug this. Unplug that. Okay, plug it in. Okay. Mirroring options. Oh, no, it's not showing up there. Do not know what's going on here. This should just work. Arrangement. Ah, there. And now play it. Okay. Now get to your display again. It's there on the other screen, so. Yeah, let's do this for just a second. Here we go.
Let's just do this the most expeditious thing.
Where's your keynote? Present. Play.
Yes.
Okay, great. At last, we may have to shave a couple of minutes off the function.
Oh, sorry.
We'll do the best we can.
Yes, I will do it really quickly. Hello, sorry for the mess. Okay. Hi, I'm Tisanon from Qatar Computing Research Institute. Today I will talk about global news coverage of disasters, how the disasters are covered in different parts of the world, and what are the major determinants of global news coverage of disasters. The work is doing work with Hae-Woon Kwak, who is a scientist in the QCRI. So when I was making this slide, I found this disaster, which actually happened in my home country, South Korea. They were watching a concert on top of the ventilation grate, and they were not supposed to do that. And then it collapsed, and 27 people fell 10 meters down, 16 died, and 11 injured. Well, actually, this is the top most read news at BBC on that day. And then if you see, then there's some celebrity news and some politics and technologies. But then 5 out of 10 most read news articles are about foreign disasters. News outlets keep reporting foreign disasters. And it is not surprising. In the process of globalization, a foreign disaster can have a political or economical impact. So they report them. And such emotional news raise a sympathy for others, which can be a key to drive more audience to their news site. And also now, people who are in that disasters wait for the help, global aid, so that they can be recovered. Yes. So we understand why media outlets report the foreign disaster, but then the following questions naturally arises. Which disasters receive more attention from foreign news media? So I will just quickly go through some theoretical background regarding the foreign disaster news coverage. So maybe to some of you, it might be just boring to listen, but since it's an interdisciplinary work, for some audience there who is not really aware about it. So the theory of the newsworthiness is proposed by the Gangton and News in 1965, and it says it focuses on the attributes of the event itself, and like frequency, intensity, unexpectedness, and the continuity of an event matters for one journalist to decide whether to report the disaster or not. And so also there are some other characteristics of the disasters, like who were the one involved in the disasters, also considered to be a significant factor of newsworthiness. But then there are some people who argue that only considering those newsworthiness is not, it may not be works best, because it also one also need to consider the relationship between the countries. So there are also some people who look at the effect of the national attribute. So in a relationship between a guest country where a disaster happens and the host country where the news media exists, they look at some of the attributes of the guest country, and then also they look at the relatedness of those two countries and how those national attributes are affecting to global news coverage. So a wide range of national attribute has been examined, but the results are inconsistent, and mainly due to the cultural differences. And also, since it's been examined, international news coverage in a single country, the result might be hard to be generalized. So to complement those previous work and to add up some quantitative evidence, we use a large-scale data set and examine a global attention to disasters. And why news about disasters? Firstly, we only focus on particular issues, so it's easy to look at like how the global news flow works for this particular type of the news. And also, since unlike entertainment, which is the mainly coming from the United States, disasters happens actually all around the world. So it can be, it can give us a fair global view how the news flows in different countries. So the talk will be in three parts. The first is the GDEL data set, which is relatively new and provides us around 660,000 natural and man-made disaster cases. And then we will look at how those disasters are covered in different parts of the countries. And then finally, we will tell you about what is the most, what are the determinants of the global news coverage of the disasters. So we'll start from explaining a little bit about the GDEL data set. The GDEL is short for Global Data on Event, Location, and Tone. It is recently developed event data set. It monitors more than few thousand different media sources and collects all the news articles in over 100 different languages. And it automatically extracts the entity from the articles and trying to find what happens around the world. So they have two different data sets. One is the GDEL event database, which is coded by Cameo taxonomy since 1979. It gathers all the events happening around the world and trying to capture how the relationship between the countries are changing due to the event. But then the other data set is called as a global knowledge graph data set, and it focuses more on how many people are actually involved in those events, which can be useful for tracking like death in each country, for example. And both data sets actually built automatically by using some entity extraction. So for example, and for our analysis, we use the second data set, which is a GKG data set. So for example, if a news article have this sentence like 47 jihadists were killed, then and that this sentence was found in 10 different articles, then it will be recorded as a number of article, like 10. Count type is a kill, and the count is actually 47, and the object type is the jihadist. And there are more fields here, like the date of those news articles reported, and the number of articles, count type, so, and the counts and the theme, which is actually give us a clue whether this event is about disasters or not, and then also like where it happened, and some objectives, so who are the ones that involved in those disasters, and also it listed all the source of the URLs. So this, since it gives the original URLs, we were able to infer the country of news media where they report the disasters from the Alexa.com. So, and then I will move on to news geography, so how those disasters are covered by different regions around the world. So what we did was, so we basically divide the world into the 7 different regions, and we focused on one region and how this region reports the disasters happened in one particular country. And then we visualize it as a cartogram, which shows the territory size of the map is proportional to the corresponding value for a particular variable. So this is the result of geography seen by North America. So basically, this is the map of which country, what the disasters happened in which countries are reported in the North America. As you can see, we found a strong regionalism here. So like if you are living in the North America, then you heard a lot of terrible things happens in USA and some others in other parts of. And the interesting thing is, if we look at some other region, which is like South Asia, on the bottom you can see now that India is like the most the worst country that happens to disasters. And then also like from the south, like news geography seen by South Asia, you also see the strong regionalism. So like comparing those two, we find like they report some disasters happens in their own region. And then we also quantitatively examine whether this is true or not. So we calculate the Spearman's rank correlation between 2 different regions. And all the coefficients are positive, but it's less than 0.5, meaning that disasters covered by each region do not overlap with each other. Also, when we compare it to the world view, it's also smaller than the 0.5, meaning that each region has the unique interest to their own region, and it actually makes it difficult for research relying on a single country or region to obtain an external validity. So with our data set now, we are possible to get the determinant of the global news coverage. So which one would be more likely to be covered by more countries, like a baby killed by her mom or 200 people killed by flooding in Malaysia? I would guess it's the first one. Then why would one be covered more than the others? Would it be better if it's not a people but schoolgirls? Or would it be more covered if it's 2,000 people? Or would it be more covered if it happens in USA? So to see what is the most factor that determines the global news coverage, we build a hierarchical mixed effect multiple regression model, where the dependent variable is the number of countries covering the disaster, and we consider independent variables in 3 different categories. One is attributes of the nation, the other is the attributes of a disaster itself, and the third one is the logistic of the news gathering, whether a disaster is covered by the international news agencies, such as Reuters and AFP and AP. Well, we actually consider a lot of different variables in these 3 categories, but then a lot of them were correlated to each other. So in the end, we had these 14 independent variables in each of 3 categories, and then we also had one variable for control the model. So what we learned is disasters in countries with high population tend to be more globally covered. It could make sense if you think about as there are more people living in country, there could be more immigrants, and to fulfill the demands of them, they could cover more global foreign news. And like disaster happening in politically unstable countries receive more global attention. It could support an argument that some countries try to stereotype of those countries by reporting those crises. And then also the number of the people affected matters. The more people killed or affected by a disaster, the more countries will be covered. And also some types are more favorable than the others. So kidnap type tend to be more covered than the other types. And also like about the certain types like aftershocks or flooding types also tend to be more covered. And then the other interesting is of those three categories, we now build different models based to see which category has the most explanatory factor. When you only consider the attributes of the nations, it explains around 3.1% of the variance of the data. And then when we add up to the disasters attributes in the disaster categories, then it additionally explains like 4.3% of the variance. But then the shocking thing is that the third category, the logistic of the news gathering, add up like 18% of the variance, meaning that still whether the disaster has been covered by international news agencies matter, and that was the most powerful explanatory factor of the global news coverage of a disaster. So in summary, we introduced the GDELT, which can be a valuable resource to study a news flow around the world. And we found a strong regionalism in reporting a disaster. And also we find the prominent role of international news agencies in global news coverage of disaster. So we are now looking at what the GDEL provide us is about what media reports, right? And then from a social media now we can see what people are actually concerned, and we can see some public opinions of the disaster. So we are on a way to compare those two different communities. And so thankfully, the work has been just featured in MIT Technology Review. And then one of the most reason that I'm here is that we want to find someone that we can collaborate to continue working on this fascinating work. So thank you for listening to the talk.
Hi, thank you for the presentation. So if I were to stack up 9/11, and I'm sorry for the moroseness of this question, but if I were to stack up 9/11, the Union Carbide incident in India, and MH370 recently, the Malaysian Airlines incident, you have a varying, you have on one end, you have 9/11 that had 3,000 Americans who died, Union Carbide who had 10,000 Indians who were perished, and then MH370, which had about 200 individuals from different countries who perished, unfortunately. How do you think that if, hypothetically, if that were to happen the same day, how do you think that that an algorithmic approach would have?
So in terms of the number of countries who will covers, I think the second case will be more. I can't really say that, because also relationship between countries are quite important, and US has the most strong power around the world, so there may be many countries who are kind of who have a lot of interest in USA. So even though I can't really answer to the question, but could be interesting to see. Yes.
Thank you.
Yeah.
In the right place?
I think so.
Is this us? Nice to meet you.
Nice to meet you. Yeah.
No, we're just using our notes, yeah. We're just talking. This is low tech. Okay, right, okay. Just tell me,
Christo.
Christo.
I was just looking at the CD and saw that. I was like,
yeah, well, I'd love to hear your thoughts on it, because it seems like you're interested in the same questions.
Okay, guys, hello.
Yeah,
Good
this-
morning. Thanks for
start.
showing up early on a Saturday. We're going to try and be lively, and we're running a little behind, but we're going to finish it in an hour, and we have no slides. So hopefully there won't be any technical difficulties. So I'm Julia Angwin. I'm a reporter at ProPublica. And this is, we're talking about algorithms and the future of accountability reporting. This is a topic really dear to my heart because when I was at the Wall Street Journal, which was up until December, I really fell in love with the idea of trying to reverse the algorithms that are out there that try to personalize our web experience. And this was under the rubric of reporting on privacy. I had been leading a privacy investigative team, and it occurred to me after several years of writing about who's tracking you where that really the question everybody wants to know the answer to is, well, what does that mean for me? Like, what is the impact of all that tracking? Am I getting different prices? Am I getting a different experience on the web? And so I spent a bunch of time throwing myself and some computer programmers at that challenge, and it was a very difficult challenge. And so one thing that I think this panel is really here to discuss is, this is an important question. It's one that journalists are trying to tackle, but one thing I think we're trying to figure out is how doable it is. I was actually at a panel all day yesterday with computer scientists in Princeton who are actually, we're all trying to figure out how to do this, and it is a really tough challenge. So with me are a fabulous lineup. So first we have Kelly McBride from Poynter Institute. She's a media ethicist, and she's a vice president at Poynter Institute. She was previously a newspaper reporter, and she spent the last 12 years at Poynter researching how journalism ethics change and whether democracy can survive the digital revolution. Big question. Light topic. Yeah. Next up, we have Christo Wilson. He's a professor in computer and information science at Northeastern University. He got his PhD in 2012 looking at security and privacy issues in social media. His current research is focusing on what information internet companies collect on users and how they use that data to personalize content and practical impacts of these algorithms. And he has a really fascinating paper out on price discrimination on e-commerce websites that I'm hoping we'll jump into a little bit. And then finally, we have Christian Sandvig. Is that the right pronunciation? Associate professor at the University of Michigan and faculty associate at the Berkman Center at Harvard University. And his research investigates communications and information technology, infrastructure, and public policy. So I think that actually we should each just start out with a little précis of what we want to say. And actually, it seemed to me that if you don't mind me jumping the ordering, that Christo wanted to start off with the talk about just personalization that journalists see right now, like, and lay out that landscape for us. So if you want to start there.
Sure. So I'm very interested in speaking to you all because for two reasons. One is that there is increasing awareness of personalization online, but still I don't think we're at the point where everyone in the general public understands this. So that means for journalists, if you're doing research on the web may actually be pushing back against you in ways that you don't necessarily notice, and that can impact the way you gather data and the stories that you end up writing. So the flip side of that is, people like me are working in this space, and we need to get the word out so that people understand that these things happen on the web, and they start taking the web with a grain of salt, basically. Things are personalized and individualized, and that changes the information you see, the prices you get on e-commerce sites. These are topics that affect 1 billion people.
And then I think, Kelly, you, if you wanted to bring it to the super high level of like democracy and where what's happening, what's under threat.
So first of all, like I'm like the philosopher, right? I'm not a programmer, I'm not a coder, but I hang around with a lot of programmers, and it's occurred to me. I mean, so the whole predication of democracy is that there's this thing called the marketplace of ideas, and that the best ideas will surface and be widely distributed, and that then people can engage in their civic obligations. And we know that that's always been imperfect. I mean, like this goes back to ancient Greek democracies, where it was really only a certain class of men who were allowed to share their ideas. And when you look at the most recent era of media that predates this current era, the era of mass media, it was, there was this notion that in the one-to-many distribution, that you had to have some sort of legitimacy in order to access the marketplace of ideas. Like, not everybody's ideas got shared. And again, it was the people who controlled the media companies who got to determine whose ideas got shared, and we know that that was like an imperfect system. So there was this idea that as the means of creating and distributing content were more democratized, that better ideas would be shared. And so I've been spending the last 10 years at Poynter looking at whether that's true or not. And I don't know the answer to that question. I mean, and some days, yes, there are certain ideas that would never have gotten distribution in the previous mass media marketplace of ideas that get a lot of distribution now. And there are some ideas that don't get distribution now because of the environment that we work in. And I think that that's concerning. And so, I mean, let me just share two examples, an idea that did get distributed and ideas that don't get distributed. So right after the Newtown shooting, there was this professor in Boise who wrote a personal blog post about what it's like to raise a mentally ill child. And the title was I Am Adam Sandler's Mother. And that got wide distribution. And I don't think in the previous era it would have. I think that because of her geography, mainly, she was in Boise. I think that if she had been a professor in New York, she may have had more access to the means of distribution. But because she was a professor in Boise, because she was a woman, I think there's a lot of things that suggest that that particular idea of what it means to raise a mentally ill child wouldn't have gained traction. But, I mean, what we know about certain ideas, and I take this from, if you guys were at the Online News Association, Nick and I did a presentation there. I take this from some of the work that he's done. If you look just at conversations about race and racism, that people don't like to be in conversation in a social media environment about race and racism. There are exceptions like Ferguson on Twitter, but for the most part, if you post, like if just a general news organization, or if you post something on Facebook about something controversial about race, it's probably not going to get a lot of traction. And that's because sociologically we know that human beings, that's a really scary topic to talk about, and human beings aren't going to engage with that content a lot. And if they do, it's going to be within their own filter bubble. It's not going to be a cross viewpoint kind of conversation. And so Facebook will automatically, the algorithm of Facebook will drive that conversation down. It won't get as much distribution. And so the notion that there are these thousands and thousands of algorithms that are really controlling the marketplace of ideas, the personalization that Christo is talking about, is concerning because there's no accountability for these algorithms. We don't know what biases were programmed into them. And I think we need to be concerned about that, because even for all of its flaws, the companies that controlled the marketplace of ideas in the previous era at least had a stated loyalty to democracy. They said that what they were doing was because they valued democracy. The companies that control the marketplace of ideas now, through these algorithms, don't necessarily have their democratic obligations as their first priority in the work that they're doing. They have something else. A lot of times it's a loyalty to stockholders. Those two ideas aren't mutually exclusive. Certainly mass media companies have a loyalty to stockholders as well, but they've always had this notion of democracy as the foundation of why they exist, why they do journalism as their business model. So it's just something that I do wonder how democracy survives in 50 years or 100 years as the marketplace of ideas becomes completely controlled by algorithms. It transfers the ability to manipulate that marketplace to a completely different set of people. And if you want to get like all science fiction on it, you could see an era where certain companies control democracies. And yeah, I think I think we want some accountability for that.
So in case that wasn't dark enough, Christian.
Good morning.
Christian has an even darker take on all this, so I thought we'll go to you next for the dark side.
I didn't think it was that dark. All right, okay. So our topic today is accountability journalism and algorithms. And I think the most interesting relation between those two things is really to consider algorithms as a target for investigative journalism. Stuart Geiger recently said that algorithms are the new God's eye trick. So in the popular imagination, as the previous speaker pointed out, algorithms are seen as perspectiveless knowledge. They produce perspectiveless knowledge. And computer scientists wouldn't see it that way, I think. They're taught to compare algorithms, and they write algorithms. They know that they're not perspectiveless. And similarly, journalists, I think, as a breed, are very suspicious of the idea of perspectiveless knowledge. But I think our goal as a society is to say, well, gosh, now that we have computation spreading into all of these different aspects of life, where we have things that used to be done by humans and now they're done by algorithms, what this is, as previous speakers have pointed out yesterday, it's a black boxing of kind of everything, so that things become technical and hidden where before they were, I don't know, they may be slightly hard to find out about, but there isn't a veneer of expertise or mathematics or computer science obscuring things from us. I think our goal really should be to ask, we have algorithms looking at us now in all of these domains of our life, and everything that we can see says this is only increasing. So what I'd like to do is develop something like a right to look back. So how do we see the things that are seeing us? And the Wall Street Journal stuff is exemplary in this regard. But what would that look like? I mean, one of the sort of perspectives on a right to look back at algorithms implies that you need to enlist a lot of super smart computer scientists to help you do really technical stuff. And I think that's the case in some instances, but it's not necessarily always the case. So when we think about algorithms in things like advertising selection, search results, recommendations from friends you may know to movies, spam filtering, censorship, all the ways in which algorithms are affecting just the sphere of content, we could also go to other things like government surveillance or I don't know, offers for loans, mortgage rates, things like that. All of these spheres, how would you develop a right to look back? I mean, I think we can do quite a bit without a lot of technical knowledge, and I have some inspirations. I mean, a couple of years ago, someone named Bernard Miesler, who I didn't talk to about this, but he wrote a series of pieces for Read Write about basically the experience of noticing that dead people were liking things on his Facebook, and he was really curious about that. And so he started to try and ask around, and he asked his readers do you have any dead people liking things on your Facebook? And then he looked into the process by which likes are used in Facebook advertising, and he was really able to bring to light the operation of likes in Facebook advertising in a way that wasn't widely known before. And it's not clear to me that you needed any particular technical knowledge to do that. So he just messed around and did a kind of lone wolf comparison, and that was really valuable. However, we might actually be able to do even more if we did combine the tactics of investigative journalism in an organized fashion with people who are interested in collaborating with us and with technical expertise. And so, I mean, that's where I'd really like to go. And one of the things we talked about before the panel started is that this would be an interesting way to develop this topic, is to what can we do? What are some tactics we can do to develop this right to look back at algorithms? Is it always going to be huge budgets and computer scientists, or are there some other efforts that we can do?
Well, I think that is sort of the central question that is, I think, at least top of my mind, right? Because as an investigative journalist, this is what I want to do. But I think it would be really nice if you could just mess around on Facebook and look at some dead people, and that was how you got these stories. But in fact, that's not been my experience. I want to tell one story. Actually, I'll tell two stories if you don't mind, and then I want to go to Christo's paper, because Christo's paper is a real test case in how hard this work is. So let me tell you one easy sort of the low-hanging fruit story that I did at the Wall Street Journal, which was right before the presidential election between Obama and Romney. I got a tip that Google was treating search results differently. When you search for Obama and then your subsequent searches would actually have Obama news in them. So for your next search, if it was, for instance, guns, it would say guns, 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 and there'd be these 3 results in the middle that were, it actually said at the top, Obama plus guns, and it was like 3 things he'd said about guns, and then the rest of your gun results. And this would happen after you search on Obama for the rest of your browsing session. But for Romney, it didn't. So you would search on Romney, and then you would search for guns, and it didn't give you the little Romney plus guns. And so I got this tip, but it was hard to verify, right? Because, I did a search, it didn't kind of show up. Then I tried to do it with incognito, and it didn't show up, and I was like, I'm confused. And so this was actually a relatively easy one to test, because I went to Mechanical Turk. I paid, $150 for a couple hundred people to test it, running it under certain conditions, and in fact, it was true. It was provable, and it was a very nice finding. And Google, of course, said, well, this was totally inadvertent, and we had essentially, quote, trained our data before the election and hadn't updated. So when we trained our data in terms, like we saw what kind of things were correlated, at that time, people who were interested in Obama wanted more Obama news in their future results. That's what it looked like to us. And, my feeling was this was a week before the election, and I was like, I feel like I'm not feeling good about your training practices here, because they have been running for president for 2 years, right? Because that's how long people run for president these days. But anyways, of course, it was all totally inadvertent, and they were like, it's just a mistake. But it made me think about how at the Wall Street Journal, if we had said, okay, we have this special eye scanning thing, and we see that on the front page you read a story about Obama, and then when you go into the personal journal section, your story about toothpaste is going to be like Obama's views on toothpaste will be embedded in there, we would have been strung up and tied, right? So full stop, like end of our business. So it is interesting that this inadvertentness of the algorithms is an out, right? But it's also, I want to contrast that with the fact that that was actually the low end of how hard it is to do this reporting, which was several weeks of a Mechanical Turk experiment. And of course we did it wrong, so we had to run it again and, like all that. But the price discrimination story that we did at the Wall Street Journal, where we found that Staples was charging different prices in every zip code in America, this still is true. Some people's staplers will be $14 and some will be $11, and that's true for your tape and your paper pallets and anything you want to buy from Staples. And they actually took us a very long time. It took us actually, I hate to say this, but almost 9 months to do that. So because we weren't looking for Staples, we were looking for price discrimination. So you send out these crawlers across the web, but then you realize that like the data you're getting is all time dependent, right? So you have to control for time. So you try to control for time, but then you realize you can't really control for like who they think is coming, and you have to put it through all these different locations. And we ultimately actually abandoned that approach. So after several months of doing that, we're like, you know what, that didn't work out. We're not finding anything. So we did another thing, which was let's test some hypotheses. There's a bunch of rumors flying around that airlines are giving you price discrimination. We always hear that. Or that there had been a paper saying Staples is doing weird things, but only sort of in Massachusetts. They have weird prices there in different counties. And so we tested a bunch of hypotheses, which was an easier test to run, and ultimately found that the one hypothesis that we could actually build a whole national story around was we were able to find that Staples was doing it across the country. But that was 9 months, 2 programmers, and 2 reporters, right? For one finding, which was a spectacular finding, but is really more of an academic research paper in some ways than what a normal newsroom is set up to do. I would like to say that it was also one of those cases where, in the end, we figured out sort of why they were doing it, and it appeared that they were giving you different prices based on how far they thought you lived from an Office Max or an Office Depot. So there was a very legitimate reason, which was you live near a competitor's store, so you will get a cheaper price, because in theory you might just get off the internet and go drive to that store and get your stapler. And so that seems like, by all economists' standards, like a very reasonable way to do price discrimination. But it also just happens that if you ran the numbers nationally, that the people who live near Office Max and Office Depot are richer and whiter. So it turns out that richer, whiter people are getting better, cheaper prices. So once again, inadvertent and confusing, right? Because they have a perfectly legitimate economic case, and there are economists who will argue and have argued with me that that is the future and that is what we want out of pricing. But there's also a question for us as a society: where are we going to draw the lines? The problem is we don't know where we're going to draw the lines until we know the contours of the problem. And reverse engineering this stuff is super hard. So I thought, Christo, if you could talk about your paper, because it seems like you went through a similarly long and troublesome journey, but with some interesting findings.
Yeah, so your journey of 9 months and 4 people is not out there. I mean, that paper is the result of 5 people and 4 months.
Okay.
So more CS people, so we were able to get a little bit of a greater scale, but still the basic technical challenges are all there. So actually, it was interesting that you brought up the Google personalization, because the first paper we wrote was actually reverse engineering how Google search personalizes results, and we saw the same thing. If you search for Obama and you search for something else within a 10-minute time window, you're basically getting Obama plus this other thing. And after 10 minutes, the effect goes away. So there's this recency of, anything you've searched for recently affects the subsequent searches that you're running.
Oh, I think I didn't pay my Mechanical Turk people to surf more than 10 minutes, so I actually didn't know that.
Yeah, so we automated all of this, and there's this very noticeable spike at 10 minutes where the effect disappears. And from Google's perspective, or from an information retrieval perspective, they do this for disambiguation purposes. So it's somebody searches for apple, and they don't know if you want computers or orchards. So then they see the next thing that you search for is seeds. And they're like, oh, actually they want apple seeds or farming. So that's why they want this history. But the inadvertent problem is, okay, now I'm looking for a political topic, and as I'm trying to dive into it, I'm also getting shoehorned one way or another based on the previous things that I ran. So for the price discrimination study, it's very similar to the approach that you took. So we started with Mechanical Turk workers, and we had them change their proxy settings to run all of their searches and browsing through a proxy that we controlled. So they would load a page, and it would run searches on all these e-commerce sites, and we would see the searches going past. We could record the results. But even then, there's a lot of noise in these samples. So the other nice thing about running it through a proxy that we control is every time we saw a search go out, we had an automated script that would run the search again at the exact same moment in time, but with no cookies. So every search from a real person was then paired with a control that was, agnostic. So the end result of that is we could see that these people were getting personalized results and some other people weren't, which is great, but it still doesn't tell us why each individual was getting a personalized result. It was different or not. So then we went back with a massive amount of browser automation and had all these servers running queries at exactly the same time with exactly the same attributes, except for one thing that we had changed. Like, was it an iPhone or a desktop? Was it Firefox or was it Chrome? Are you logged into the site or are you not logged into the site? And in those cases, we could disambiguate, this is the particular feature on a particular site that caused this change. But even doing that, we still couldn't explain all the results that we saw. So there's some things in these algorithms that we just couldn't tease out. We couldn't reverse engineer the black boxes. So we didn't look at geography, which is what the Wall Street Journal was doing, looking at staples. But we did find a bunch of interesting things, like on Travelocity, you get better deals in hotels if you browse from an iPhone. You get about $15 off on hotels. Home Depot is incredibly weird. So Home Depot basically has different inventory for users on mobile browsers. So if you go from a desktop, they give you 24 search results, and the average price per item is about $100. But if you go from your iPhone, they give you 48 results, and the average price per item is about $230. So it's like if I search for a folding table, on one I'll get plastic, cheapy folding tables, and on the other one I'll get, a mahogany dining table. It's just a stark difference. The last fun one was Expedia and Hotels.com. So on those sites, they're actually doing massive A/B testing on all their users. So when you show up, they randomly stick you in a bucket, and one or two of the buckets, when you search for a hotel, you get the expensive ones at the top. But then there's one other group where you get the cheap stuff at the top, and in general, everything is much cheaper. It's totally random. You have no idea which bucket you're going to end up in, and there's really, unless you start clearing your cookies, there's no way to get out of this. You'll just be stuck with the more expensive stuff.
Right. So this is like a huge amount of work, and the problem is that we still don't have the conclusiveness, right, of like what exactly is Home Depot aiming for. And in this era where so much personal data is collected, it's very strange because you try to control for every factor, but it may well be that they have this is like, I'm stretching it a little bit, but what if they just decide that everyone with blue eyes is going to get like random prices? Like, there are going to be factors that are going to be very hard for us to predict, and because the amount of data they can get is enormous, right? They have so much of our behavior. It's not as much, there is some of our identity mixed in there, but there's so many behavioral factors that could be attributed, right? In your cookies, they have stored where you've been on other websites. Maybe there's something there that that behavior flagged something. And so this is the challenge of reporting in this world right now, but it feels to me like a challenge we have to figure out how to surmount, because just the little evidence we do have suggests that whether these algorithms are designed to be benign or not, they can actually be very influential in ways that we as a society may not want to accept. And so I guess the question I have back to you, Christian, is are you still convinced that we can do this without massive computing power?
Well, I mean, the danger of saying that this is hard over and over again is that we just scare people away from it. And the people in the audience are like, well, gosh, I don't have a background in this, and I'm not rich, and I'm not at a rich news organization, so I guess I give up and leave it to you guys. And I don't think that's the right way to go about it. So I think I wasn't trying to minimize the efforts that you've done, because I think that there's a range of things we want to find out about algorithms, but some of them might be easy. So I think that, Bernard did some interesting work, and he didn't spend 5 computer scientists in 4 months, right? He seems to have just asked his readers questions and had them submit things back. And that's an interesting strategy. I mean, it's one that I've been calling a collaborative audit after the phrase, not the financial audit, we know what a financial audit is, but after sort of the audits for housing discrimination or for employment discrimination that you may be familiar with, where someone will send resumes with varying names, for example, but equivalent experience to try and detect discrimination in employment, or someone will apply for apartments with actors that vary in a systemized way, approaching landlords. So, I mean, I'd like to see something like this for algorithms. So I guess to reframe your question, I think my question is the same as yours, is how do we reduce the cost of the expensive problem so that it's something that more people, more investigative journalists have access to. And I think one way to do that might be to ask ourselves, what could we do that would be kind of like a consumer reports for algorithms? Because right now, Consumer Reports does things like, they're a nonprofit, and every year they're going to send car owners these surveys where the car owners fill out how the car worked for them, and then they compile these really uniquely iconographic reports with the little half moons that maybe you remember that tell you what cars to buy. So I'd like to see something like this for algorithms. So rather than going out to Mechanical Turk each time, or rather than using your own proxy servers each time, there could be a pool of collaborators that would allow researchers access to their data, and they would systematically vary things when they interact with platforms. It's a little different than Consumer Reports, because Consumer Reports kind of takes it for granted that cars are a competitive marketplace and your goal is to decide between cars, whereas we're not in that space with algorithms, I think. I mean, algorithms are not typically a competitive marketplace, and a few algorithms tend to really dominate certain areas of activity. So rather than helping you choose the right platform, what this would be more is like, help us find out how you're getting screwed so that we can save others. And I think, you know, some people would be interested in participating in that, and we could bring down some of these costs.
Right. I think there's also a question that is worth mentioning, even if we don't have the answer to it, which is that there's also this other thing we have called laws that could could come to play, right? We could demand accountability not just through technical means, but through legal means. Kelly, you wanted to jump in?
Well, yeah, I do think that public policy could address some of this, but it seems to me like technology is always going to be ahead of public policy. I mean, it normally is historically, and that's probably going to remain the case. I just think that we also need to diversify the way we ask the questions, because if you think about like the way you guys have formulated your questions, it's based on these questions that you have, and the reality is everybody's making almost all of their major life decisions based on information that they get through algorithms. So if I am a poor parent who's searching the web at the library about school choices, I'm going to get one set of information, whereas if I'm an affluent parent and I'm searching the web from my high-speed internet connection in my home, I'm going to get a different set of information. And so I mean, we have spent a lot of time on some significant equality issues in our country, and we still haven't gotten them right, even when we don't consider how algorithms are affecting them. And now, the way it could steer people towards certain decisions that would create, I mean, you're essentially talking about a separate and unequal environment for people in terms of the information that they're getting, and the decisions that they're making, or the prices that they're being offered. And we tend to be concerned about prices because we are consumers, but think about it in terms of like the school that you enroll your child in, or the food that you choose to eat. I mean, some real significant equality issues.
Right. And that's why I think that we need more evidence on the ground about what's happening in order to have a conversation, because right now we just have some discrete data points and we're like, oh, there's a price here, there's a search result there, and it's hard to have a conversation about what does this really mean global inequality, right? Because the truth is there is another possibility, which is that these economists are super right and it's all going to be awesome, and we're going to, no, seriously, like this is an argument I have with my husband. He is an engineer who installs sensors everywhere, and he believes the more we know about the world and how things are actually working, we will be able to then provide better services to the poor, and like there is an alternate world, and the people at Google who want to change the world and believe this do believe it, right? And so I don't want to rule out that possibility. I want the data, right? And so we need to know what it is on the ground. Our job as journalists is to present that truth, and then we can all make that decision. I just don't think there's enough.
There's a third
there.
alternative as well, and that is that some sort of like ombudsman for algorithms, or ombudsman organization, where the companies are required to do certain levels of reporting, and then there's a third independent party, not just one individual, obviously. And you're not going to come up with a solution. Yep. I mean, I think you need all three solutions, right? You need journalistic accountability, we need public policy, and I do wish that there was more energy behind this third alternative, where the companies were required to be transparent on a certain level to a certain authority who could then
and
talk
I feel
to
like
the public.
That level of algorithmic accountability, we have seen that with the NSA, for instance, that they have internal safeguards, and theoretically their algorithms for collecting supposedly, like for instance, the phone metadata program. That was information relevant to national security, which turned out to be everybody in the United States. So I don't always think self-regulation, even when it has the name Inspector General, always works. But we have a huge amount of questions, so I think we should let our awesome audience jump in here.
Sorry, I started the line. Just thought it'd be interesting. So Irfan is at Georgia Tech, and I appreciate this panel. I think it's extremely important, the conversation you're having. I just want to be a devil's advocate for a few minutes. Last I checked, people write algorithms.
Yep, that's
Okay?
right. And
Absolutely.
they don't fix the data right after they trained it 2 years ago or whatever. And
Well,
And you don't know who those people are, and you don't know what their personal biases
so,
are.
No, just kind of, what I'm trying to get to is kind of blaming technology entirely as a, in a cocoon of its own, while other things that are ethically related. I mean, for example, there was an attack in Pakistan. For the first 6 hours, everybody thought this was an attack from India. There was no evidence for it. And by the way, it was people who were tweeting all of this, not algorithms. Okay? So, I mean, there are lots of instances of this. And I just, as I said, people still write algorithms. They have ulterior motives.
Correct.
They want to
And-
make money.
right. And our goal
They
as
wanna do all of that
journalists
kind of stuff.
is to hold people accountable, algorithms accountable. I don't think that any of us here have a mistaken belief that the
No, but so when
computers are
that's-
yet running the world.
So that's the question I'm asking is, what does it mean, accountability for algorithms? I mean, are we going to start creating ribbons that are going to check mark this algorithm is now safe and possible for people to use because there's a group of people, equivalent to the EFF types of things, who has now basically checked everything and check mark, seal of approval. Is that what we're going for? And again, that could also be gamed. Because that's what we've noticed with
I think we're
security
looking at, I think we just want to call bullshit on the people behind the algorithms. So like when Google says, oh, that was inadvertent, the reality is it causes harm, and they should fix it, even if it's inadvertent, and they won't fix it, they won't be motivated to fix it unless somebody is holding them accountable.
Yeah, so 2 comments. One is that there are definitely cases where algorithms are super helpful. I mean, the idea of a smart city that helps people or controls pollution, or even something just like Netflix. People love this stuff. It's super useful. But there are cases where things just go wrong and you didn't plan it that way. Like there's this great study from LaTanya Sweeney where you search for African American names on Google, you tend to get ads for criminal background checks. You search for a white person's name and you get a genealogy search. There's not a racist engineer at Google who built it that way. The algorithm was trained on data from real people, and the algorithm learned that people have biases, so now the algorithm has those biases. It really is inadvertent. But that said, people need to start looking at these things to increase the transparency. When we notice these problems, we should be able to push back and say, this needs to be changed, this needs to be tweaked. And that's not to say that there's a perfect algorithm that will never cause these problems. This is something that's iterative. So the other thing I'll mention is that I think there's a problem with computer science education in this respect. There's a generation of engineers that received almost no ethical training or how to deal with human subjects. And yet today I can write an app over a weekend and have 100 million users in a month. The scale at which my algorithm now impacts people, you couldn't do this 15 years ago.
Just to add to that, I actually teach the ethics class to our undergrads.
Thank you.
But actually, I must admit that what the problem is, nobody actually, when they're interviewing them for a job, actually ask them, what ethical training have you had? Neither does the job actually have any requirements for that.
Right, and is the class
Yeah.
required? Is it a required class?
Okay,
That's
let's
good.
go to the next question.
Great discussion, and unfortunately, we cannot really make a dent into the issue in an hour. We need a conference for that,
Yes.
really. Seriously, we should consider that. The story goes way back. You see, the algorithms did not evolve that way randomly. If you go back to the history at how search engine algorithms evolved, actually they started from information retrieval techniques, but spammers have been so successful in actually beating them time and again that we had the popularity metric, we had the page rank metric, and eventually the search engines gave up and said, okay, we're not going to do that, but when it is important, we'll try to fix things. So I know that for a fact that when it comes, for example, to elections, the search engine's results of the candidates is not going to be the same as Staples or JCPenney's, it's going to be, you're going to get the official page first, you're going to get the campaign next, you're going to get Wikipedia, you're going to get that. News will come way back because on the past things have been fooled. So there was, in their defense, an effort to essentially create things that they are more reasonable when it is a high-stake game like elections. But it has gone out of control because errors can produce results in algorithms, and we do not know. I mean, we tend to believe that if the algorithm behaved like that, it was intended. No, many times, most of my programs do the wrong thing, and in the beginning I would think that they are so smart, and then I will realize it was a typo somewhere. But what also happens is that there is another huge network named Facebook, which has the ability actually, when it comes to elections, with its hidden algorithms, to affect greatly the results of an election, because they can essentially move a subset of society, if they so please, to be motivated to go out and vote, while the rest might be demotivated, or at least not motivated at all. So, the thing gets really, really high. I appreciate all of your comments about the...
And do you have a question?
The question comes down to how do we eventually do that? Do we go with a law, with a regulatory? Do we ask for openness of the algorithms? Do we ask for a panel of experts to test that? Because we need to do something. Otherwise, the public's trust in this technology will go down. What do you suggest?
I can...
Go ahead.
We haven't mentioned that much about transparency and openness. It was just touched on briefly, and that's a great topic. I mean, 2011, Pasquale and Braca started to call for algorithmic transparency, and I think in the years since that initial call, maybe you remember they said there should be a federal search commission instead of a federal communications commission, and it got some press coverage. I think we're now at the point where no one is that interested in that proposal, because it's really hard to imagine a system of transparent algorithms that would give us the accountability that the panel's been talking about. And the reason, in part, is that let's say with the Google search algorithm, what is it? It's like 150 people touch it now, and if you just gave it to someone, like here it is, here's the algorithm. If you're a computer programmer, it's hard to know how that would help you do anything, because you would read it and you'd say, like, what am I supposed to do here? I mean, because the algorithm produces its results in combination with the data. So really, what we need is the combination of the algorithm and the data. And there's not an effective way we could externalize that, even if we got around the companies really hating the proposal and being really forcefully asserting their trade secret privileges and their intellectual property and not wanting to show it to anybody. But it's just hard to know. So just to make this clearer, you do have some platforms with open algorithms now, like Reddit, right? And Reddit can't reveal the entire algorithm because of the spam problem that's been mentioned. So there's still a kernel of secrecy that they're not revealing. But even the stuff that they did reveal, if you read programmers talk about it on Reddit, they all disagree about what it does. And some of them are the authors. So it's hard to know how exposing all the algorithms are going to solve any of these problems. I think that's why the other strategies that have been raised are much more interesting.
Next question.
Thank you. So I wanted to address the survivability of democracy and draw a historical analogy of the ostracism process in ancient Athens, where people used to ostracize people in pots and stuff, and even that was inadvertently sort of manipulated because you had people bribing other people to put more ostrakas in pots. So I feel that there's always. So my question is, what does success look like? Because a lot of the times we don't force ourselves to operationalize success in your fields. And more importantly, I think reducing the barriers between computer scientists and non-computer scientists, because I started off being a computer scientist. I currently study at the Center of Urban Science and Progress at NYU. And I'm deeply distrustful of computer scientists because they're all men, and yes, they don't have ethical education to even conceptualize these questions. So I think my overarching question is, what does success look like in terms of in 15 years down the line, 10 to 15 years down the line? I'm very excited about the consumer reports for algorithms, but if I were to suggest a Google and a Facebook to reveal the categories of their algorithms, like, you know, like location or, you know, just high level stuff, so that you can you can separate the monetary element. They can still stick onto the monetary element, but then reveal just enough to reduce your pain to reverse engineer those algorithms, so that we have a capability to study them, but they have a capability to like enrich them for monetary benefit as well.
Google and Facebook do offer some window into sort of how they've categorized you. They have these sort of preference managers that you can look at, sort of what buckets they've put you into. But having spent a vast amount of my time staring at those buckets, I can tell you they're highly unilluminating. Although I have to say they are often wrong. So Google continues for, I don't know, how long have I had a relationship with Google? At least a decade, right? And they think I'm a man, because I write about technology and I search about technology topics, and I'm like, you know, they have so much evidence that I'm not a man, and it's really surprising to me that they haven't learned this yet, but I'm fine with it. I actually feel like I'm winning. I'm winning some sort of weird game with them. But I think that the best model for what he's talking about, which is could we have like limited visibility into the underlying data, is the Fair Credit Reporting Act. So the Fair Credit Reporting Act is basically what allows you to see the data underlying your credit score and to challenge that. And so it is a kind of a clunky law, and anyone who's ever tried to clean up a mistake on their credit report can say it is not the perfect system. But out there, it is probably one of the only ones that sort of seems maybe applicable, which is right now that law only covers data really used for employment and financial decisions, but it could well be that we decide that we want people to have a right of access to data used for other decisions made about them. And the FTC has talked repeatedly about how they would sort of like to expand the contours of that. So that's one thing to think about in the realm of possible solutions, but I think we are all basically in the world of like, we're just trying to understand the problem.
No, well, I also think that success looks like, I think that that's actually a fabulous question, and there's a lot of research that we could do, and we could create models of different success. And one model might be that you at least have the ability to surface an idea to so many different people within your affinity group, that you would look at how ideas or information cross affinity groups, and there's probably a level of success that you want to create there, that I think we could build computer models of success that would look very different. And then we would say, you know, that like in a society, you know, so you're talking about giving power to the individual, to the consumer. And I also think that we want to think about giving power to groups of people as well. And we could create computer models of success, which we haven't done yet, right? We don't even know what a democratic success would look like as a computer model. But if we did that, it would inform our public policy, and it would also inform, I think, the people who are really concerned about this, so that they could start, like I'm sure that there are people at Google and at Facebook who are really concerned about the democratic implications of what they're doing, and it would give them some more creative ideas to think about. Next question.
Hi, Michael Bernstein from Stanford. As a computer scientist and a humanist, I think it's dangerous. You think that's impossible?
No. I thought that the idea that they would be mutually exclusive was funny, because I don't think it is.
Good. Okay. So I find it dangerous to project our concerns onto, quoting you, a black box or an algorithm. It's like, I think instead this should actually be causing us to reflect on the nature of us or a society. And I'm just going to attempt to hone some of the points that have already sort of been said on the panel here. For context, I spent 6 months as a postdoctoral researcher at Facebook on the data science team before starting my faculty position. And I was trying to basically understand what was going on in terms of data and design and their intersection. The Facebook newsfeed algorithm maximizes human engagement. That's what it wants to do. In fact, like Facebook wants to help people connect. And so what we see...
And see lots of ads.
No, that's a separate part. That is a separate... Hold on. What we see in that algorithm is us. It is a machine learning algorithm that takes data based on human activity and learns what to show us. So we are the ones who are disengaging with negative affect, high valence content, like political content. And so it in reflection, as you pointed out, is now tamping that down. So I reject the claim that what we need to do is like attack the algorithm. And I think we need to think a bit more broadly. And I was wondering if we could open that conversation.
So it's totally true that, I mean, the algorithm is mining human data. But if the end goal is a democratic society, we need to move beyond just what people want as very simplistic impulses. Perhaps Facebook having a million or a billion eyeballs, it's Facebook's responsibility, as a good actor in the global community to try to surface this high valence content or to challenge people. So in that case, it's not the algorithm, it's more the company's ethics and what is its position in society and what should it try to promote overall.
Because we do have the data on what people want. They want cat videos. We know that. This is a fact, right? And so, in the old days at newspapers, there was this tension. How much of the fun stuff do you do, but still you have the moral obligation to do the other stuff? And I think what's interesting about these companies, in some ways, a Facebook and a Google, is they just don't think of themselves as playing that editorial role. Now, you can have that debate. Is that a paternalistic way to look at things? Maybe. But it's worth noticing that it's a massive change in the way that we view the world and the way that we consume news. And so that is what we're trying to put contours around. Mm-hmm. And I think it's a fair point. It could well be that we will all be better off. Let us just look at cat videos and we can elect a cat for president and it'll be awesome.
Well, right. I mean, I think you want to push back against, so we're sitting in a room here where the Pulitzer Prizes are judged. And I was in a conversation yesterday, and 2016 will be the 100th anniversary of the Pulitzer Prizes. And we were talking about the role of editorials in the South in the era of civil rights and the role that those ideas, those people who are influential in the marketplace of ideas had, and whether that could happen today, whether the editorial page editor at a small southern newspaper could say to people with a very unpopular idea, right? Because John Stuart Mill said in a democracy, he said, if all mankind minus one were of one opinion and only one person were of the contrary opinion, mankind would be no more justified in silencing that one person than he would be justified in silencing mankind. That's John Stuart Mill, and that's about democracy. The algorithm does exactly the opposite.
Could I respond to that just quickly? Yeah, I just found the "what we see is us" statement in the Facebook algorithm, that just seems incredibly naive. I'm sorry, but I'm shocked by it. Because, okay, I have friends. I have a definition of what I mean by friend. I've just poked Christo. That is not the definition used by Facebook at all. In fact, if I were to use Facebook on my terms, I think what I would do is define a certain small group of people as friends, and then I would read what they said. But Facebook's algorithm, as you said, emphasizes interaction. It really wants interaction, right? And if I define my group of friends carefully, it would be a pretty small group of friends, because that's what I think of as friend. But that's not what Facebook thinks of as friend, because Facebook wants users, obviously, right? I mean, that's really important to them. So the idea that the platform itself is somehow transparently representing what I do is it's sort of an argument. Argument
so that's
against
certainly a
the
straw man
point
and
that
not
you're
one that I
making.
would take. I totally agree with that. My claim is perhaps a little bit more refined than that, which is simply that saying all the rhetoric I've heard has largely been treating this as like attacking a technical problem. And I think that we need to consider it as a socio-technical problem in the way in which we discuss it, or we're not going to make much progress.
Well, I think we are in violent agreement on that, actually.
Yeah.
So let's go to the next question just to give
you.
people more chance.
Hi, well, first of all, great discussion, important discussion, and I think to the point that all of you have been making, any enterprise will require external auditing, external accountability. I guess the job of journalism is always to provide that kind of external accountability, and people aren't always going to do the right thing, even if they would like in their hearts to do the right thing, if they're not going to be pushed, in ways to do that. That having been said, and I'm actually going to disagree a little bit with Michael, There are aspects of this that are a technical problem, and we should be thinking about partly as part of the larger socio-technical problem, how do we provide the tools to people to provide internal accountability? You know, whether the engineers at these organizations think of themselves as editors or think of themselves as providing a public space that's going to be structured in a certain way, that's definitely a huge thing, but they don't even have the tools yet, even if they do think of themselves that way, to do the right thing. So part of that is an issue of scale. I mean, machines are always going to do things at scale that no human being is going to be able to foresee ahead of time, you know, and that's just a reality of operating at scale, and that's always going to happen. But a lot of the features that they're using aren't even the right features yet. So I'm thinking about the Obama thing or this 10-minute window. I mean, 10 minutes is a very measurable parameter, and so it uses a 10-minute window. Does it look at the result and say, gosh, this is not, a person looking at this result is going to say, that's a little bit, you know, use toothpaste. I mean, actually, Obama and toothpaste isn't problematic, I don't think. It's Obama and guns that's problematic. And a person can tell the difference, but of course, the machines cannot yet tell the difference. I mean, there's no filter that Google can put in place right now that will say, maybe not this one, right? And so part of the issue is a technical issue of providing the kinds of tools that will be required to allow people to put in place in the algorithms things to provide internal accountability as they come to understand that that is necessary. So you're doing a good job in helping us understand that that's necessary.
I think that people are trying to build those tools both internally and externally, but it's not easy. So.
Hi, Augustin Chantreau, professor at Columbia in CS, same community as Christo. I have to confess one thing, I'm very, very concerned, but I'm also extremely optimistic. And I would really like Kelly, Julia, Christo, and Christian, that you react to my reason to be optimist and see if, you know, I'm just too naive. The first reason to be optimistic for me is a technical one. You mentioned that these tools are difficult to use, and that, you know, sometimes we find simplistic things. I've been to a lot of, you know, technology wave, and I've always seen that the complexity of the solution increase very fast in the beginning, and then you sort of find the operation that works the best way, and the final solution is simpler. Just this summer, actually, we had a paper that showed that you can run a transparency machine on a lot of different inputs without having an hypothesis in mind at the beginning and find which one are actually the email explaining your ad in Google. I'd love to discuss it later, but that's just one result that shows you don't need to test all hypotheses one by one. That's my first reason. The second reason is a more like societal one, which is I've been working for 5 years in privacy, and I've been working for 2 years on transparency, and the amount of reaction from public policy, the White House, journalists on this issue has been, I mean, 25 faster than on privacy. I mean, we've been fighting, you know, in my community with Christo and other people, how to make privacy, you know, an important concern. Essentially, no one listened. But the day you talk about discrimination, the day you talk about impact on people, then suddenly, you know, all doors open. People want to talk about it, we want to solve it. So I'm very optimistic for that reason. With Julia, we were at a workshop yesterday at Princeton where people from the FTC and the industry and everyone really wanted to solve that. And then the third reason for which I'm optimistic is more like a philosophical one, which is I don't trust a bad, obscure algorithm, but I don't even trust a real person. Actually, I kind of agree with Michael on that, which is that maybe making the web transparent will also make us learn about our own bias. On Facebook, we can actually see racism, you know, really happening. We can measure it, we can fight it, we can reveal it more than on, you know, media where we didn't have measurement. So that's all. That's my 3 reasons. I'd love to see if I'm just too idealistic.
So if you don't mind, I'm going to say yesterday we were talking about the perils of the word privacy, right? And so I have this new thing, which I call it the issue formerly known as privacy, the way that Prince has it, and I have a logo. It's like a little Prince logo. But I think that it's true that the issue of privacy sounds like you're just trying to hide something. But what we're trying to do here is expose what's going on in life. And we have, it's true, better tools than we've ever had, right? This is one thing that's worth noting. We didn't have the tools before to expose at a grand scale. Now, it's really hard work, but there wasn't really a way to break open the black boxes before. We're still never going to know the secret formula for Tide, right? But we might know the secret formula for Facebook's newsfeed, right? We're not going to get it perfectly, but we're going to have a better sense of that. And so there is a great opportunity here for journalism, I think. I share your optimism.
So Augustine's very modest. One of the things coming out of his research group is a tool called X-ray that's specifically designed to determine how sites are personalizing data without a lot of sort of these noise issues and difficult experiments. It's super good.
I'm optimistic. I mean, I think Steven Pinker wrote a book 3 years ago, called The Better Angels of Our Natures, and the argument essentially that is, as human beings, we are getting nicer. We're becoming we're evolving to be more equal and more just as human beings. And I think that's true in evolution. It doesn't mean it's not going to be hard and that bad things aren't going to happen. But ultimately, I think it's an upward progression.
I think we are out of time, and so we may be forced to end on a note of optimism.
It's not such a bad thing.
So why don't we try to squeeze one last question so we can try to get a pessimistic thought in before we close.
Okay, I'm going to try to be eloquent here, but I have so much going through my head, it's hard. My name is Angela Shaw. I'm with PRI.
Pull it down.
Pull the mic down.
And I'm very short. I'm with Public Radio International, and if you guys know my organization, we are the second to NPR, and social media and algorithms have allowed us to grow in ways and compete with NPR in ways I don't think we could have some time ago. But kind of what I wanted to say is that, Kelly, you said one thing about Facebook algorithm not allowing conversations on race. Controversial statements on race means that
not encouraging.
Which is funny because my Facebook algorithm, my version of Facebook, is exactly the opposite. It is full of conversations on race. And if I get a cat video, I'm thrilled. Like I really am, because sometimes they're super fun. And so I guess my question is, we think about algorithms, and I'm a journalist, and I'm thinking about how this applies to news media. We think about algorithms as black boxes. To me, as a journalist, woman of color, working in international news, the mass media editorial process is a much bigger black box than an algorithm. And it's one you can't get into at all. And so I'm wondering if you have any comments on that, because the idea that this is non-democratizing is really antithetical to everything I've learned in my career at this point.
I actually think that algorithms are morally neutral. I don't think that they're democratizing or non-democratizing. They have the potential to do both. And you're absolutely right. I mean, that old model of the editor and figuring out how this group of people in a boardroom make decisions that affect the marketplace of ideas was very imperfect. And still is today. But I think that I think it's easier to figure out human beings and to actually reverse engineer that model. I mean, if you go into any Southern community and you ask African American people who the major institutions of distrust are, they will tell you the police, the schools, and the news media. Those will be their three, and they will And they will say, because we are not reflected, our needs are not reflected in this world. And all three of those organizations are concerned about that, right? They may not know what to do, but you can't go to a police chief or an editor or a superintendent of schools and ask him, and he for the most part would say, I don't give a shit about that. But if you ask them, do algorithms or the people behind algorithms, are you concerned about that? They may not be aware enough to be concerned about it. And if they want to get an answer for it, it is so much harder to hold them accountable than it is. I mean, you can hold the police chief accountable. You can hold the superintendent of schools accountable. You cannot hold the algorithms accountable.
I have to just completely disagree with that, because I think communities of color in America have a really hard time holding institutions accountable. How did Ferguson become a news story on the national level? It was not via these institutions they were trying to hold accountable. It was via Twitter and Facebook. I mean, national media didn't pick it up.
Well, no, but that's actually it was via Twitter, right? It wasn't via Facebook. It was via Twitter, which was not operating on an algorithm at the time. So it was very, very angry, loud voices on Twitter, but it wasn't an algorithm at that point. Facebook's algorithm pushed Ferguson News down in a way, maybe not on your news feed, but you're the exception. You're the exception to the rule, though, in terms of human behavior.
I don't think so. I think I'm a person of color who's interested in issues of race, and that means that Facebook will not push it down.
Yes, for you, because it's learned your behavior, but for most users of Facebook.
I
guys, we're gonna
I think
have
if you
to,
talk to a black user of Facebook, their friends are talking about this, and it moves up.
Right. I think we are in agreement that the algorithms are showing you different things. Christian.
I mean, it seems like this issue here is just a matter of the division of labor, right? So Facebook doesn't need someone to get up here and tell you that Facebook is really awesome and it's great and that you should use it because you're probably already using it, right? So the celebration of the great things that the internet does for us, I just don't consider it to be my job. So I'm not saying that the internet isn't great and I don't like cat videos. And when we say that algorithms should be held accountable, we don't mean that all algorithms suck and that we're against computer science and we're really mad at them. In fact, as the saying goes, some of my best friends are computer scientists. I mean, really, so I think it's just a matter of what's the role. Our topic here is accountability journalism, and so I think this is a really important domain for accountability journalism, and to say that isn't to deny that Mountain View is a delightful chocolate factory, all right? So it is, and I like the internet, and I can't believe I have to say that, but holding algorithms accountable seems to inspire a certain, I don't know, even defensiveness among the engineering community particularly, and I don't think there's any cause for it.
Right, and I think that it's worth reminding everyone as like a final note, which is the calling card. The first thing I learned in journalism is if your mother says she loves you, check it out, right? Our job is to check it out. These algorithms may well all be 100% awesome. We are in the business of testing that assumption. So we're going to have to close it. I'm so sorry there were more questions, but we are over time.
That was great.
Hey. Yes.
Very familiar. Have you presented or distributed it?
Hello again. So we're a little bit, well actually we're significantly behind schedule. Welcome to a 9 a.m. start time for a conference in New York City. But why don't we take, instead of a half an hour break now, why don't we just take a 15-minute break and come back at 1:45, and then we'll make up at least part of the time. So 15-minute break.
So folks, I'm Bernd Giraud from Stanford University. I'm an electrical engineer who has worked in media technology for a long time. Very happy to chair this session. I should probably also, for those of you who don't know this, I'm also the director of the Brown Institute at Stanford University. Probably know that the Brown Institute straddles and connects Columbia, the journalism school, with the engineering school at Stanford. So our session, late morning session this today is about visual content gathering and creation. And we have two excellent papers. The first one is going to be about the feasibility of using small unmanned aerial vehicles for mapping news events. And Ben Kramer is going to present this paper. You know, let me say a few words about Ben. Ben is based in Nebraska, but he travels the world, and I think in the last year he spent most of his time in Africa and India, and I think you're going to tell us a little bit about why that is. He's interested in using drones for journalism, and these are parts of the world where you actually can do this, and you want to do this. So, you know, Ben has a lot of interesting things that I could talk about. I just mentioned that he's also been a DJ for quite some time. So he's basically, you know, he's a Renaissance person, a maker and an artist, and Ben, we're really looking forward to your talk.
So I work with Matt Waite at the Drone Journalism Lab at the University of Nebraska, and he could not be here today because he's giving a TEDx presentation in Omaha, Nebraska. So it's just me. So a little background, the Drone Journalism Lab is the first drone journalism project to come into existence at an academic institution in the world. And the premise is pretty simple. We are interested in the ethical and regulatory and practical applications of drones. So we've got this blog where we get out of journalism and drones and talk about drones more broadly. Matt is the primary contributor. And we've been doing this since November 2011 when he started the lab. I joined up in January 2012. Anyhow, my focus is on flying and buying and building and making drones. So I spend a lot of time out in the field and doing projects with various organizations, which I'll get into in a little bit. I do take primarily off-the-shelf drones and modify them as needed for the projects that I'm working on. So the first project that we did, and this was kind of a turning point for our work, was back in October 2012. We did a project about drought in Nebraska. And it was significant because it was a proof of concept for the lab, for drones and journalism. It was a news package, video package. And what happened, in July of 2013, we got a letter from the FAA saying we're not allowed to operate in the US doing our drone work, basically. We cannot fly. We are a public institution. Therefore, we are part of the government. Government entities can fly drones, but only with certificates of authorization, which we had not applied for. So, since a little more than a year ago now, I've been leaving the US regularly and doing things for the play, like this. I was in India for 6 months working on a film, Fulbright film, the documentary, and went to Kenya back in March. So that's where I've been more or less based in the past year, doing projects with African Skycam, going on drone safaris, working with CCTV Africa on projects, African Wildlife Foundation, basically operating in places where I can actually fly drones and publish content and not worry about getting in trouble. So I got back to the US in April and wanted to do another project, obviously, outside the US. The Antioquia ad Cragum Archaeological Research Project got in touch with me and Matt, asking if we could come to the dig site in Turkey to do some aerial imaging. Located on the southern coast, you can see Cyprus from the dig site. I was invited by the guy on this boom here, on this fire truck, Michael Hoff. He's the director of the project. And he's up there taking photographs of a 1,600 square foot mosaic. Now, he was doing this in 2012. At the time, I was actually working at the dig site as a student, just digging. And I saw these photographs after I left, and I realized, he could use a drone to do this. This is kind of silly. And when he was talking with us, when he was proposing that I come over, he told this story about how he had been suspended by some kind of piece of heavy machinery. So he had this chain harness, and he was being dangled over, there's a temple on the site. He was dangling over this temple, trying to get these photographs from above, and the chain snapped and he fell on his back from about 30 feet. And surprisingly, nothing happened to him. But after that, he realized he can't do that anymore. It's too dangerous, and so he needs to find another way to get photographs from above. So he wanted stuff like this, and like this. Basically shots that he either could not get without an airplane or some other flying machine, or shots that were just far too risky for him to do. Shots like this. And then the mosaic was really a focus, just because this is the largest Roman mosaic in the region. And a little background on the site. It dates back to, there's a temple on the site that dates back to about the 3rd century AD. So this is, it's an old Roman city. And before that had actually been sort of an enclave for pirates. So it got incorporated into the Roman Empire because of the pirate problem, because they were raiding Romans nearby. So what Michael Hoff was not expecting was for me to do this. And I'm going to jump out my presentation here. So I wanted to do more than just take two-dimensional photographs of the dig site. And so the logical thing was to create three-dimensional models of the excavations. So what we've got here, and it's kind of blurry on the projector, unfortunately, but basically this is the mosaic. I took 249 images, stitched them together in software, this here, PhotoScan, and created this model. Now the way this works is, if you look at these blue rectangles, they are, each one is a photograph. And so what I do is I fly the drone in a very systematic fashion, where I'm kind of doing this lawnmower pattern, back and forth, back and forth, back and forth across the mosaic, flying at about 1 meter per second. Each photograph, if I could rotate here, each photograph has a lot of overlap. So the photos, they're taken pretty close together. And the idea is that when I take enough photographs of an object or an area, I get all these different angles of the object or the area. And I'm able to then, in the software, create a three-dimensional visualization of that object or area. And as you can see here, it works. It's kind of, the software is a little bit cumbersome, so it's not, this is not sort of the deliverable, but you get the idea. Okay, so the way this was done was with an off-the-shelf DJI Phantom 2 carrying a Canon camera. Now, I have to point out, I used an L bracket and some hardware and a bottle cap to rig it up to the drone. And at first I thought this was kind of an embarrassing aspect of this work, but it's not, because it worked. And it was really simple, and it was really inexpensive. And reusability at work. What's that? Reusability. Yeah. So, and this is how I operate a lot, is cheap, fast, whatever works. If it gets the job done, perfect. And this did. So anyway, this is the camera. It's special. It's got a built-in GPS. So each photograph is tagged, which helps in the assembly process when I'm making the models. I use Canon Hack Development Kit, CHDK firmware, which is a great open source firmware system which you load onto an SD card. When you flip the little lock switch, the firmware engages. So basically, it kind of opens up your Canon camera and allows you to do a lot of things that you can't do with the stock firmware. So here's just a screenshot of the camera. And I mean, you can take raw photographs. It gives you an intervalometer, which is crucial for what I do. Because when I'm flying and taking those periodic photographs, I'm taking periodic photographs, the camera's running continuously while I fly. So it takes a photo every 2 seconds, which is the fastest I can operate with this piece of firmware. And without the CHDK kit, I can't do this work. I use DJI's ground station platform, which basically runs on an iPad, and it lets me map out my waypoints, my transects, which look like this. I forgot how to do a screenshot on my iPad, so this is a literal screenshot using my phone. But you can see, those are the transects. You can't really see the mosaic underneath, but that's the pattern that I do. That's basically how you do this mapping work. And you fly slow, and you fly as low as you can. So I was flying at about, 20 meters, so 80 feet approximately, or higher. And it worked. So like this is a low view of the mosaic from the model. Okay, so I wanted to apply this in a more journalistic context, this work. Well, wait, okay. So I just got back from Nairobi, third time there since March, doing a story for Vice News about this dump. It's the Dandora dump site, the largest in East Africa. It's about 30 acres in area. And there's a journalist from Vice who's doing a story about the dump, doing a video documentary piece, and wanted me to come and do stuff like this. He wanted me to shoot video and get aerial perspectives to get the scale of the dump from the air. And that was no problem. But I told him that I'd been doing this mapping stuff, and I thought, could we make a map of the dump and a 3D model of it so that people could actually explore it from their computers in addition to just watching these videos? Because my drone work is all about capturing new and interesting perspectives that were not possible before. So this stuff is very relevant in that regard, but so is this modeling aspect. And that's a trash cyclone right there. So you can't capture that in a three-dimensional model, but in video, it's interesting. Okay, so now we'll jump over. Now there was a problem here. So that mosaic that I imaged, it was about, let's see, I wrote it down, 100 feet long. So it's pretty small. So it's pretty easy to fly back and forth and to get the shots I needed in a fairly reasonable amount of time. It took about an hour and a half from setup to pack up. But the dump is 1 kilometer long. And so I needed to process a lot more data and a lot more images. And that mosaic model that I showed you, it took about 8 hours to do on my MacBook Air. Now, for the dump, I had to fly high and I had to fly fast because I had so much terrain to cover that I couldn't fly really slow. And plus, people were throwing trash at the drone, and there were a lot of potential problems. So I needed to get the job done fast. But I also got a lot of images, like about 570. Now, I wanted to do a high-resolution version of this model because I didn't have those nice low-altitude shots to get detail. So in order to process it like I wanted to on my MacBook, it would have taken 200 hours. And so I didn't have access to a really powerful workstation, so I thought, why not use Amazon Web Services? So I loaded up an instance on AWS, and it's got two processors, 2 Xeon processors, 32 cores, and 244 gigabytes of RAM. That's great. My MacBook is one single 1.7 gigahertz processor, 8 gigabytes of RAM. It's slow. So basically, I've got a really powerful workstation here that I've been working with remotely via AWS. And I was able to create this giant model of the dump. And so here you can see all the photographs that were stitched together. And there's the dump. And even with all this computing power that I'm operating with remotely, it's still, as you can see, it kind of lags when I move things around. So I'm going to jump back over to my air here, where I've got a slice of the dump. Okay, so here's a section. So we can zoom in now, and, well, here it is. So to point out, yeah, you've got kind of these weird distortions in areas. That's, once again, that's just a result of flying high and flying fast. But the dump this is what it looks like, and you can zoom around. You can see the big yellow trash bags from Kenya Airways. You can look over here. This is a school right next to the dump. Got the Nairobi River. And there's another school over here too. Schoolyard's right over here. And then we've got, this is housing here. People live at the dump. Slum housing. We were right up here flying from this point. So it worked. There are some kinks that I'm still working out. Like I said, I just got back a week ago, and I'm not sure yet how we're going to deliver this online, but there's something that has been working, and I'll show that next. And it gets into where I want to take this modeling stuff. So we've got these models in PhotoScan, but now the question is, how do we get it out to the people? On my website, we've got this, Sketchfab. What it does is allows you to upload your three-dimensional models to the internet. So it looks like it does in PhotoScan, where you can rotate it all around, which isn't great, because there's a lot that you don't need or want to see, but you can do things like this. You can zoom in, you can set annotation points. So I've got mosaic detail here. This is the frigidarium. This is a cold pool where people go during it's a Roman bathhouse, so it's part of the bathhouse process. I can zoom back out. Now I'm in the pool. This is my favorite mosaic detail. And then you can repeat. And then you can also, you should be able, you can navigate around like you can in PhotoScan. So you can do your own exploration, which is where I want to take things. So with the drone video, you can take viewers on a ride through a dump or an archaeological dig. But by creating three-dimensional models of an area, now you can actually give people the opportunity to explore areas themselves. And the issue becomes, how do we get these giant gigabyte-sized models online and compressed in such a way that you don't lose essential details, but that'll get worked out. So this is where we're at right now, and I think that there are some interesting things that will come in the future doing this process. And it won't be applicable to all, there are not a lot of applicabilities, not a lot of situations where it's going to work, but there are some where this will really add something to stories. And I think with this dump story that we're doing, when Vice releases the video and the map, and also these models that I've been doing, I think it'll add something that wasn't possible before. So, thank you.
So again, I'm from NYU's Center for Urban Science and Progress, and we study cities. And I think what you've done here is fascinating in that you've managed to digitize video content. My question for you is, how do you see this as applied? And you're probably already doing it. Is that one of my suggestions is to focus on slums and map slums almost on an ad hoc basis so that you can deliver resources. In crisis response in the slums of Mumbai is something that's non-existent. And I think this could apply perfectly there. Now my question is, how much of this modeling stuff can you convert into a queryable data set? So if I were to say, I want to see a particular category of the environment, can I do that using this software?
Yes, so there's a lot more that you can do. So with Photoscan specifically, you can plot, okay, so related to that, you can make spatially accurate models that are accurate to within millimeters. And the way you do this is by plotting points. Now these points are generally used as, I guess, spatial indicators. So you would say in the software, okay, this point is this far away from this point, and then the software can process all that, and then it can help sort of mold the model to make things really accurate. But what I'm thinking is, and I don't know specifically how to address what you're asking, but I think that you could apply these points in sort of this other fashion where you could plot up points on a model or just on a regular map. I've been doing that too, just a two-dimensional map of an area that's been stitched together from hundreds of images. It's not as interesting as this, but you could either in either fashion, I think you could do that, where you could plot points, and then I don't really know how far you could take it. So my answer is I'm pretty sure. I don't know how to do it yet, but that's a really good idea and something that I'm going to explore. So thank you.
Thank you.
So next speaker is Unaisa Asan. She's a second-year PhD student at Georgia Tech, working with Irfan Essa. And Unaisa's paper is going to be about story visualization from social media, or I should say social multimedia. Yes.
Hi, everybody. This talk is about our ongoing, oh, I'm sorry. Yes, it is. See? Oh, right. Sorry about that. So hello again. This talk is about our ongoing work where we're trying to investigate how to aggregate social multimedia content for story visualization. This work is applicable to the journalism domain in that it can provide a structured view of social media images publicly available and reusable online. Today, content creation on the web involves not only text, but increasingly images. The more powerful the image, the more that content is consumed and shared. Oftentimes, images tell a bigger story than the text around it. And with the decreasing attention span of consumers over time, images can actually play a greater role than text, for it is not really easy to skim an image. The screen grab here shows the multimodal nature of digital content. You have a title here, an image, and a story. The title and image by themselves can convey most of the story. This image, among others, was captured by two photographers, John Moore and Mohammed Al-Shami, who traveled to Liberia, West Africa, to capture images of the effects of Ebola virus on the people. Now, I read 2 lines below this image, and there was a lot of lines below this image, and I got the whole story. That Liberians traditionally do not cremate their dead, and now they have to cremate them to prevent the outbreak. So to cover a series of events that happen at a particular time of the year, such as Christmas events, at a particular place, such as Chicago, a content creator may enter this search query in an image search engine, such as Google Images, and obtain a result that looks something like this. A large collection of images with no clear indication to which event do these images belong to unless you manually click on each and every image and go to the text. Another example can be of a content author searching for protest events happening in a particular place during a certain year, such as protests in Egypt during 2013. And again, the image-based search results would give you a large collection of images in grid format where you will have no idea how many events are actually depicted within this large grid. Now, before it seems as if I'm undermining the importance of text in the news stories, let me clarify. I'm only talking about specific scenarios where content authors might want to include images of events that happened at a particular time and place. For that, if they do search for public images that are taken by people who were present at the event and uploaded those to social platforms such as Flickr, they would appreciate a search result which would show them groups of pictures, not just a large collection of pictures in grid format. So just to reiterate, our goal is to automatically aggregate a large number of event images, such as these, into unique social events. And that brings us to the important question. What exactly is a social event? Now, in the social computing literature, as well as in the NLP community, an event can have several different meanings. But for us, the event means the traditional thing, a gathering of people who organized that gathering and they attended it, they took pictures of it, and then they uploaded it on social platforms and they shared it publicly. So we formulate this as a multimodal clustering problem, where the first modality is the image itself, the image content, and the second modality is that of text surrounding that image. Fortunately, nowadays when users upload images on social platforms, they are given the option of entering information about the images that they're uploading. And that brings us to the importance of tags and titles and descriptions. Sometimes we have the location as well and the usernames all surrounding the image. So this event image is a protest event from France, and I've taken this from Flickr. It was publicly available. It clearly demonstrates that along with the image, we have a rich set of information. So now that we have established that we have 2 attributes of data, that is the image and the text, we can approach this problem as follows. We can extract features from these 2 attributes and learn a reduced representation of the features. What do I mean by reduced? What I mean is that real-world data, it is of very large dimensions. Images and text you can imagine. So now if we have a reduced dimensional space, that means that we have performed some kind of dimensionality reduction to obtain that space. And now we can perform clustering within that space to obtain unique social events. So I'm showing here a very standard diagram of dimensionality reduction using PCA, and the direction in which this bunch of data points, they vary most is depicted by this long blue vector you see on the diagram. And when you map the data points onto this long blue vector, you get a one-dimensional space. So you've kind of reduced the dimensions now. The technique which we use in our approach is not PCA, it is CCA, that is Canonical Correlation Analysis, a standard machine learning technique which was originally proposed by Harold Hotelling in 1936. The basic principle behind CCA is that it transforms pairs of multidimensional variables into pairs of reduced dimensional variables. In PCA, we were only transforming one variable. So we had a bunch of points, x1, x2, x3, x4, etc. Here we will have x1, y1, x2, y2, x3, y3. like that. And so intuitively, you can imagine why we're using images and text. So we have one dimension and the second, one attribute and the second attribute. The criteria which is used to reduce the dimensionality here is not variance. In PCA, it was variance. In CCA, it is correlations. So we're maximizing the correlations between the projected data points. So similar points are going to come closer together because they're more correlated with each other, and different points are going to go further apart. So this is the high-level diagram showing our proposed approach. We first compute the visual features from the images, then the textual features from the text surrounding the images. We transform these two feature sets via kernel canonical correlation analysis. Before I said CCA, now I'm saying kernel CCA, and I'm going to explain why we're using kernel CCA here, and then in a bit. And then in the reduced feature space, we perform standard k-means clustering to obtain unique social events. So here I'm going to show a detailed approach, the detailed approach. These are a bunch of images and the tags that are depicting what the event shows in the image. We compute both the visual features and the textual features, and X and Y just show the feature sets. Now, real-world data sets are highly nonlinear, and CCA alone is a linear technique because it gives us sets of basis vectors on which the original data points are mapped. So we have to do some kind of nonlinear transformation, and that is what I meant by kernel. We kernelize these features, map them on a higher dimensional space, and then we perform linear CCA on that space. And the kernels we use is Gaussian kernels because they're very simple to use and a good starting point. So we use kernel CCA, transform them into the space, and then finally we get the learned space with fewer dimensions, and you can see that similar shapes have come closer together. The color of the shape depicts where the features are coming from, whether from images or from text, and now we can perform clustering in the final learned reduced space. The alphas and betas that you just saw appearing, they're the learned weights, and one important thing you have to note is that in the above two X and Y's, the dimensionality is running to N, which is a higher dimension, and in the alphas and betas, the learned weights are going only up to D, and D is always less than N. And the omegas you see are the actual projected data points. Now the data set we're using is provided by Media Eval, a benchmarking initiative. Basically, they hold a bunch of challenges each year where they provide social media data and they have challenges. So the challenge that was most relevant to us was the social event detection challenge, and they provided us 300,000 images. They were all annotated. From 2006 to 2012, I think they crawled Flickr, and along with the image, they had the whole feature set like tags, titles, descriptions, etc. We also had metadata. So we had usernames, we had dates and times, timestamps, and we had some geotags as well. But in these experiments, we did not use geotags at all because first of all, we had missing geotags, and that was the first reason. And another reason is that geotags are not really reliable. And even if they give a course location, such as a convention center or even Columbia University, you can never get the particular events from that because multiple events may be taking place within the same location. So here are some sample images from our data set. Some experimental details. We compute the image features by computing SIFT descriptors on the image. And we use the standard bag of words model on 30,000 training images. The motivation behind using SIFT, which is a rotation and scale invariant image descriptor, is that if you have images like performers on stage in varying poses, SIFT can reliably match these kind of images. However, relying on visual content alone will not be useful in this scenario, where you have pictures taken of food and pets and interesting door signs. Now, one may argue that these images are kind of irrelevant, and even if you eliminate these images, you still have images of the events. But the thing is that if in real data sets of hundreds of thousands of images being uploaded daily on social platforms, how do you automatically eliminate this kind of images? How can you classify an image as random? You can't. And this doesn't have a very clear answer, by the way, because there may be events where people want to know what kind of food was served there. So we have treated all of these images with equal importance, and we want to find all of the images that depict a particular social event. Hence, we will use textual data and metadata with these images. How do we do that? We compute term frequencies on the usernames and dates and timestamps. There are users who have uploaded multiple images, so we have multiple usernames, hence we compute the term frequencies. We also compute TF-IDFs on the titles and descriptions, as well as tags. We treat titles and descriptions as one, so whenever you see text, that means titles and descriptions, but tags we treat differently. So these are the parameters that we have to tune for our experiments. We have the Gaussian sigma that varies the width of the Gaussian bell curve. We also have the number of canonical variates, D, the D that you saw, the number of reduced dimensions. How far do we need to go to get a reliable reduced space? And we also vary the number of clusters, K. We evaluate our clustering algorithm using normalized mutual information, which is an information theoretic measure. So here are our results. As you can see from this table, we have performed experiments with several combinations of features, and we have tested which attribute will give us the best clustering performance. Also, the reason why we chose to use like one textual feature at a time rather than combining all of them was that we wanted to see how much noise each one adds to the result, and we will only take that attribute which gives us the best result. So the actual finding was that the attribute combination that gives us the best clustering score turned out to be usernames and tags. Now, this is not something which we could have predicted in advance without running this kind of experiment. Intuitively, I'm going to talk about tags first. Intuitively, tags would be a great source of information because it is very easy to add tags when we are uploading an image rather than enter long sentences describing the image. Tags are just a bunch of words. But usernames, that was a big surprise. Then we figured out that users will only attend one event at a time. They cannot attend two events at a time. And then if they're uploading those images and they're also adding the tags, and you're combining usernames and tags, you're bound to get a good result with usernames and tags. The more interesting result from our perspective, coming from a image processing and computer vision background, was the second best result out of this, which was visual features plus usernames. So we had just used SIFT features with bag of words. We had not used any kind of color features or combinations of features. So we saw a huge potential in this result that we can compute further improved features, visual features on these images and potentially get an improved result. So with these experiments, we learned a reduced representation of social event images, modeling both the visual content and the textual content around the images. We also learned that visual content alone will not give us the best result which we need, and hence textual data is also an important indicator. We also discovered that the most useful features turned out to be usernames and tags. Improving visual features is an important next step for our experiments. So concretely, we want to scale up our work to millions of images. Right now, we're using only 100,000, but for this experiment, and we had a data set of 300,000, but potentially we want to reach up to millions of images and carry out further experiments. And then we want to combine more visual features beyond SIFT, which I just mentioned. And the third thing we want to do is has three important application areas, which is that once we have this reduced learned space, and we have one source of information, but we don't have the other source of information, we can use the space to find the missing source of information. What I mean is that if we have an image, we don't have any tags, we transform the visual features of that image into the reduced space, do nearest neighbor search, and retrieve the relevant tags. Similarly, if we have tags, but we don't have images associated with them, we can transform the tags into the space, do cross-modal retrieval, and retrieve nearest neighbor images. And finally, we can also classify an image into a particular cluster, and that would be event image classification. Thank you.
Okay.
Thanks for a very clear presentation. I'm just wondering that I remember some work from Cornell Tech, Columbia on event detection. I think maybe some authors are even in the room. Can you tell us how it's different?
Was it social event detection?
I think it was event detection.
Because
on
I've
social
heard of
media.
many different event detections actually.
Okay.
In Twitter, if you have a sudden spike in the number of tweets, that's classified as an event. So event detection in textual domains is there's a lot of work that's done there. This is particularly social event detection that's done there. I'm not familiar with which event detection you're referring to, so.
Okay, we can discuss it offline, but
Sure.
it's about this particular same definition. So
Okay,
no problem.
sure.
Yes, let's see more in the back of the room, and there's probably an interesting discussion also with the type of social event detection that your team has worked on, and that, for instance, has been used in the City Beat project that the Brown Institute funded here. Related to that, GPS and time stamps is not something that you have access to in your data set? I mean, those would be very obvious.
Obvious, yeah. So Media Eval only provided geotags for 1/4 of the data set, but even if they had provided it, there are multiple events happening at the same time. That was a problem. So there are many similar dates and timestamps which we see in our data set. Furthermore, they're not a reliable source of information, because if the camera is showing 1980, and it does sometimes if you're not setting the time correctly, then it's not much use. Thank you.
Katie, can you come up already? So while Katie is setting up, let me just say a few words about her and her paper. So this paper is entitled Data-Driven Cartoons, a procedural experiment in provocation and civic participation. Katie works here at Microsoft Research on 6th Avenue, and she's previously been with Zynga for a couple of years, and I think you joined Zynga through an acquisition of a company where I learned you were employee number 1. And so this company was area code with a slash between the two. But I guess that's now ancient history. So Katie's in the Fuse lab, and we're looking forward to your talk.
Thank you. Slight height difference between the two of us. I'm just going to lower that a little bit. Let's see, I hope you can hear me okay. I'm a little sick today, so sorry if my voice is odd. So I'm going to talk about this paper. It is something that I did with help of Shelley Farnham and Michal Lahav, who are, Shelley's another researcher at Fuse, based in Redmond, and Michal is a user research tester person who works with us as well. And just by way of background, this connects to a larger body of work that I've been exploring probably for at least a decade, that is looking at bringing sensor and network data to life using character design, relationships, and emotions. Oftentimes this has involved games. So on the right, that was from a game designed for the UK government for 9 to 11-year-olds that used real-world traffic data to control monsters in a massively multiplayer online game for kids. In the center is Botanicals, a plant system I designed, a network sensor that allows plants to make phone calls or use Twitter to say what they need and get humans to respond to them appropriately and thank them and be polite and stuff. And then all the way in the, I guess you're right, sorry, is that's a satellite and pop-off tag on a shark's dorsal fin, which we use the data from to control sharks in an online game for the Discovery Channel, in which you played a virtual marine biologist. So just to give you a little bit of my context, I'm less of like a rigorous academic and more comfortable making entertainment. So in the space of civic engagement, I've also done a series of games in civic engagement for governments and foundations and stuff like that. But for this particular project, we're looking at driving civic engagement and looking at opportunities for people to engage with hyperlocal data about their neighborhood or their community in different ways, and how we could use network data to generate those kinds of opportunities. So, you know, there's a convention of cartoons, political cartoons, social cartoons, news for years and years and years. Honoré Daumier, all these folks in all kinds of cultures have been using cartoons as a way to provoke, either using satire or what have you, to get you to engage with issues of today. So like, for example, yesterday, I don't know if any of you saw this, obviously the New Yorker, for those of us who live in New York, I'm based in New York, the New Yorker cartoons, and you know, we had our first Ebola patient and blah 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 blah. But you know, I think it's interesting because it's also about when you're trying to create a new experience or a new interaction paradigm, finding the convention that people can recognize. So as much as you're introducing novelty and new experiences, there's also a real requirement for somebody to sort of like be able to step into your weird world. And the Sunday cartoons are certainly something that across socioeconomic demographics is pretty accessible. Okay, so under the hood, getting to this project, which is called Here New York City. Under the hood, there's another system that I built since I joined MSR, which is called Project Sentient Data. And that's really, it's a server and REST API. And the idea is it's a system to take complex real-time network data or third-party APIs, any kind of data stream, and process that for a more human-readable output. That's kind of the goal behind it. And you know, the admin UI looks like this, but really like the goal here is like to challenge designers and developers and myself to think about data in terms of relationships, personalities, and emotions, and what kinds of new products and services and interaction paradigms emerge when that challenge is posed and when there is a system to be able to experiment with that. So like what you see here, this is kind of under the hood for Here New York. The system basically enables you to create entities, or if you've ever played a game, a video game that has non-player characters or NPCs, a kind of non-human character that reacts to you and responds. We create something called an entity, which is essentially a character. You can assign it a personality in our system, which there are default personalities in our system, but you can also design your own personality. And then entities have relationships to different measures, AKA data streams. So in the case of Here New York City, we broke down New York City into 42 major neighborhoods throughout the 5 boroughs of New York, and for every neighborhood there's a personality assigned to it, and they have a relationship to about 200 different data measures. And then based on that neighborhood's goal or hope for where that data measure is, there's a calculated emotion. So here we're seeing this calculated emotion is happy, and the triggered reaction rules are because the data is at the place in which this particular neighborhood is happiest. So we're looking at Southeast Bronx graffiti reports. These are complaints. It's on or below 1, and that's where this happens to be. So the neighborhood's pretty chill right now, just to give you a sense of what's under the hood. Functionally, it's like this. On your right, there's the sentient data server that can be running on the desktop or on a Raspberry Pi if you want, locally, physically in a space, or in the cloud, and it has that admin UI that I just showed you. You can have an application server that's connected to that might be running a phone app or a web app or some physical thing in space, and then you're sending through raw data. Again, this could be sensor data, this could be a third-party API that you're grabbing. Data goes through to the sentient data server, is processed there, and pushes out calculated emotions that are tied to entities that you've defined as a designer or developer, and then that can drive any kind of interaction. So, for example, I have a prototyping group at NYU, and some of my students have built things like self-aware street signs that talk to you, or networked city bikes that have tails, and they might wag if it's the second time that you're coming to ride them, or they play music based on how they feel, but they're really trying to distribute the bikes throughout the city based on, you know, where there's less bikes at different hubs. Just to give you a sense of some of the interactions. And I've walked you through this, so I think you have a sense of what the interface looks like. And on the right-hand side, we, or I don't know, left or right, sorry, but all the way over there where it says event, it'll give you sort of like the background of why this is being calculated. And this is really meant for designers and developers to just sort of like quickly dump in any data set and get a sense of what you might get out of it. Also to tweak it and then see if they want to use it. So it's, yeah, really taking multidimensional information and using characterization as a single vector to communicate and interact with it. So for here, we're looking at translating a New York City public data set, specifically complaint data. So 311, anybody in this room not know what 311 data is? Oh my gosh, thank you. That's so nice. Okay, so good. So we take that data and we're using that to generate a kind of weekly neighborhood cartoon. Right now, first of all, I'm a big fan of the New York City 311 app. If you haven't seen it, it's fantastic. We're not trying to do anything like recreate that. But you can track your complaints if you've made them, and you can, whatever, easily see the answers to the most commonly asked questions. But if you want to see the aggregate data and you want to get a picture of that, for the most part, these are kind of your go-to sites, which are not that user-friendly and are not necessarily that well known. And maybe it's because it's a boring data set and people don't care that much. I don't know. But if you look at it, you can go down, drill down to like the address level of complaints for specific, all over the 5 boroughs of New York. You can also sort it by categories and that sort of thing. And then the city reports on their performance. So that's kind of where you would see any aggregate data. We wanted to give ourselves a challenge of like seeing if users would retain more hyperlocal data when there was an emotional component to how it's communicated versus looking at a chart or a graph. If we could invent new habits for interacting with this kind of data about their neighborhoods, and which neighborhood issues were citizens interested in sharing and getting involved with, if they were kind of getting this stuff coming at them. And what happens when you put civic data inside of cartoons inside of Instagram. So this is the system that we ended up building. This is the home page. It's a responsive website, so it works equally well on your smartphone, your tablet, or your desktop. And like I said, we have 42 different neighborhoods in New York. It kind of functions like a Sunday Comics. It's a single frame cartoon that's procedurally generated for each neighborhood. So the Lower East Side for that particular week had most issues with disorderly youth. Bed-Stuy and Crown Heights had some bus stop challenges, and the Upper East Side was having improved noise complaints. It's really meant to be a glanceable provocation. Below, we summarize the call volume or the complaint volume, and also by category, we show you a glanceable view. We also have a leaderboard, and the speech bubble at the top, that's also hyperlocal trending tweets for your particular neighborhood. It's not really meant to be a website where we expect people to come to, though. It's mostly was designed to be distributed through email subscription, Instagram, or Twitter. So each of the neighborhoods have their own Twitter account, so it's very lightweight. The idea is to be lightweight and slightly provocative and see if that peripheral entertaining engagement changes the way people either relate to, care about, or get involved with their neighborhoods. And then we also give people the opportunity to go deeper, so if they click through from those cartoons, either on any one of those subscription platforms or on the website, they can dive deeper. So here on this side, we have socioeconomic and crime statistic data for that neighborhood to give you a sense of the context. We have 2 comparisons tools to see year over year for your neighborhood by complaint category or overall all categories, and also the opportunity to compare your neighborhood to the average for New York City or specific neighborhoods. And then below, we do stuff around volume, and a year ago today, what was the biggest issue? The idea being glanceable ways to sort of get a sense of this and see if anything's intriguing to people. And then below all that, there's this get involved thing where we suggest that people might want to contact their community board or get involved with an advocacy group, that sort of thing. And that was sort of the frame. So, and like I said, not really designed to be like a website where we want people to come and hang out in. It was really meant for things like this. So this is our Instagram account. We share these photos once a week for the neighborhoods, and this is what Twitter looks like. So if you live in the Lower East Side and you follow our Lower East Side account, you would get weekly one kind of summary status with a link to that page and the cartoon. Same thing for Bed-Stuy. And this is what the website looks like on mobile. And just in terms of how it works functionally, I don't know how technical this group is or how interested you are in this, but the idea being that we get the data from 311 from the city, process it through the Here server so that we can kind of normalize that into our canonical complaint types, then send it through the sentient data server where it's going through the personalities for each neighborhood and the kind of acceptable norms for those neighborhoods based on 3 years of data, and then generates kind of emotional reactions. Then on the other side, we look at the cartoon generator. The cartoon generator is using a set of cartoon recipes that were created with cartoonist Iris Gottlieb and myself. And the different attributes, so the emotional response, the particular neighborhood that we're talking about, what the complaint type is, these sorts of things. And that ends up generating a set of potential cartoons that then a cartoon editor selects from and then chooses to publish across distribution channels and on the website. So that's sort of how it works. We did an initial short study, and which we don't have all the results on, but we did do get some feedback from people about what things they found most interesting and engaging. It's interesting because we did this at the beginning, and the beginning was definitely people were really psyched about the demographics, socioeconomic demographics, and the tweets and stuff like that. Later on, what we found was that people much more appreciated the cartoons. I think also when you have a first-time experience, you're seeing a lot of data, but if you're having a light peripheral experience on an ongoing basis, it's something new that's timely, that's more relevant. So that was interesting to find out. But we did see this sense of increased empathy and sense of being informed. So even there was one of the study respondents was a teacher, and she would print out, even though she said she didn't like the service initially, like she used it and printed out cartoons and would bring them to teachers that would use them in her classes to talk about issues that were going on in the neighborhoods, and also used it to find out about the neighborhoods in which her students were living in to sort of get a better sense of their what they were dealing with both outside of school and in their community. So that's sort of a quick summary of here. I don't know if you guys have any questions.
Hi, great research. Short question. The 311 data, it reflects bias from where I come from, in that it's if you have a person who likes to complain a lot and is an old person, it kind of tends to skew the mood of that neighborhood. So
Bias.
how do you actually, I mean, this is a beautiful, engaging way to get people engaged in civic data, but how do you, do you have any thoughts on how to get people to report or maybe get more serious issues through this interface of comics, and maybe, you know, let people report more serious stuff through the comical interface?
Yeah, I mean, I think, well, two things. One is our goal was not to have people report more to 311. The other thing is that we didn't presume or pretend to say that this was ground truth. 311 is human beings as sensors, and human beings have the challenges of, like, will this matter if I do this? Do I have time to do this? Does it matter that there's dog poop on my street? Oh, for me it does. Oh, for me it doesn't. You know, so we were as much interested in people contesting the data and getting involved in accurate representations and, you know, the idea of self-efficacy in communities, as much as we were in sort of representing the data. I think there's definitely opportunities to do provocative stuff, and certainly other data sets could be very interesting to do that with. Yeah.
Thank you.
Yeah.
This is great stuff. Could you tell us a little more about the cartoon generator? Like 30 seconds?
Yeah, yeah, so Iris was, I would like to highlight Iris Gottlieb, who's a great cartoonist that we worked with, and it's very much recipe driven. So aspects of the recipe include the frame, which is specific to the 5 boroughs of New York. The speech bubble, the type of speech bubble that's drawn is one of the items in the recipe. The text, the images, there's scaling that happens, there's juxtaposition. So we'll have multiple, currently, because this is kind of like a quick prototype, we have multiple recipes for each type of emotional response to a particular complaint type, if that makes sense.
Yes.
Right? And then those generate, but the key thing is that we wanted to have a human being in the loop, because machines suck. And people are smart, so they're smart at certain things, to be very eloquent. And we wanted to make sure that we were using human intelligence in that process.
Is there some touch-up at the end? Or
So there's the editorial process where an editor makes a selection, but also can swap things out. Yeah.
Although they don't have to suck, and also, all the other thing you could do, I guess, is send them to Turk or something like that and get them.
Yeah, exactly. And and actually we had an intern from Stanford this summer, Joy Kim, who did a project doing just that. So somebody's just pumping their fists. Yeah, so Joy did a project doing that with MTurk. Yeah.
I'm curious if you know what people's reactions are to the cartoons when they see them for the 6th time or the 7th time. I can imagine that it was really cool to see it represented the first time, and I don't know, maybe it's great even repeatedly, or maybe not. So what did you find?
Well, I mean, we have several hundred cartoons that are chosen from, and I think that the majority of the way that people are consuming them is by following them on Twitter or through email. So in that case, they're not necessarily seeing them that much yet. But I think people do get dulled by it, absolutely. And that's sort of the study that we've been doing, is collecting the data of over time. If you're using this over time, what's the impact, and what do you feel compelled by or less compelled by? And I think that that's also like a scaling thing. If this became more of a full-blown project, you could certainly, there are tons of cartoonists who actually contacted us and wanted to get involved and create their own recipes, specifically people from certain neighborhoods, which is totally awesome, you know? So I think you could totally get around that. This was just sort of like a short-term, quick prototype to learn something. Yeah. Thanks.
Organizational hoo-ha. Thank you, Katie. That was awesome. Lunch is the same as it was yesterday. There's going to be a wobbly, hopefully not so physically imposing stack of sandwiches because we dialed back the number of them, so there'll be fewer leftovers. But they're just downstairs. And Irfan wanted me to suggest that for those of you who might be interested in helping to organize or talk about how the direction of this symposium for next year, could join us for lunch downstairs. Assuming there's fewer than 10 of us, we can sit in the sort of mezzanine area on the second floor downstairs. There's a little, you can sort of go up in the mural area. So if you'd like to join us, grab box lunch and head up to the second floor upstairs. Otherwise, we're back in an hour, so let's make it, so it's 1:45, so let's come back at 1:45. All right? Thank you. So, but until this data, you can never.
All right. We are starting without Hannah. Welcome to the Data Mining in Journalism panel, also known as the Revenge of the Nerds panel, although we're missing one nerd, so I don't know if we'll be able to exact revenge. Very quickly, I'll introduce the participant. I'll ask each of them to say what is data mining in journalism, and then we'll have Q&A. I have some questions. I'm sure you will have some questions as well. Let me skip Hannah for a second and talk about Matt. Matt is a professor of history at Columbia. This year is visiting the London School of Economics, and he also is a PI on the declassification engine project. He has written for The Times, The Washington Post, Le Monde, and hosted the radio documentaries. Hi, Hannah.
Hi.
For the BBC, BBC Radio. Hannah. Tweets at Hannah Wallach. She's a researcher at Microsoft Research New York City. She's also an assistant professor at UMass Amherst in computer science, where she studied. She was one of the founders of the Computational Social Science Institute. She is probably the only person covered in both Linux Format and Glamour magazine.
And there was word on the Twitter streets that the audience wanted sloths. As a result, I am wearing my best sloth sweatshirt.
Excellent. Here's your mic.
Thank you.
Dan tweets at D.T. Keating. He is a psychology grad from Williams College, and he's been newspapering all his career, including the Miami Herald and the Washington Post. He's doing computer analysis for journalism since '93. He was on a team that was a finalist for the Pulitzer and then won the Pulitzer in '99 for vote fraud investigation. And finally, Jacob Eisenstein at Twitter, assistant professor at Georgia Tech, School of Interactive Computing, is looking at mining social media data to look at language and looking at applying natural language processing to non-traditional domain, including newspapers from the 1840s and other such data sources. Recently doing work on analyzing discourse structures. Finally, I am Informor at Twitter. I'm faculty at Cornell Tech, where I direct the Connective Media program, which is meant to bring together media information and communication and understand technically how those, and socially how those systems work. Also the co-founder of Scene.co. I've been doing work on data mining in social media and in journalism, including at Scene and at the project that we did here at Brown called the cdbit.org. So for an example of Scene, you can see at bit.ly CJ Scene for tracking of this conference. So let's start our discussion and talk a little bit about what is data mining in journalism. Maybe we can start with you, Hannah.
I would love to start.
I'm
All
good.
right. So
And I'm going to limit you guys for 2 minutes each, so we
okay,
can
I
have
will
more
speak
discussion.
fast. So I'm a machine learning researcher, so I'm actually going to answer the question, what is machine learning in journalism? And depending on your definitions, this may be the same question as what is data mining in journalism, or what is data science in journalism. So unlike most of machine learning in journalism is not, for the most part, focused on supervised learning or prediction. So instead, I would argue that the primary modeling goal is exploratory, unsupervised analysis. That is, models for uncovering hidden patterns in observed data. Or equivalently, models for answering the question, what can these data tell me that I didn't already know? So moreover, I would even argue that many of these analyses are concerned with who, what, when, where, and why. So as a result, I think the fundamental challenge for machine learning researchers interested in journalism is developing tools that capture the structure, who's interacting with whom, the content, what's happening and where it's taking place, and then the dynamics, when, of social processes. And so in order to do this, I think it's necessary to draw upon ideas from network analysis, from natural language processing and text analysis, and also time series analysis. That's all I have to say on that.
Very good. Let's hear from Dan.
Well, I will be honest and say that in speaking from the perspective of within a newsroom, if you were to ask anybody at the Washington Post who does data mining, they would say it's me. And I know that from what would be defined in the CS perspective, it bears no resemblance to data mining. It is at best exploratory data analysis using descriptive statistics. So it wouldn't be anywhere near. And I kind of wanted to just lay out quickly the sequence or the spectrum of what you would find in a newsroom within kind of data journalism and where I see data mining in that. At the base level, and I wish it would be overly optimistic to say we could always say this is true, would be that reporters could accurately quote statistics when they're used by others. The next level up would be that reporters could accurately seek out and use statistics to inform their reporting. That also would be good. Sometimes it happens. Next would be that reporters would do their own quantifying, aggregating, summarizing, using spreadsheets and databases. Once again, wish I could see more of it. It happens sometimes, but not all that much. And then essentially using algorithms to do more sophisticated data analysis for bigger stories. That happens really very rarely in American newsrooms. And you know, I think the kind of broader machine learning, or certainly the predictive aspects of data mining, really the only application I can think of where I see that in newsrooms is in things like trying to predict presidential elections. And in fact, that's almost always done in team with political scientists who've spent years honing models that journalists then try to provide some benefit or added value to. So kind of from the newsroom perspective, data mining is really not generally what people in CS would think of it as.
I think we'll go back to that theme later. Jacob.
Okay. So I was the only one that made some slides. Instead of asking the question that Moore asked, I decided to answer the question that I wanted to answer. Instead of talking about data mining in journalism, which frankly I don't have a lot to tell you about, I can tell you about data mining on journalism. And the reason I can do that is because my home field is natural language processing. We write software to do intelligent things with human language. And when I say natural language, what I actually mean is journalism, because the dominant data set that we've used for the past 30 years in natural language processing has been newswire text. So if you're a print journalist, that's you're sort of providing the lifeblood for this computer science research field. If you can go to the next one. I just wanted to show some examples of what you can do with that. So one thing you can do is try to remix journalistic content, things like newswire articles, into other sorts of information products. So you might have heard about topic modeling. I would put that in the category of exploratory data analysis, maybe in the domain of text. So this is a screenshot from something I did in my postdoc at CMU, where we try to go a little beyond topic modeling. We think of topics as sort of high-level concepts that maybe apply to many different stories over a long period of time, things like sports or politics as topics, and then we think of storylines as more sort of temporally focused events that may pertain to specific entities. And we built a statistical model to try to combine these things. So this is data mining, but it's applied to journalistic content. It has some of the same goals in the sense that we'd like to present information to people. Go to the next one, please. So another example of looking at of journalistic content in sort of a different way is Eric Gilbert, who's here, and I and some of our students, I think Ten, who's here as well, started to think about credibility. So when journalists quote content on Twitter, how do they quote it? And do they quote in a way that sort of frames it to change the credibility? So one benefit of the fact that we've been developing all these NLP algorithms for journalistic content is that they work pretty well on journalistic content. So if you try to do dependency parse, which is what you see here in the bottom left part of the figure, on a patient medical record, that won't work too well. But on a tweet from a professional journalist, it actually works quite well. And so we're able to extract the quote, the source of the quote, and the way the quote is framed in terms of this Q word. And then we could do some analysis looking at Mechanical Turk to see how people think about the reliability, the truthiness of the quoted content based on who the journalist is, who the source is, and how it's presented. So one more, the very last, this is on the 1840s newspapers. I'm working with a a literature professor, Lauren Klein at Georgia Tech, and we're looking at journalistic content from the 1840s, which is happily out of copyright, so it's easy to do. And this is something the Library of Congress provides. One reason we're interested in this content is because this period, the pre-Civil War period, where there was this anti-slavery movement, was the first time in American history, I believe, that in a large-scale way women got involved in political discourse in the United States, at least in attributed texts. And so one thing that Lauren's interested in is thinking about, well, what did they talk about? So when they were brought into this process, there was an expectation that they would talk about a certain set of things from a certain perspective. Did they actually do that or not? And how did that affect their participation in things like suffrage down the line?
Great transition to Matthew.
Great, thank you. So like Jacob, I'd like to reframe the question just a little bit so I can give you a more meaningful answer because I'm an historian. So I'd like to tell you a little bit about data mining and history. But of course, history is a lot like journalism. So it's often said that journalism is the first draft of history. We often try to answer the same kinds of questions: the who, what, when, where, how, and why. But because by the time we get to it, a lot of the who's and the what's and the when's and the where's have already been answered, we tend to focus on the how's and the why's. And similarly, we have similar kinds of research methods. But for us, data mining typically means just digging into archives. So 30, 40 years after the fact, in the field of diplomatic history, you often have a lot of previously classified records, so you can begin going through them. But what's happened just in the last couple of years is that the people in my field, history of world politics or diplomatic history, we found that the archive is more and more overwhelming. And we know that it's only going to get worse. So the State Department is now producing 2 billion email a year. Now, it's not as if we expect to see more than a fraction of that, and that's the other problem. What we're getting is really just a fraction. We just don't know which fraction. And we're likely to see less and less proportionally, both because of bit rot, the fact that a lot of electronic records are not going to survive, and we've already seen that with records from the 1970s that haven't survived, but also because of official secrecy, which is increasing exponentially. So diplomatic historians are just beginning to realize what a lot of journalists have realized quite a while ago, which is that we have to begin to rethink our methods. You still don't see a lot of data mining in the sense of natural language processing and machine learning in history. The field of digital history is really about using new methods to better communicate historical research to a broader public. One of the obstacles is similar to journalism. Most of us are humanists. We became journalists, and we like to work with words because we're not that good with numbers. The other problem is that, as in journalism, though this is changing, but still in history, it's rare that you can get a lot of credit for collaborative work. So there's a real problem if you want to put together a team, like the kind of team that will win a Pulitzer. But that's just beginning to happen now, and I'm working on a project. There are other projects that are underway. The project I work on is called the Declassification Engine. So this is a collaborative effort to do data mining with declassified documents. So we're trying to make out the broad patterns in official secrecy. So I can talk about some examples when we get to that part of it.
Cool. Okay. And I'm actually inviting everyone to participate in the discussion. I have, as I said, a few questions, but feel free to step up to the mic. So I guess the question came up of the common language, right? So, or maybe even the common ground. We have machine learning, NLP. We have both talked about different levels of knowledge that you have in history and journalism. How do we bridge that gap? How do we bring people to use such systems or methods? How do we even start talking about the same thing?
Right. So much of my work over the past few years has been in collaboration with social scientists, and in particular political scientists. And when I first started working in the area of computational social science, I thought, well, this is great. Political scientists have data, I have methods, great. Well, throw out a few papers, it's all going to be very quick. I was so fundamentally wrong. If you're undertaking interdisciplinary work, you have to first, before you can write any papers, establish a common language of communication. You have to establish what the common norms are, what the goals are even. So one specific goal that I kept running, or mismatching goals that I kept running into, was this difference in emphasis between predictive versus exploratory analyses. You also have to figure out kind of what the cultural norms are of the other community. And these things take time. And the only way you can really effectively do these things is to actually sit down and have these conversations. They're not even going to be easy conversations. A lot of the times, especially at the beginning, you're going to be talking across purposes, but that's okay. You need to persist in having these conversations to eventually get to that point where everybody's on the same page.
Can I give like an opposite? I mean, I completely agree with that answer, and I'm doing collaborative work with social scientists myself. But there's an opposite sort of perspective on this, which is, you know, how many of you guys use a search engine? Right? If you're a journalist and you use a search engine, then arguably you are doing computational journalism, right? Because that is a computational tool that you're using. And one way to think about our job as computer scientists, as engineers, is we're trying to take technology that currently maybe requires a graduate student, at least in computer science, to use, and turn it into technology that you use without even really thinking about it. We're trying to make data mining boring. And if we can do that, then, you know, the future might be, you know, something like a spreadsheet, right? I mean, that's something that any sort of, you know, intelligent, educated person maybe knows how to use now, but at some point that had to be invented. And I think the hope is that we can, you know, down the road invent technologies that people just take for granted, the way they take for granted spreadsheets and search engines. And that's sort of I agree, you know, working with people maybe you'll shape the direction of what that technology should take. But ultimately, if ultimately the only way to use computation is in collaboration with computer scientists, then I think we haven't done it right.
That's not quite what I'm saying. What I'm saying is that in order to develop usable technology, you need to know your users. And if you want to know your users, you have to have those kinds of conversations that I was talking about.
We agree.
Yeah.
Well, you know, everything you're saying really resonates with me because I've been working now for a couple of years, you know, trying to put together a team like this and to keep it together. And, you know, some of the things along the way, you know, that I learned, for instance, is that a lot of computer scientists, they would say, you know, let's say you generate data showing the patterns of State Department cable traffic, you know, and so you have millions of telegrams. And, you know, the historian is interested in looking at bursts, you know, and we think that bursts of communications might indicate where there are events. You know, we think that maybe some of these events are relatively unstudied, right? And so there may be, you know, techniques in data mining, in this case traffic analysis, that might reveal some of these bursts. But, you know, in many cases, you know, a computer scientist might say, well, can't you just look at a table? You know, couldn't you just look at a spreadsheet in this case? And so sometimes there's a process of, you know, communication about how it is that a lot of us anyway, you know, we think spatially, right? So it's going to be much easier for us to see patterns, right? And discover anomalies, like if we can see that data displayed in ways that to us is more intuitive. That takes a lot of work, and it's often work that computer scientists, many of them are not interested in doing. You know, there are many computer science departments where they don't have anybody working in human-computer interaction or design. And I'm told in part because it can be more difficult to evaluate that work compared to evaluating the performance of an algorithm, say. So that's like an example of, you know, how it is that there's real work to be done, kind of bringing these communities together, and sometimes it's not work that computer scientists would find particularly exciting. And then conversely, I know that you know, we're pretty close now to publishing some of the first fruits after this whole time, you know, in history journals. And political science journals, and I'm sure, you know, that very quickly historians are going to find that you know, some of the arguments that we're making, if you dig down into the data, you're going to find lots of errors, right? Because, you know, with you know, entity extraction, you know, there are going to be errors, right? And so what you want to do is try to test the performance and discover what the error rate is. But for a lot of historians, there is zero tolerance for error, and even one can seem embarrassing. So there's going to be also a lot of communication across these disciplines as to how it is. You know, some of this kind of research is going to have these kinds of intrinsic methodological flaws, but so too is historical research, which will also have errors. It's just that we never are able really to discover them, except for years later, right? Anyway, so these are some of the kinds of, you know, arguments that you end up having, but I think they're worth having.
I think I really liked the very first thing Hannah said, which was that the whole objective for us as journalists is to tell people things they don't know. I mean, that's what I live for. That is absolutely, if anybody asks me, why am I in the business? It's because I love to tell people things that nobody knows. That's my whole life goal. And to the degree that we can bring additional cutting-edge tools that CS is developing to be able to do that with natural language processing, with better data mining, we would love to do that. But to get there, we do have to cross a couple boundaries. Also, similar to what Hannah was saying, is that at this point, the skill set is nowhere near the newsroom. To the degree that we hire coders, and we hire a lot of them, we hire slews of coders, but we are hiring them all on the output side. We're hiring them all to design outputs and jingly, jangly, shiny things to entice clicks, and that's what our CS people are at. But on the reporting side, the analytical side, we aren't hiring coders for the most part. And so when I think about, but when I've sat here for the last couple of days and I've been so impressed at a lot of the kinds of analysis people do and a lot of the kind of thinking and working they do, so it's making me think a lot more about how much we could benefit from collaborating in the newsroom and taking advantage of these kind of analytical tools. But I think the real challenge for that is, in addition to the kind that you talked about with regard to, different communication techniques and everything, is simply timing. Is that the way we do things so often is unpredictable and sometimes just absolutely, we will crawl naked over broken glass today for something that we won't take off a platter tomorrow. It's that critical to us is timing. But that doesn't have to be fatal, because I think there's two ways around that. One is if we have pre-existing relationships with people that we already know and we can tap into, then I think there's a good ways that we can use that to use expertise and bring the two together. And the second is that we do sometimes do long-term projects for which that kind of thing could be. So I would love to be able to bring that in to do it. And one last cultural issue that's similar to what Matthew brought up is that we cannot do anything on this stuff without ground truthing. We absolutely have to find examples that we can then go out and poke. And I know sometimes with academics that kind of runs against the way people like to look at things, but with us is no choice but to do that. So it has to kind of come down. That's one reason why really sophisticated models, I've found, can be problematic that way, because when you do a really sophisticated model, there might not actually be a living, human, breathing example that exemplifies what you're trying to talk about. And without that, we have nothing.
Let's go to the crowd here.
Thanks. Well, you guys are all awesome, amazing stuff so far. I just wanted to throw out an anecdote. So when we first did this Symposium of Computational Journalism, just like within a few months of that, Jay Hamilton was around here, invited me to come and give a talk at Duke. Gave a Duke about computational journalism to a bunch of students and professors and all that kind of stuff. At the end of it, some of them got up to me and says, "You really don't mean journalism, you mean information." So the reason I actually want to put that anecdote out is sometimes we spend a lot of time trying to define terms around ourselves, like what is X, what is Y, what is Z, and then try to kind of build up from that one. I think at the end of the day, we're all interested in solving some problem. And I think kind of the problems that you kind of defined, being able to extract information from data. I mean, there are terms like data science, and like yesterday we even heard, data journalism and all that kind of stuff, computational journalism. I think we're coming up with too many different terms. So, I mean, what I'd love for us to start spending a little bit of time, not that I want us to stop thinking of labels, it's important, is what kinds of problems we want to solve. I mean, is there a specific form of data journalism or data mining that we want to do that will solve the problems in journalism? I mean, in the newsroom, of course, there has to be on a deadline, because that's actually differentiates journalism from anything else. Can we start thinking a little bit on that kind of context too? So more of a statement rather than a question.
Well, let me answer that in a little bit of a way. The way I operate now, usually, is if we can envision a way that you could see, if there's something that we think is going on, or provable, or a question we want to answer, we try to say, is there a way that you could piece together an algorithm to perceive this in the data? So in Miami, there was a long-standing perception that the cops were stealing money by, when they arrested someone, they would list all their friends on the arrest report. So that way, every friend would get called to court for every pretrial hearing, and they all get a minimum of 4 hours overtime pay. And the cops had a name for it called collars for dollars. And it was kind of a known deal, but it was nobody ever could, like the police department always said, we tried to investigate, we couldn't find it. Well, we used the witness pay data from the courts to prove that they were doing it. It was a piece, once we got our hands on that data and worked it the right way, we were able to prove they did it. So the thing for us is more often finding information, the data, that we can then sink our fingers into. But I think it was really interesting, the question that arose yesterday with Rob Berry is someone said, but what more questions could you be asking in that data? So I think, part of what you asked was that it was a question that we're not well equipped to answer, because I don't have a good sense of the things that we could be doing if we tapped into that we haven't been able to do so far. And I think probably a lot of it has to do with unstructured data. I think that is probably the hardest thing for us to tell stories out of.
While he's running over there, I just want to say that's why I think it's important that computer scientists come to these interdisciplinary venues and actually have conversations with journalists and explain what the latest technologies are, so that we can actually start that discussion of what questions can be answered that you don't even know you want to ask yet.
And I think what comes down to, and this is what I asked Rob also when he talked about the Wall Street case, I think that was Wall Street, was what can we do that's repeatable? I mean, what can we do to solve that one X problem that you just decided that now actually leaves a trail, a software, or a set of tools, besides your personal expertise, which are the most valuable, that will let you do something different the next time? And that's the kind of thing that...
We have the attention span of squirrels. We don't do repeatability, hardly ever. I mean, one day I'm doing Ferguson, and the next day I'm doing the Winter Olympics, and the next day I'm doing census demographics, and the next day I'm doing hospices. The big story I'm publishing tomorrow's paper is all about hospices. I mean, we don't, repeatability, like we are just so scattered. It's the nature of our business that, very seldom do we keep things up in permanent structures. We don't take databases and hone them for years and refine them. It's like, next, that's it,
But this is another thing where computer scientists can help, because we're trained for years to think in terms of abstractions. When you see a problem, when you see a challenge, how do you abstract to something more general, such that it's then something larger, of which many other problems are also instances of?
That's true.
Right.
That's true.
And we'll get to Nick in a second. I think a related question, right? We talked about the one-offs and the immediate needs, and we also talked about toolkits and working over time with journalists. So how do we move from the one-offs or...
Well, Jacob said it, you just have to make it really easy.
What is it that we make? How do we get to those toolkits that are needed in your work and that can be developed using interesting computer science techniques?
In my field, as soon as I saw that it was possible to get access to not just hundreds of thousands of digitized, declassified documents, but born digital documents, structured data, and I started to hear about some of the techniques that computer scientists were developing, I was like a kid in a candy shop. I thought, oh, this is amazing. We could do amazing things. And we could, and we began to do some things, but then I began to realize that if all you're doing is going after low-hanging fruit, then pretty soon it's a big mess. You got all this low-hanging fruit and you're sort of tripping over it, And so our long-term goal was, because, maybe the biggest difference between historians and journalists is that we are in effect beat journalists. Our beat goes on for 5 or 10 years. Our deadline could be 10 years down the line. And we also, because we're in these universities, there are incentives, to develop resources that are going to survive, and become community resources. So the goal for this project, Declassification Engine, is to create a website that will aggregate all of the declassified documents that we could get, turn this into structured data, and then build a suite of tools and visualizations so that others, and not just us, can begin to discover things. But early on, when we were just plucking low-hanging fruit and not paying attention to like building a robust and flexible API and so on, we actually made things harder for ourselves down the road. And so that was one of the things that I had to learn, along the way, is that there's important engineering questions, at the outset that you have to think about for long-term sustainability. But that question, what are the problems? What is this actually supposed to be for? Those are the things you have to keep uppermost, right? So for me, the problem for historians, journalists, political scientists, when it comes to official secrecy is, how do we know what we don't know, right? How is it that what's behind that blacked out text might change the story, right? If you knew the author of that anonymous document, how would it change the way we understand this history or these events that we're all living in? And so the kinds of tools that we're developing and the platform we're creating over the long run, the hope anyway, is that we could begin to tell what sorts of things tend to be redacted. Do you have a document that's anonymous? Well, we can give you a probabilistic estimate of who may have written that document. So these sorts of things are quite feasible. It just takes time and money and expertise and collaboration. So all these things can be done if we have the resources to do it.
Yeah, so I'm hearing a lot of different sort of approaches and perspectives on data mining and wondering if one of the sort of divides that needs to be bridged is the kinds of questions that we approach data with, right? I mean, in the newsroom, you're approaching it with one set of perspectives. As a historian, perhaps a different orientation of perspectives and questions that you want to data mine from that. I know at the Washington Post, they have data scientists. They just happen to be working on optimizing the website, right? And getting more clicks and optimizing who's going to subscribe. And they're doing the same thing at the New York Times and so on. So there are data scientists working there. They're just working on questions that are relevant to the business rather than to the newsroom per se or finding a new story. So I kind of wanted to pitch this question to the computer scientists on the panel. Now that you sort of spent some time maybe listening to other journalists in this community or talking to other journalists and thinking about the kinds of questions that you approach data with, how might you reorient those questions to sort of see things more as a journalist might? And maybe more importantly, can you convince yourself to, or incentivize yourself to actually approach your data in that way?
Yeah, I don't know if I'm ever going to approach my data as a journalist would. I don't have that training, I guess, and that's not really that doesn't really align exactly with what I want to do. I want to be able to work with people that have different perspectives. I guess one thing I would say in response to that, though, is so I'm thinking about data sort of journalism projects, other applications in the computer science world. There's sort of an analogy where people do data mining on social media data or other kinds of social data, and often I think we don't bring a lot of theoretical perspective sometimes to that kind of research, and that's really something that came up in a lunch discussion that I had with a few people. And I think that's one place where we really, that's some training I think that we really don't have when you look at a data set to sort of question the underlying things that led that data set to look the way that it did. So you can sometimes read computer scientists saying things that look really pretty facile, like, well, the data is just speaking to me, this is what it's telling me. And one reason I like talking to social scientists, and I think journalists have very similar training, is that they're trained to really think about the assumptions that led that data to look the way that it looks, and maybe lead you to ask a different set of questions.
Hi, Meredith Broussard, Temple. I wanted to bring up something that came up earlier in the discussion about correcting errors. You had said that one of the things that happens when you look at data is you discover errors, and I feel like as humans, it's very easy to correct for errors. And as journalists, correcting for errors, correcting for misinformation is something that we do as a matter of course. I mean, we've talked about this in some of the sessions. You know, how do you deal with misinformation as a journalist? How do you correct for it? I mean, we actually we issue corrections in newspapers. But as computer scientists start getting more involved in journalism, as data mining becomes more extensive, my question is there a culture among computer scientists of going back and correcting for misinformation? Or correcting for errors? Because I feel like a bug is different than a correction that a journalist might offer.
So we're very interested in predictive accuracy, like probably too much, right? So in data mining, like if you can't sort of reframe what you're trying to do as a task where there's like a ground truth that you get 95% on, it's hard sometimes to sell that research. So you know, in the sense that like you know an error is failing to replicate some ground truth, I think absolutely there's a tradition of that in computer science. I'm not sure though if that's exactly what you're asking.
Well, I'm just thinking about the kind of accumulation of knowledge. So for example, if we have if we have an algorithm that is 64% effective in predicting something in social data, and we publish on that, and you know everybody says, "Oh, great! It's this algorithm that's 64% effective," and then that becomes the standard. Well, when somebody realizes that, oh, we shouldn't have done it that way, how do you correct for that error if it's already embedded in code everywhere?
Oh, I mean, I think that is kind of what Jacob was saying, is that we're very, for better or worse, I would maybe argue worse, we're very competitive in computer science. We like to compete with each other, we like competitions, we like to outdo each other. I have a whole other rant about this issue, but we'll save that for some other time. But this means that if somebody publishes, and we're constantly always looking for new problems and new data sets and new challenges as well. When these two things come together, you mean that what this means is that if I, as a computer scientist, see that somebody else has written a paper that gets 64% accuracy on this particular task, and the rest of the computer science world, we are going to go out and we are going to try to do better. We are going to try to find different techniques, try to find different ways of doing things, try to find alternative ways of doing things, and try and improve that score. So I think this is very much what Jacob was saying earlier. I don't think these things end up getting etched in stone in terms of code, because that's just not how, I don't know, the academic community in that world seems to work.
We're far more likely to get 98% accuracy on the wrong problem, right? Than to be satisfied with 64% accuracy on the right problem.
And to, when thinking about, so that's talking about prediction and predictive tools, but you also have tools for exploratory analysis. And then you're still creating findings, but there isn't necessarily a labeled data set that you can compare to. And so I think the bigger challenge is, how do you evaluate models for exploratory analysis? And furthermore, when you come up with findings using models intended for an exploratory analysis, how do you then revisit the veracity of those findings down the line as the technology evolves?
Yeah, I mean, actually, this goes back to something Moore asked a minute ago, which is that, so, you know, I think we've gotten really, really good at making predictions that we can quantify because you can sort of see every year, you know, the accuracy rate goes up by 1.5%. I don't know that, like, our tools or our methods for exploratory analysis have really improved in the same way. And I think, you know, to the point that ultimately we could really black box it and ship it off the way we have, you know, in a spreadsheet or something, and just let people use it. And I'm worried the reason maybe that we haven't made the same kind of progress is we don't really know what to measure. Hannah's a little too modest. She wrote one of the papers that really helped define how to measure the performance of topic models, which is an exploratory tool. But I think you probably agree it's still an open problem.
It's a huge problem. One of the issues that I came up against when I started working in this area is I would hear computer scientists and social scientists talking to each other, and each one would say to the other one, I don't get it, what's the research question? And from the computer scientist point of view, they couldn't understand what all these social scientists were doing, because what are you trying to predict? How are you going to evaluate it? And I then saw many computer scientists, when they realized that there wasn't an easy way of making predictions, there wasn't an easy way of evaluating these things, I saw them drop out, lose interest, move on. Great, I'm going to go back to predicting part of speech tags, that kind of thing. And so this is a real issue, encouraging people to say, no, this is really hard. But just because it's really hard doesn't mean we shouldn't be trying to do it.
I think this might go back I feel kind of dim, because I think I'm just starting to think of the answer to what Nick asked about 10 minutes ago. But I think based on what you're saying is that there's kind of a different, and when you were saying kind of that you guys could be more helpful to the kind of problems I've been saying that we have, is that there's a difference in thinking about the system that you can build, that you don't care which the content is that goes through, that your system can work. And the people that are so content obsessed that we tend to think of each one as unique, and we're not seeing that I'm not seeing a generic system that you can push this through, because I'm trying to answer a specific thing in a specific data, and the things that are reproducible to me are that there's some skill sets I can bring, but that systematically I don't see. So your guys are kind of talking about a system that content could go through, and I'm just fixated on the content.
Right, exactly. And I think this conference, computational journalism, also the field of computational social science, is really all about finding that midpoint between those two, and finding ways that we can articulate that midpoint and actually make it happen. So caring about both of these things together.
So let me ask about the midway, because there are two technologies that were mentioned here in the last few minutes that have been investigated in computer science for a while and are more exploratory in nature, and therefore theoretically, based on what you said, can be applied. So let's talk about topic modeling and social network analysis. We have fairly robust algorithms for exploring those two areas on any data set. Where are they? Why aren't they
I can answer that question.
Great.
I can totally answer that question.
And then we'll go home.
Yes.
No, happy hour first.
Happy hour. In that case, I won't answer the question.
No, I
Just
think there is
move on to
another
happy hour.
session after.
No. So
Don't go away yet.
here's the thing. Most of the people doing research in this area on topic models, and I am one of those people, I've been doing this for 10 years at this point. My job at the end of the day is to write papers. I get credit for writing papers. I get credit for going out and giving talks and stuff like that. I get credit for developing software, but in the sense that it implements my research ideas. At the end of the day, when I sit down and I put 2-3 years or something like that into creating a piece of software that is usable for somebody off the street to just run their stuff through, I lose out. And this is true for many people developing these techniques.
But you're a researcher, so we have by now produced years of PhD students and master students that have access to this method and these knowledge
Somebody needs
bodies,
to fund it.
Is that the problem?
Let me give you an example. So I don't know how many of you know the Debian GNU Linux operating system. I've been started using Debian 15 years ago. When I started using it, it arrived on 7 floppy disks. It was just a nightmare, super unusable. You would upgrade your computer and everything would break. You'd be without a computer for a week, this kind of thing. Yet there were a team of 1,000 people around the world doing Debian development. Why could we not get this to a point where it was actually usable technology? Then we figured it out. Here's the thing, all of those developers were doing that development in their spare time. None of them wanted to do that difficult polishing, testing, nitpicky, annoying, frustrating work of making things actually usable. So Mark Shuttleworth came along. He founded Canonical. They were actually intending to do something else, but to showcase that other thing, they came up with the Ubuntu Linux distribution based on Debian. And he paid people who had been doing Debian development but had separate day jobs to quit their day jobs and actually work on polishing Debian into something reasonable. How many have used Ubuntu? Probably a lot more than have actually used Debian. I think funding is seriously important.
So can we get that funding?
Yeah,
That I can't help.
I think that's one reason to have these kinds of conversations, because there are very important social needs that topic modeling could address. So Hannah and I actually just yesterday were talking about research that we are hoping, in some cases she's already been doing this work, and I'm working with people who have been working as well on this idea of, can we come up with automated means of reviewing documents for declassification? So the whole system for declassification is going to break down, in the next few years when they start to choke on tens of millions and eventually billions of email. So unless we come up with some automated means to accelerate that process, the whole principle of open government is at risk. So topic modeling can actually do things like this. It could, predict the classification level of a document. It could, and we're talking about prediction, but actually it's important in this case. It can predict, what department, what agency produced this or that document. Now, it's not going to be 100%, but neither are humans 100%, in identifying those documents that need to be reviewed more closely or withheld. More than that, the National Archives now has all but given up on the idea that they can review every page before release. And so just recently, they approved some 360 million pages to be released to the public, and they were only able to sample about 10% of it. So this is a system now that's not working for us, citizens, journalists. Neither is it working for government in the sense of they're being confident that they're not releasing, data that could be used for developing weapons of mass destruction or simply carrying out, mass, attacks. And so topic modeling can actually solve these kinds of problems. So we just now need to find the funding to do it. And then, by the way, the MacArthur Foundation is happily, doing some of this, and they are providing some funding, for this kind of research, but we need more, to be honest.
I will note that DARPA put out a call for white papers about 4 years ago,
Right.
asking for people who were thinking about these things to submit white papers detailing ways in which researchers could help the government declassify more effectively, and to my knowledge, nothing came of that.
That's right. They put this out, and then they didn't fund anyone. And to my knowledge, the CIA, to its credit, is the only agency in the government that's doing any kind of research in this area. And apparently, after 3 years, none of the research that they've seen has been tested in any way in terms of how it's performing, which I find kind of weird and suspicious.
Just a quick note on this on this funding point is I think one reason that you don't have commercial funding for this is that there isn't a clear story for what role topic models are going to play in a work process that anyone actually has, right? Like people that know how to use them get cool things out of them, and they're like, man, this seems like it should be useful, but in terms of like someone already has a job, they already have a workflow, and you're going to bring topic models in, and it's going to help them somehow. I think the problem is, and actually this goes back to something Matt said about HCI, that branch of computer science, human-computer interaction, is pretty separate from machine learning, the branch that develops the topic models, and it's been hard to really bridge that gap.
I would say that Jordan Boyd-Graber is really thinking seriously about these issues and thinking about how people use topic models in that workflow, and how they can actually iteratively refine what they find with them and stuff like that. So I think we may see more focus on that in the next few years.
I should have said the Brown Institute has also funded research in this area, and for that, we're very grateful. All right.
What institute?
Oh, sorry. So I've been on the front lines of trying to bring natural language processing to journalism for 4.5 years now. And so I wanted to share some horror stories of what that's like. So we got a Night News Challenge grant in 2011, and we thought, this is really great. We're going to use some really simple stuff, right? Document vectors and clustering, not even topic modeling per
Sorry,
se.
can you introduce yourself?
Oh, sorry. My name is Jonathan Stray.
I thought so.
Yes, and Kay Crawford has told me I have to meet you.
Likewise, and you sent me an email, and I failed to respond to it, and I feel terrible. Okay.
It's all coming out. So
get a room, guys.
In the spirit of dirty laundry, let me tell you about sort of the challenges involved in that, right? So we had a working proof of concept at the end of 2010, because I was working on WikiLeaks, and produced a visualization, which you may have seen. And then we're like, great, we're going to get this out to people, and the first thing we discovered was that nobody could install software that required use of a command line. So then 18 months went by wherein we hired 2 developers and rewrote it as a web application. And then the next thing that we discovered is that nobody could use it because it only read CSVs. So then we integrated with Document Cloud and added PDF import. And then we discovered that nobody could use it because we had massive usability problems. So then we went through 6 months of Think Aloud user tests and rewrites. And then people started, actually stories were trickling out during this time. People started to use it. And we were trying to solve exactly this problem of finding stories that you didn't know were there. One of you, I think Hannah, that was your phrasing. And in fact, we have succeeded in doing so. And this is, gentleman here, this is Tyler Dukes, wrote an article about doing exactly that with Overview. But there are so many unsolved problems, right? You know, can I run this on an air-gapped computer? And suddenly that's 3 months of development, right? And it's, oh, but you know, it needs to OCR in Albanian. And we're like, you know, and so we're working with the Organized Crime and Corruption Reporting Project now, and they work with 20 Eastern European languages, which makes all of the open source named entity recognition software useless. And then there's the issue of evaluating the visualizations and models, right? You've touched on this. It's incredibly hard. You know, is this a good visualization? All of the stuff that I've seen on evaluating topic models is completely useless to me and the people I work with. I'm sorry to say that's the truth, right? Because it's all statistical evaluations and none of them connect it to usability.
No, I have a paper on coherence and human subject evaluation. And different ways you can start to get at actually how humans use these things and what they think of the topics. Also, Jordan Boyd-Graber has a lot of work on this as well.
And I know the Tea Leaves paper, but I haven't read yours, so
Okay. There's
you've
a body of literature out there that I would be happy to send to you.
But ultimately, I think the only metric that counts for journalism is, are people using it to produce stories? And the use of topic models in journalism, I can't think of a single example where that was used to find a story. I can think of a few visualizations where people wanted to show, you know, what's happening on social media. Nor, by the way, can I think of a single example where algorithmic social network analysis was used in an investigative capacity. So far, it's pretty much all been drawing pictures of things that they found out in other ways. Anyway, so that's the view from the trenches, and it's ugly. And there's this tremendous disconnect between what's happening in the research world and what journalists are trying to get done. Which is why I'm glad that, you know, we're all in the room today.
Yeah. Which I guess I was going to ask, if can anyone think of any success story of data mining, like after this? I see a hand there.
I mean, yeah, I have a few. Wait, well, yeah, tell them. Yeah, anyway, it's...
It sounds to me like you're making progress. I mean, I don't know, like it's slower than you want it to be, but it sounds like you're getting there now.
But the progress isn't designing the algorithms. The algorithms are, you know, 10 years ahead and in the wrong direction. They don't connect to the problems that journalists are actually facing.
I mean, part of your problem is that WikiLeaks is such a nasty data set, too.
What's that?
Part of your problem is that WikiLeaks is, you know, I mean, all those language issues that you're talking about coming in is partly the nature of WikiLeaks as your topic source.
No, I mean, we've done a bunch of stuff, and it's not that bleak. I mean, you know, we have users who have produced real stories, including a Pulitzer finalist. So, but I mean, I read the topic modeling and social network analysis literature all the time, and mostly I'm like, yeah, but you know, the bottleneck that I have today is that users don't understand what a tree of topics is. So I have to figure out how to communicate that instantly, and I have to, by the way, do that fast enough that they don't get frustrated and just read the 5,000 pages, and I have to do it faster than just using a search engine, right? So it's not just does it work, but is it better enough than what you can already do?
So look, these are great points, and these are really interesting questions, and they're questions that I would like to see addressed as well, and that I also find frustrating that they haven't been addressed. I think what I hear you saying is that there perhaps needs to be, as a starting point, not the ending point, more dialogue, more communication between those researchers, people like me, people like Jordan, who's doing his interactive topic model stuff, and you, for a start, but also other people who are trying to use tools in practice. I would love to have these conversations. So maybe what we take away from this is that we should start having them, take it seriously.
Yeah, and I think also the use of the word tool there, right? You guys have talked about tools. I think when researchers mean tools, they mean algorithm. But in my world, a tool is not an algorithm. A tool is something that you can deploy to someone that they can use immediately without reading
Full
the manual.
disclosure, I don't actually develop tools. I develop models and inference algorithms for those models. I don't actually develop tools. I think when talking with people outside of the world of computer science, I sometimes use the word tool because it's more immediately accessible, but you're absolutely correct. I don't develop tools.
All right, I'm done my rank. Thanks for putting up.
Any other comments from the panel?
Yeah, one thing I would say, by the way, is like Jonathan, I've been for a couple of years, well, maybe not as long as you have, but I've been trying to understand better the field of computer science and the research coming out of that field. And one thing I'll say is that Hannah is part of a very small group still, of computer scientists who are genuinely interested. I mean, this is my perception. I may be unfair, but I think I'm echoing some of the things that you've been saying. Who are genuinely interested in the ways in which the insights and the approaches coming out of that field can really work for the social good, right? And serve the public interest. And I wish that kind of feeling was more common, because what I've sometimes found is that computer scientists, I'm surprised in a way that you didn't have this experience yourself, but sometimes you tell them, yeah, we want to do data mining with declassified documents. They go running in the other direction. They don't want to have anything to do with it. And one reason for that, let's be honest, is that there's still a lot of money from government contracts to do data mining research, when we all know why they are giving that money and for what ultimate purpose. So I feel that the field of computer science and the industry that it has helped to generate, really owes it to the rest of us to give something back, right? And so I'm making a pitch again, for this idea, but I think especially we ought to be focusing on issues of transparency and open government, not just for the public sector, but also for the private sector. So I really think, that you shouldn't be waging this fight almost alone, Jonathan. I think that more computer scientists like Hannah should be coming forward and helping. Yes, and yeah, I mean, a lot of times it's engineering problems that we're dealing with.
To be brutally honest, as an academic researcher, so do I. I need engineers to turn my research into usable tools, but I don't have the money to make that happen.
And developers. I find that is the hardest thing of all, is to find somebody to help us create, public-facing, tools, the public could actually use. And so, I've been very lucky, I've eventually anyway found people like that, but it's very hard and usually very expensive.
Dan, in your organization, in the Post, do you think if you go to the higher up and say, here is something that we want to develop, here is how it will help our reporting, social network visualization, topic modeling, whatever classification techniques for writer.
Well, I think, this conversation about what is a tool in CS versus what is a tool in the hands of a journalist is absolutely appropriate. I mean, it has to be, for you to sell it in the newsroom, you have to make a very confident pitch on this is usable right now for this purpose. We do, there's WAPO Labs, is a more exploratory place, but that's really more aimed at developing new products. So kind of a lab oriented at the reporting side is not something that news organizations are terribly inclined to do. Remember, we're not very far removed from a business where everybody assumed that the only tools you need were a pencil and a notepad. We're not that far from that. So the idea that they would be investing money that doesn't have an immediate return. And in all honesty, a little bit of what's hurting us is the kind of the open source free software thing, because they keep saying, well, is it free? Well, actually, no, it wouldn't be free. Well, then go get a free thing. So that doesn't always help us either when we're talking about trying to tap into the more sophisticated. I mean, quite frankly, the biggest, and several people have said this so far, it's all about resources. If I could promise a really great story out of it, they would be willing to let me work on trying to make that kind of thing happen. But, you have to be able to back up those promises, and it's tricky.
Xiao?
Hi, my name is Xiao, and I'm a PhD student at Cornell Tech, working with Moore. And before that, I was intern producer at New York Times Beijing. So we were hearing a lot about how difficult it is to have a conversation between computer scientists and a journalist, and try imagine having that conversation constantly in your head. And I'm interested in building tools/algorithms to help journalism and journalists. And my question or problem right now is I think there's a lot of value in years of journalism training. And there's a lot of wisdom in that. And I want to extract that knowledge and wisdom and to put that into the design of the algorithm to sort of improve exploratory data analysis and finding stories. But I'm at a loss where to begin, because in computer science you have codes, you have papers, but in journalism right now I don't know exactly where to start. Maybe talk to journalists, but I don't know if it's the most effective or time-efficient way to do that. So I'm wondering if there are any ideas to get started.
Well, I think the universe of the most kind of cutting-edge thinkers on this in journalism that you want to try to communicate with is this group called NICAR, Computer Assisted Reporting Group. I mean, that's where the most receptive and likely targets to interact can be found and can be engaged. And it's a really good, active, thoughtful group of people that are really eager to try to take on these kind of things. So, yeah, I mean, there's not, in the academic journalism field, I don't think there's existing right now a lot that's kind of representative of that, but in practice, there is a group that really does it.
How do you spell it?
NICAR, it's the National Institute for Computer Assisted Reporting. It's a part of Investigative Reporters and Editors, IRE. So NICAR holds an annual Computer Assisted Reporting conference, which is just fantastic. And where is it this year? Scott? In Atlanta, this coming March, February, March?
Yeah, just to give some sort of, maybe more generic advice for starting a research project like this. Sometimes you think about these sort of really interesting high-level questions. Man, how do I get journalistic principles into a text mining tool? But sometimes that can just be overwhelming, and it's easier to just pick a specific project, like a much more concrete project, maybe something that you can do with a journalist. Do it, and then take a few months and think, okay, what can I extract from that I can generalize? Because as academics, we actually have time or we should have time to have that reflection period and try to think about what the next step would be to generalize.
Great. Thank you.
Hi, Ann Grimes from Stanford. Want to offer a solution to improve the communication here a little bit. That's pretty easy. A lot of us in academia teach classes that are project-based classes. There are many people in CS that teach classes that are affiliated with industry. Industry comes to the CS group and says, I have a problem with X, and they stick their students on it. We had some pretty good success recently working with our colleagues in computer science, as well as working with the McClatchy Corporation to take on a big issue in journalism, user engagement, which is a big abstract problem for all newspapers, all news organizations. We took 2 teams of journalism students and computer science students. They worked very closely with a group at McClatchy, and they came up with they built software. One was a meta tagging system, and one was a new commenting system that helped push the organization forward. They gave us a little sponsorship money. It was very modest. but we came out with something that was useful. And that model, I think, can be applied over and over again, either through industrial affiliate programs or sponsored research, to get to Hannah's question of incentivizing people to do this, as well as to Dan's problem of finding solutions for, issues that are shared industry-wide. It's very simple, and the infrastructure's already in place.
See, we've had more luck on that. We've done that as well on the output side as compared to on the reporting side. That's been the bigger challenge.
Just my 2 cents.
I just want to, Jonathan, right? I appreciate you standing up and sharing the, reports from the war stories and stuff like that. I just want to add, this is a Kennedy statement. If it wasn't, we do it because it's hard, all right? Computational journalism is hard. It's 2 different communities, and I'll just give you an example from Phil Meyer, who I've been blessed because of this effort in computational journalism. I've been spending a lot of time with him. All of you know, most people know him very well in the journalism field than I do. And he actually, we were having this conversation, and this relates to my statement I'll say, is that you can come up with all strategies and culture will eat them for lunch, okay? And the culture between these 2 communities is extremely different. And I think Dan kind of said it, is that, they're deadline driven. Yes, we academic thinks we're deadline driven, but our deadlines are 5 months apart. Their deadlines are maybe day to day, right? And that is an interesting thing. So in fact, one of the proposals Phil had was, you guys, all of you who are doing data science stuff, why don't you create a group that if a journalist has a problem, they could send it to you and you guys could work for 3 days and give them a solution. I heard this, I fell on the floor. You 3 days to solve a problem? What are you talking about? 3 days, I barely go figure out where to get coffee to think about a problem. So it's the culture that's different here. But one of the interesting parts in this community, and as I said, you've heard me enough about this community building exercise, and I'll keep on emphasizing this, is there are some amazing problems out in this field. We have to start thinking about artifacts that are not just stories, and that's a cultural problem on the journalism side. But the output is always a story on the journalism side. It's valuable. I would argue that actually you just said stories are things, but sometimes visualizations are a story. The data is a story. And again, that's not the output that they're used to, but those are the kinds of things that, perhaps this kind of the culture that needs to be created between these 2 communities is going to help. It's going to be a long road. And what Jacob said is extremely important. You're making progress. It took a while, but you're making progress, okay? And that's the important part we want to actually get across. So I just wanted to, get that back in there, that it's 2 different communities. Having meetings like this, having conversations like this are extremely important. Let's not go home depressed. We'll get some drinks.
But just to say, and I worship at the altar of Phil Meyer. For us in the journalism business, he is considered the great bridge, the first kind of guy who walked across the ice bridge from Asia to Alaska. Although now we know that's all bull. But anyway, but just to say that, we dream of the day when we only had 1 deadline a day. Now it's literally minute to minute that you got to get out. And just to turn the tables here, I kind of want to ask a question, because there's a guy out there in the audience who's a journalist who knows this stuff so much better than I do, and I think he could. I'm just curious what Scott Klein thinks, because you've done this stuff more than I have, and I'm sitting up here talking for journalists, and you know it better than I do.
What's the question?
How should we bridge this? And you've done it better than maybe.
No, you mean to answer. All right. Well, thanks, Dan. I'm Scott Klein. I work at ProPublica here in New York. And we've done some of this work. We have done, during the 2012 election, we tried to understand how the campaigns were targeting individual voters with emails, and we ran a lot of statistics that was over our heads, but we learned as we went, and we really were able to predict within some level of certainty why Mar got one email and I got a different email from the Obama campaign. So we did use some of these advanced techniques. So I only have a minute to say it, so the answer is how do you get started is you get started, right? You do it.
But did you collaborate with academics on it, or did you use techniques that you found in papers they had published, or what'd you do?
Yes, both of those things, right? We didn't have a formal collaboration, but we're journalists. So, we recognize that we don't know shit about shit, and we call people and we say, hey, I think I can use this mathematical technique or this statistical technique to understand this body of work. And they tell you, no, you can't do that. That's actually the complete wrong technique to use, but you can use this technique. And we say, okay, well, let's go back and we'll work on it for a little while. And we'll go and say, hey, here's what I did. Did I do it right? And they say, no, actually, you did it completely wrong. Try this instead. But, like with everything, we sucked until we got really good at it. So the answer is, you do it, right? You do it, and you do it bad the first time. And hopefully you don't publish the results of your bad version of it. But eventually you get to where you're pretty good at it. So that's my short answer.
One last quick question, Oren, and
Yeah.
1 minute answer for everyone.
I almost feel we kind of rehearsed this panel in the summer. It was very similar Q&A. But I wanted to connect two things that were said before, like the previous slide that you just flipped, that there were no real success story for this type of cooperation, which is something that Hannah and others echoed like much earlier, about the problem about evaluation, the methods we use as computer scientists. And maybe the different type of accountability here is what makes like the no success story, right? Because for us as computer scientists, if we validate something 65, 70%, which is fine, publishable, a journalist that will come with a story with this, and I will provide the perfect tool, which I published in an academic conference, and he will use it and say, well, 70% is not something I could write on. Right? And I don't have, and if I use it as a black box, I can't really evaluate the output of the algorithm you give me, so that's why I'm not going to use it at all. So maybe here is where what creates a problem of using these tools.
All right, I think we're getting the from the organizers, so thanks to all the panelists.
Thank you.
Thank you for the questions.
That was a bit more of a dialogue. It's on the side.
I'm in the School of Interactive. Well, we should be further. Same as Eric.
Yeah. We're going further.
I feel like I would know that.
Let's see how far you can go. Yeah, that's pretty far. You can even more. Okay, that's good.
Hey folks, so for our final session here, we have a little bit of a different format. We have a hello guys, we're powering through last formal session here, and then we're just going to have one little wrap up after this. So for our last formal session, we have a dialogue, so a little bit different format. We have the topic of the session is crowdsourcing and collaboration in journalism. Guys, please come in and have a seat. Michael Bernstein, visiting from Stanford University, and Mar Cabra from Madrid, where she works for the International Consortium of Investigative Journalists. And they are going to do some presentations and sort of instigate each other a little bit and have a dialogue about what it's like to work in this space of crowdsourcing and collaboration in investigative journalism. So thank you.
Thanks, Nick. All right, so the basic format will be, I'll share some thoughts, some ideas, some opportunities. Mar's going to tell me why I'm wrong, which I love being wrong. I'm usually wrong. And share some of her ideas. And I'll do the same, and we'll flip it around and talk, and then basically try to progressively open this up. So there was some discussion of human-computer interaction. I know more affiliates with that. I'm myself a human-computer interaction researcher, which is that I care about creating really tools, things that people use, and pushing the boundary in what people can use them for. In particular, I work a lot in crowdsourcing, getting large groups of people together to do all sorts of things that they wouldn't normally be able to do. And in a journalistic context and a non-journalistic context, it's largely been about taking lots of small tasks. You might think about The Guardian and these MP expenses, and giving it out to a large number of people who each help out a little bit, and then collectively we're able to do all sorts of things: shorten text, label images, collect data. And what's interesting about this is that computing is mediating this relationship, so we can guide how people interact. So we can guide this conversation in such a way that, we can take this document that you've written, take it out to Amazon Mechanical Turk, guide the kinds of feedback people are giving, and then allow you to look at all of these alternatives that the crowd produced, give you a slider, and very quickly shorten your text, for example. These are the kinds of things that computer science and HCI research has been working on. And this is great for things that Mechanical Turk is great at. Now, Mechanical Turk is typically amateurs, 5 cents, $6 an hour kinds of work. And so anything that gets complicated, like design, engineering, writing, sense making, it really struggles. And just whenever those blocks get larger than the people do, it's really difficult to decompose this into something that lots of people can help with. And we want computation to help. We also know that just from organizational behavior research, we ourselves are not so good at organizing. Like lay theories of organization really stink. We do the wrong thing all the time. But there's all this opportunity, right? We know that just by adding communication, peer production can help create things like Wikipedia, right? Just by making communication easier, we can create all sorts of new artifacts. And what I'm interested in probing here is, what if we take this farther? What if we go past just communication and think about how we actually organize ourselves? What if we could bring together people toward a goal that we all care about and coordinate our efforts in new ways? In particular, let's stop thinking just about amateur work, getting anyone to help. Let's start thinking about what happens when we bring together experts, people who bring specific expertise, whether it's journalistic, music, graphics, whatever it would be. Now, in my world, this might look something like this. Could we actually crowdsource an entire design process, starting from a napkin sketch of the tool that you're trying to build, and one day later produce a high-fidelity prototype and say, hey, is this the kind of thing you meant? Be able to show it to those users and say, oh, actually, no, let's try it again. Could we likewise give you the power to reach out to the crowd and coordinate their activities to create an entire animated video in 2 days? Or put all of this together to create platforms containing content, videos, learning materials, again, in about a day. And again, I think this is about shifting our point of view of crowdsourcing as being, let's ask everyone, to one in which we are asking targeted people and structuring their collaborations. So just to give you one example of this, we've been working on something we call flash teams. Flash teams are computationally guided teams of experts from the crowd. And when I say crowd, we're actually talking about other kinds of labor markets that are not, say, Amazon Mechanical Turk, but something more like Odesk or Topcoder. I don't know if you've heard of these, but there are large online labor markets that are worldwide where you can get people. We've gotten Frankfurt opera singers, for pay, for short, basically contract work. And the idea is that we can use these computational structures at scale to help you get done whatever you want to do, or likewise, you can contribute to such teams to help support whatever you'd like to do. And at its core, we're just talking about how we coordinate roles and handoffs. And this is what the organizational behavior research suggests, is that all you need is a team scaffold that sort of gives us roles and goals. Each thing says, okay, what kind of skills do we need? We need UI designers or UX researchers or software developers. What is the structure of this? I'm going to hand you something that's a low fidelity mock-up, and you're going to give me back out something that's a revised mock-up based on some feedback that I've received, and I have about 90 minutes to do it. And we sort of take it from there. Here you can see an entire flash team structure, everything from a napkin sketch out to a working prototype. And what's interesting about this is that now, because technology is in the middle, we can computationally modulate these teams. They can grow, they can shrink, we can replicate them. We can make as many as we need. So for example, if we have a modular team, we can make several of these teams, right? It's the same thing, we just need more people. And those different teams can take in different napkin sketches and go and create different prototypes, for example. We could also combine them like Lego blocks, right? This team does this, that team does that. We can combine them to create, almost starting to create macro-style organizations. We can grow and shrink on demand. Okay, so maybe you think you need one person typically, but you occasionally need to be able to reach out to a machine learning researcher to say, hey, this isn't working, help us debug this. And in our experience, you can get someone in about a half hour on these crowdsourcing marketplaces. You could also pipeline. So again, this is in a computer science notion of pipelining, where all you really need to know is that some tasks actually don't need to wait entirely for these other ones. And once we know that some things can finish early or can start late, we can just automatically sort of compress things and make it happen faster. We can also help people out who don't actually know, don't feel comfortable authoring these teams. We're building up a bunch of these little modular Lego blocks, right? And if it's possible to lay down a path from point A to point B, we can actually help you do it for it. We have this library of everything that everyone's ever built, all these teams. And let's say you have a napkin sketch of your idea, but you don't want a prototype, you want an animation. Okay, well, we can try to see if there's inputs and outputs that we can weave together from known teams to create a team that was synthetic, like it never actually existed before. But by combining all these different perspectives, using actually really old school artificial intelligence techniques, we can create this new synthetic team that can do it for you. So there are tools, right, for project management. I'm sure many of you have seen them, Gantt charts and so on, but they don't really capitalize on these affordances of distributed crowd work. And I think much of the stuff that we're talking about in this venue is it's distributed. There's many people, it's across country boundaries. So we are creating tools here to actually help aid in the authoring of these Flash teams, and when they go live, the coordination, in a sense, a computational management of these teams. Everything from creating glorified Gantt charts, which basically specify who's doing what and when and who's giving what to who, and then turning it around into sort of a runtime that's keeping track of how we're doing. It says, actually, that thing's taking longer than we thought, so it sends everyone an email, says, hang out, we'll start again soon. And let me just give an example of how these kinds of things work. So these napkin sketches, you can see one of the running prototypes on the right. It took about a day, cost about $1,000 using these workers on Odesk. And it's not deployable, but it is a functional prototype that has been user tested. This is something that takes weeks in my undergraduate course, and we did it in about a day. More ambitiously, we can create sort of more creative animation kinds of outputs. Now, I don't think there's actually an audio output cable here, so I'm just going to point this at my computer. You'll get the idea, trust me. We were looking for something that was a little bit more open-ended. Imagine you're a journalist and you want to be able to convey this idea quickly, maybe internally or externally. And what we had was one of my colleagues, Terry Winograd, is actually retiring. We said, hey, help us make an animation to celebrate a moment in his life when he created a computer in his garage. So here's Terry.
It works!
The it works may have been me celebrating that this actually succeeded. So this is not a set of skills I have, but by collaborating with people who do have these skills, we were able to create this Flash team and create a number of these animations. In fact, just to give you a sense, we can take several of these kinds of teams. We added one more, an education team that combines someone who has expertise in curricular development with a topic expert, and can combine these things into a macro organization. So we create people trying to create an entire MOOC platform like Udacity or Coursera, just for sort of little ad hoc things you might want to learn, like how to sing from the diaphragm, or how to solve the Towers of Hanoi puzzle, or how to take portrait photography. And again, we're doing these things in the scale of about a day. Simply by structuring these collaborations. And in other work I won't talk about here, in fact, by using this approach, we do basically save half the working time. These teams, just through the structure, are actually twice as effective, or as efficient, excuse me. So I mainly just want to try to make the point that crowdsourcing can be much more than you think. It's not about taking just a huge munch of data and throwing it out to everyone and saying, everyone do your little part. I think that we can look forward to much more complex, interdependent projects for all sorts of creative, analytical, and engineering stuff. So I'll pass it over to Mar here, who's going to tell us some more. And she's on a Google presentation, which I think I drag over here.
You just need to click on present.
Not if it's on the wrong display.
Okay, you have. So you actually said that I was gonna criticize your work or something. My jaw is like this, so I cannot criticize any of what you said, but I think it's very interesting what you're showing about using the crowd for very specific tasks. But I have a problem to apply your work in what I do. I do investigative journalism, and I need to trust the people I share information with, because it's very sensitive stuff, or because we have leaked material that I cannot share with everybody. I don't want people to publish ahead of time. So how do you measure trust? How do you know who to trust in your Flash teams? And also, how do you know these are trustworthy people that are not unbuilding each other's work?
Oh, you want me to respond now?
Yeah.
So I think this is actually a general problem with crowdsourcing. How do you know who you're working with, right? Could you use anyone who's a sufficiently talented, your mouse is over there, who's a sufficiently talented character designer? Or do you need someone who you trust is not going to leak this lead you have or this data that you've come into the possession of? And I think that really any group could be, of sufficient size could be thought of as a crowd. Like crowdsourcing became synonymous with Mechanical Turk somehow, and I think that that's wrong. I think that, not that you want to necessarily use James Hirayuki's definition, but it was just about making an open call to a potentially unknown set of people, right? And that group could be the employees of your organization or people who have all volunteered. And I think that you have to at some level trust the individuals you're working with or who you're asking, or you have to be able to filter it once they apply, which is what we did in practice. We built up panels of people who we thought were good enough based on their ratings on this Odesk marketplace, which works a little bit like Airbnb. People rate each other. But in your scenario, I think you build up the trust group first, and then you go.
So that's actually what I'm going to talk about. So thank you for the leading. But I think his work and our work overlap a lot, and it was very interesting to prepare this session, because all of a sudden we realized that we're doing similar things but from different perspectives. Before I was even talking to him, and he's like, oh yeah, all the literature supports all your questions, and we are having the same questions. So hopefully that's what this discussion is about. I work at the ICIJ, the International Consortium of Investigative Journalists. You can follow this presentation on that link. And what I want to talk about is especially how can we gather the collective intelligence of investigative journalists and collaborate on micro tasks, as he's saying. And I asked about trust because to me trust is the beginning of everything we do. ICIJ has been working since 1997 on building a network of trust, of trusted reporters that work together and share information across borders. We are a network of 185 reporters in more than 65 countries, and that's exactly what we do. We collaborate and investigate on issues that are of global importance. We try to expose systems that are broken at a global level. And this is the key word of everything we do. ICIJ would not exist. We would not be able to do groundbreaking investigative work without collaboration, which to me was a very new concept, because journalists, in general, we don't tend to collaborate. And in the country where I come from, Spain, some journalists don't even talk to the person in the next desk because they fear that that person would steal some of their work, right? So collaboration is a very interesting concept that we're trying to apply among people that don't know each other and they have never talked to each other. They're just part of this network. And I think collaboration is one word and sharing is another very important word of what we do. And in order to show how we collaborate, I wanted to use this case study, which I think Scott was pointing at as like, show your success story. And I think this is a success story of how we collaborated, and not only on a content producing basis, but also on a technology, emerging technology and content producing. We worked for more than 15 months on an investigation called Secrecy for Sale, or also known as offshore leaks, where we were basically trying to expose who were the owners of more than 100,000 offshore entities in tax havens. And we did that all over the globe because the connection of the data was with more than 170 countries.
The way we worked is basically, we wanted to expose these type of places, right? This sounds like a beach you probably want to be in right now. This is actually a tax haven. Tax havens not only produce or have nice beaches, they mainly give two things. One is secrecy, and the other one, in many cases, is low taxation. So how can we collectively try to break through the secrecy that these places provide and that are affecting the global economy? Well, everything started with a hard drive that popped into my boss's mail, Gerard Ryle, when he was a reporter in Australia. And this hard drive had 260 gigabytes of data, 2.5 million files that basically exposed who these people were and who were the owners of all these offshore entities. These places don't have corporate registries that are publicly available, so having access to part of their corporate registry was very interesting. So Gerard, who was a traditional investigative reporter, could have acted as many traditional investigative reporters have acted for many years, which is doing this. He could have hunt onto his hard drive and say, "My treasure," and not share it with anybody, and try to do the scoop that would basically lead him many front page stories and possibly, you know, winning a prize, I don't know, Pulitzers or whatever. But he didn't, pardon?
Are there any others?
Yeah, there are many others. For those that we don't write in English, there are many others that. So anyway, he could have done that. And instead of that, he decided not to be selfish and tried to be actually more clever and use the collective intelligence of our network. So when he became director of the ICIJ, what we did is basically collaborate together so we could find stories in all those countries that you can see there that have dots in blue, and many other countries that we haven't been able to report on. So for 15 months, we worked for 112 reporters in 58 countries, exposed. The way we did is we broke down the data into sets that were understandable by regional reporters. Reporters would use their local intelligence, and again, I'm talking intelligence of intelligence, I'm not talking computer, lists of names, because some people, they just read lists of Word files. They even find spreadsheets very complicated. So, but by basically distributing and partitioning the content and distributing it among our network of reporters, are using their local knowledge, we were able to basically build a global investigation that was published in all these countries. The beauty of what we do is that in order to have the best impact, we publish all together. So everything we do is embargoed until we publish together, and journalists respect that, which is quite an amazing fact. So by April 3rd, 2013, or April 4th, depending on how you count it in the part of the world, we were publishing in dozens of media organizations, and you can see some of the ones that you may know there. They were all producing local stories and adding to our global story. So we would have like a story that would summarize what's happening and what is the global trend. But we don't not only produce stories globally and content and basically print or videos that were broadcasting, for example, in a Canadian Broadcasting Corporation. What we did is also try to collaborate on other types of products. So interactives. We built this interactive for the second part of the investigation we published in January 2014 this year about China and how the Chinese elite was using offshore and tax havens to basically manage their wealth. We did interactive that showed the main faces of the people connected to Chinese elite, and we did this interactive that was translated into 6 different languages and published in 10 different media organizations. In the end, it's a spreadsheet that is feeding the interactive and the JavaScript. So it was easy to actually produce it, and then for them to then embed the content pretty easily. With this, we were able to have a lot of impact worldwide. Just so you have an idea, with this China story, all the media that we published with were immediately blocked in China. So it was like sane censorship in China from The Guardian, Le Monde, El País in Spain. So it was basically showing what an impact it has, that not only the New York Times publishes something, but that we all publish together. And we're not competing media because we're in different media organizations in different countries. And also we also had some impact on policy as well. So for example, the G20 had to basically bring back tax havens into their table for their meeting. The G8, the same thing. Also, the European Union and the European Council especially had to deal with this issue. The big minister for the EU Commissioner for Taxation said that our investigation, because it was published in so many places and had such a big wave, was able to help him in pushing forward his tax policy. He said that our investigation was one of the main triggers into tax policy in Europe. And we had also some bankers resigning and some other interesting impact. But not only we collaborated on content and on interactives or graphics, we also tried to produce a tool that would help the public collaborate with us. So in a more general way, not targeted individuals, we basically put up some of the data online, and people can go online into this URL and basically type in any name and see whether that person is there and kind of explore the nodes around who are these people and so on. And we had this database up since for a year or so. We've already received more than 600 tips, and some of them have already turned into stories done by us or our partners. So we collaborate even at that level of sharing the tips we gathered. So in the end, we could say that we helped, thanks to this collaboration and sharing all these type of parts of the process, of the journalistic process, we were able to break a little bit of the secrecy that some of these jurisdictions provide. I guess your question now is, yeah, all that is very good, great PR for ICIJ, but how do you do it, right? Well, the main thing we try to do at ICIJ is this. We are the orchestra directors trying to orchestrate the investigation. When I was talking to Michael, he was saying that, and he just showed in his chart, that having a leader that basically tells the people where to go and basically coordinates some of the work is very important. And we find that without the work of somebody knowing what's going on everywhere and basically helping find people some leads and move on and sharing and promoting the sharing, it's not that easy for people to share immediately. So it's very important to have a role of somebody trying to direct. But not in a direct sense of I want you to do this. We're not editors. We just basically try to gather the collective intelligence in the best way. How? Not by my boss just making phone calls to people. We try to build cloud-based solutions that help people collaborate. So we've been in a very simple stage, we've been trying to implement some open source forums. This is one forum we implemented for offshore leaks. It's called FAT Forum. As you can see, it doesn't seem to be very user-friendly, but at least it allowed us to have secure threaded communications and basically exchange what we were finding in Germany, what we were finding in Spain, what we were finding in Brazil. And actually, thanks to tools like this, cross-border stories that have happened. So right now we're investigating a topic that will come up in the next coming weeks, and the Germans are collaborating with the Canadians on a topic that they didn't know they were both working on, and they would not have found out if it was not thanks to this tool. We're moving from very simple threaded communication, cloud-based solutions to social network tools where our journalists can communicate a bit like they communicate on Facebook, right? So this is an open source tool called Oxwall that we're implementing, and we're creating something called the Global iHub. Basically what Oxwall allows us to do, and of course because it's open source we can modify it, it allows us to have not only threaded communications through forums, but also Facebook-like walls where journalists say, hey, I found this. Does anybody have any insight on that? And also share files and share links and so on. Because it's a social network tool, it's very funny because in the registration login, it asks you whether you're there to find females or you're there to find males and so on. So we're trying to adapt some of these things to our needs, but it's the same idea. And we're actually trying to develop this thanks to a little bit of funding from the Knight Prototype Fund, and hopefully we'll have a prototype by the end of January or so on. Because what we're trying to do is get this social networking site and adapt it to investigative journalism. So basically, it would also have an infrastructure that provides a bit more security than just serving a site over HTTPS and having it physically stored in a physical computer, physical server, sorry. So we also not only create platforms to communicate and make those exchanges easier than just by sharing email or sharing email over PGP, we also try to find tools and create tools that would make people be able to search over the leak of files. So we've tried to use our own tools, but we're also trying to implement and coordinate with already existing tools like Document Cloud or even Overview that Jonathan was talking about. But so far we haven't found the best solution, but because, for example, with offshore leaks, we had emails, PDFs, we had photos, so it was not one type of file. So we turned to DT Search, which is a free text retrieval search tool that basically allowed us to index all the files, the 2.5 million files, and you could search words through it. So Denise Rich, which is the name I showed you before, which I'm sure many of you know, because it's a famous person from the US. Well, you could search through the emails that mention her. Recently, we've been turning into Apache Solr. We've tried to use Apache Solr because it allows us to add metadata and for all the journalists to search very easily, which is search box. That's what my journalists understand. There's a search box and I can add some words. But for example, that allows us to basically put the leak in there or whatever data set we're working on and also enrich it by basically adding some other data sets. So for example, we've just added the Gazette, the official Gazette of a European country, which is, the Gazette is the documents that the government produces where they specify what are the points and what are the things they're doing, the regulations, and what are the companies that are being created and so on. So that enriches the leaked data that we already have. And this is our current challenge. So I heard many of you saying that you need ideas for tools to develop. And so we have an idea, and that's what we're trying to solve, which is, okay, so far we've managed to get journalists to share what they're working on and say, hey, I found this here. Do you have any leads in Canada? Or so sharing or commenting on what they're working on, it's something we've already achieved. But how can we get journalists excited about sharing what they have in their computers and sharing their data sets? So it's not only us putting up a leak in the cloud and then for them to be able to search, but also how could we create collective intelligence on the data that is stored in their computers. So we're trying to basically develop, and we'll be trying to develop this over the next year, a cloud-based solution that is secure enough for journalists to share part of their data or indexes of their data, and for those data sets to be matched so we can find cross-border stories that we didn't know about. So if I have a data set and Cecile there has another data set from France, maybe there's a story we don't know that exists. But by sharing all the data and the collective intelligence and the data that we have, we'll basically be able to find more stories that we knew about. So the big problem, though, is not only that this seems technically difficult, but what seems technically difficult for us so far is to do this securely. And usable. Because we haven't talked here much lately about how difficult it is for some journalists to use some secure tools. So my boss or other people in our network find PGP complicated, but not PGP complicated to know how it works, not PGP complicated to know how to install it in their computers. PGP, opening up Thunderbird, for example, and putting a passphrase complicated. So how can we get journalists that find all these secure tools complicated to actually be able to communicate online in a secure way, not exposing the whole network? So I guess that's our challenge now. And if you have any ideas, I'd love to hear about them now or in the happy hour. If you want to know more, just sign for our newsletter. Thank you.
All right. So I'm going to vamp while you all get up at the mic, because this is supposed to be a discussion to whatever extent we can muster. First of all, I want to say that that's an incredible collection of journalists you've put together, and I think the collective force that you're able to exert is super impressive. The trust issues are fascinating because it's not just that you have to worry about incentives, essentially, like, why should I share my part of this data if this person's going to end up getting credit? And it's part of the ongoing research mystery of peer production, why doesn't Wikipedia have author accreditation, right? Like, why does that work? But in this case, actually, it does feel like you want to have some amount of credit for what you get. And it's not clear what the right way to do this is. And this metaphor that I think you and I keep coming back to is like, what's the carrot, right? How am I going to get these individuals to behave in a way that the entire thing stays together, so that if someone comes and tries to do the wrong thing, they get swatted out rather than flame at each other and the entire community falls apart? That's a really tricky question.
Right.
Go ahead. And then
Go ahead. Yeah.
I don't mean to interrupt if you have a comment.
That's the point.
To interrupt, then, I think your presentation kind of echoed what we talked about in the last panel, where Michael showed a beautiful set of tools that were generalizable and used under different settings. And you showed that you actually need one specific tool that perhaps is not going to be generalizable and going to be used for one specific purpose. So how do we combine these two approaches to create things that are both generalizable and usable by you every day?
Can I take a hardline answer here?
Yeah.
I don't think you should. I think you create generalizable tools, but ultimately the last mile is just going to be a process of bricolage, right? I'm hacking together this script. Have you ever seen? You must have seen the scripts that your graduate students create for their research output, like in R code or something like this. It's a hack, right? Because it's not intended to be reusable. It's about pulling together all these different tools that they have at their disposal. And I think in their case, it's exactly like this, right? You have something that's vaguely forum software, something that's vaguely a wiki, something like, and you make it work. So I feel like you need the core components to be generalizable, so that obviously they can install them and I can install them, we can use them. But beyond that, it's all about drawing between the lines. As long as that's not too difficult, as I think was clearly articulated in the last panel. At some point, if the startup costs get too high, then just forget it.
Right, well, I guess my perspective is different in the sense that what we're trying to do is not just for us. So everything we're trying to produce, we're trying to be able to share it with other types of communities. So for example, when we're creating this global iHub, we know for a fact that there are activists and people from NGOs that have already approached us and saying, we have the same problem. So there's this NGO called Global Witness, for example, that has the same problem, but they're not producing investigative reporting. They're just producing reports for NGOs and exposing global problems. So I really think that what we're trying to do is trying to think beyond journalism and see who else has the same problem. So we can try to have cross-border connections there too. So that, because if not, it's very difficult to develop this and also to get funding to do some of this. So all the tools that we try to apply are not just for our specific problem, but we're trying to think of problems that serve a wider purpose too.
I would just add, every time I see people try to create like a general workbench that combines all of the tools, it ultimately fails because it doesn't quite do the one last thing you need it to do. So I think it's about the flexible on-ramps and between them that's ultimately going to succeed.
Hi, Nick Giacopoulos. I want to try and make a connection to the panel this morning on algorithmic accountability. And, Michael, you're talking about creating computing, guided workflows from crowd workers. Mar, obviously, lots of people publishing from sort of the same source material and collaborating around data. I'm interested to hear you guys reflect on, where should the accountability lie when you have these large collaborative projects, whether they're creative projects, using some kind of cloud architecture to bring people together, or whether it's hundreds of journalists who are sort of working together on these document sets. Like, is there some accountability to the larger process somewhere, or does it come down to the individual who worked on that piece of the project? Or I'd love to hear some reactions to this.
So we don't operate as a newsroom, but we operate with newsroom standards. So we will operate in cells, right? So ICIJ provides or the setting for collaboration, and then each reporter in each newsroom does their own thing, but then they feed onto the crowd and onto ICIJ so we can get the global picture, right? Every time they feed something, so Le Monde gives us something that we can use in our story or an interactive, or that helps us improve the data that we have, we ask the same journalist, we ask for the same journalistic standards that we would ask for a reporter. So if they provide a fact, they need to provide the document to back that up. And it's kind of like the same idea. So we would not publish or take anything into account if they would not back it up, as they would do if they were our employees, if that makes sense. So basically our group is very controlled and very small, so I guess that's probably why we can do that. Or maybe we believe in the same thing, and that's why we think that.
Does your organization take on a legal liability?
Oh, good. So no. So we take on legal liability.
So you're not accountable then for mistakes made by
we're not
partners?
Well, yeah.
Legally.
That would lead to another discussion, because we've republished some of our partners' work, and we're in a legal problem right now because of that. So, but no, if they feed us anything that we put into our story, we request the same type of accountability that we request for our reporters. Whatever they publish, whatever the French publish in Le Monde, it is their responsibility. So that is basically a legal arrangement. So in the past, we've republished some of the work of our partners, and that has led us to problems, so we're not doing that anymore.
So maybe some of my colleagues know this, because I don't happen to know off the top of my head. If Wikipedia publishes libel, who gets sued? Yeah, I don't actually know.
Wikipedia has been sued for content on the site, but it's all still up in the air.
I see. So there's no clear precedent.
I believe there's a statute in the U.S. that shields them from content that's solicited from
right.
users.
But if a mob
online.
attacks someone, then like clearly there's something's going on, right? Like there's a core that makes sense to your point. The crowdsourcing systems that I tend to develop, not exclusively, but mostly have, like there's a buck stop somewhere, like there's a user or a requester in the loop. So in the kinds of things that I design, it tends to be that I, as the requester, am ultimately responsible. I'm the one who chose to use the tool. I should be vetting the results. But this is not necessarily a design approach that everyone shares. And I think there's lots of interesting questions around more bottom-up kinds of collaboration.
Thanks.
So my question is kind of along the same lines. I mean, this is so brilliant what you've done here, and I'm wondering, when you share data, I've always been taught, and maybe this is erroneous or overly cautious, that sensitive data should not be in the cloud because it's too easy to subpoena and it becomes subject to laws in lots of countries. So I'm wondering, how you guys deal with that, and if, like what do you upload and what do you say? No, we're not going to put this in the cloud.
So this was an interesting discussion we had, like in December 2012, where I was hired to do research for the reporters. So we had a team of 10 people at that point who had the hard drive, this hard drive I talked to you about. We made copies, and they came and they got it physically, and they traveled back home, and they had it. So they were like distributed hard drives in like 5 or 6 places in the world. And then they hired me with one of those hard drives to do the research for everybody else. And I was getting these emails from reporters all the time asking all these intensive, labor-intensive questions of like, can you do this? Can you do that? And then somebody in India, and somebody like all over the globe and all the time zones. And in 2 weeks, or less than 2 weeks, I realized it was not possible for us to do it. I'm not scalable. I work a lot, but I'm not scalable. So the only solution we thought was to actually put up the documents online. I guess one of the big considerations that we had is who would be our enemy on this. And we didn't consider any government threats on this because we already knew that, well, first off, if governments get hold of this data, they would be happy. They would be, oh, great, data on taxpayers that are supposedly not paying their taxes, great. So, we didn't think that was a threat. And also, we also knew that some governments, the US government, the Australian government, and the UK government especially, as they later publicly acknowledged they had a copy of this data. So it's true that, at that point we thought, MAR not being scalable, we don't have the resources to hire 20 MARs, so let's just put it up online and try to make, at least have some security around it. So that was kind of like the thinking process of putting this data online. And so far, now we're trying to put everything we have online. We haven't found, or we haven't worked on a project that is so sensitive that we don't think could be put up online.
Did you have to redact anything to protect whistleblowers or anything like that?
So we did some forensic analysis on some of the data we had and made sure that some of that information was taken out before we published, because so far the sources of offshore leaks have remained anonymous, actually.
Okay, thank you.
John Meiskens, I'm a computer science student at Calvin College. So what happens when you take editors and humans out of the loop and you hook up our event detection on social media to the crowdsourcing platform, and that's how the news is produced? To extend our answer to the previous question.
Well, I mean, the literal answer is what you could create. I don't know whether you want to create a sort of automatic press release engine, right, that takes news as it's identified and can produce, well-behaved, nice reading, perhaps prettily illustrated articles. There's one example of this almost in the running. I'm actually unsure whether they still do this, but for a while, Twitter actually hired an internal set of Mechanical Turk workers. So they used Amazon Mechanical Turk, found people who they liked, and created a sort of a private workforce who they would email whenever they had something. When something started trending, people start searching for it. And search results are great, but Twitter, it's hard to get great relevance signals. So what they started doing is get these Mechanical Turk workers to start piecing through the tweets and so on that would come up on this trending topic, and more or less manually put together a search result page for that trending topic for a little bit. And I think that's something that's a really fascinating point of view. Algorithm says something's going on, but I don't know how to present it in anything that's any way that's meaningful or useful. Can you help us get over that hump? And that can produce data over time that eventually perhaps machine learning could take over more of that cycle. But I thought it was an intriguing model.
So actually, I'm realizing we said this would be a dialogue, and we're answering questions, and I have a question for you. Because one of the things we're struggling with, and Jonathan pointed it out in the question time before, is the language, right, and the cultures. And when you've done work among different people, how have you dealt with cultures and different ways of doing things and knowing what's ethical, what's unethical, and also with across different languages, so some issues don't translate well.
Yeah. So how do we deal with it? Not well. I think, in many ways, part of the power of some of these visions is that you could have these globally collaborative teams potentially, handing on a deadline, handing things off such that it's like the sun never sets on this journalist team, right? And in our experiences, it's been very difficult to get over, especially language barriers, but I think even more so technical and social barriers. So in these Flash teams, for example, not everyone's on a great internet connection. So even hanging out in a Skype room together becomes infeasible. And not everyone's great at written English, and so even Skype text chat can be problematic. But I think potentially even more challenging is, well, I expect that the work environment works this way, you expect that it works this way, just because we come from different cultures. And I think that we can design something that intermediates, but I don't think we yet know what all the problems are. So we're just sort of stumbling across the errors. I think the quote from before was, "We do it wrong until we do it right." I don't think we have a great answer. There's a lot of research in globally distributed teamwork that comes out of, Pam Hines is a great example, and there's a lot of insights there. But I yet haven't been able to effectively translate that all into design recommendations.
Right, because I guess trial and error is our way, but I guess our journalists get to collaborate and share better the more they do it.
Yes.
So because in the end we have a limited set of people, so it's 185, but we also bring people that are not journalists in our network. So, maybe it would be like a set of 200 people, right? And the same people doing it over and over again. So in offshore leaks, people didn't communicate much in the forum. Now in this new project, people have communicated a lot and shared memos and shared ideas, and the Germans with the Canadians that I was telling you about. So I guess, I don't know how you do it with like different people that don't even talk to each other. I really find a lot of the personal interaction is very helpful in that. Like whenever we started implementing some team meetings, so every news organization would pay for their reporter to go to a place. So we would meet, for example, in Brussels, and all the reporters, even the people from South Korea, would come for a day where we would do training on how to use the tools, training on how to what the data is about, or training about the topic, sharing, exchanging ideas, and that has proven pretty useful, and that's what we're doing right now, because in the end, we're also not only distributing research and trying to do distributed reporting, we're also trying to do distributed economics. So ICIJ is not basically paying all these 100 journalists, because each newsroom pays for their own journalist or journalists, right? So in the end, it doesn't cost us that much. But anyway, what I'm trying to get at is the personal part is very important. Right. And for example, we've had a lot of problems doing creative work. So I'm an ICIJ staff, and I sit down in my house, in the office next door, and in Madrid. The programmers that work for ICIJ at ICIJ's data unit are in Costa Rica. Then we have the office in DC. And then we have people that are working from New York, and some other people that join from other different places. And I just find too much time on Skype. I actually have TMS syndrome, which is too much Skype syndrome. And over Skype, it's very difficult to communicate creative ideas. So I've been having a lot of problems like prototyping, for example, creating prototypes. But it seems that you've created a motion graphic or like a video animation. So what are the tips that you can give?
It's actually, we have to continuously push our collaborators to remember to do what we're aiming for and no more. This is partially just an artifact of the incentive system on Odesk. Everyone wants to get a great rating. So first of all, they want to spend a half hour Skyping with you to make sure they understand exactly what you're asking for, which, like you, does not scale. And they also want to keep going to make sure that they are doing exactly the best job that they can, when in fact what we really need is like a hacked prototype or a low fidelity mock-up, and we really want to keep things moving. So it's this sort of like lockstep coordination is very difficult, especially when I feel like we've inherited this mentality perhaps flowing out of Silicon Valley, of this very flat hierarchy, and everyone's doing this together. But like ultimately, I think that if we need to start, dancing together, which requires a lot more coordination, then there needs to be, we need to rethink some of this. We're sort of, I think, starting to hit the limits.
And for creative tasks, like, is there anything special about creating together? So not doing things that could be breaking down to tasks, but I don't know, designing together from different parts of the world, like drawing together, creating a video together. What's the difference doing that to, hey, push this, commit this,
I actually think that, I don't know, I'm not convinced that the processes are so different, at least the interpersonal processes. Certainly the work processes are different, and like how you get it done. But when you're watching these animators collaborate, like, I don't know, have you ever visited a video game company? You have like programmers and artists sitting across the wall from each other, and they have to collaborate to get this stuff done. They have to make something that works and is beautiful, right? It's in some cases these cultures wrap all the way around, like, and meet each other in the middle. So I agree that it's a problem. I'm not sure if it's exactly about creativity versus engineering pursuits, though.
So just to jump in there for a second, and just final quick question before we wrap up at 4 for our final little quick wrap-up session. I wanted to push on this issue of the creativity angle, because you hear, well, data journalism, it's 80% cleaning the data, and it's sort of data munging and so on. Is creativity really the barrier for collaboration, or are we really talking about distributed effort to clean data and make sure it's reliable and accurate, and then we need like a workshop for a long weekend where we can like have some really high bandwidth creativity going on?
Want to take it first?
I guess it depends on what you're producing. So, or in our experience, it depends on what the ending product is. So, when I meant creativity is, I mean, we're trying to build this platform so it's usable. People know how to use Facebook. People don't know how to use encryption. So I don't want this, I don't want people to think encryption, I'm secure, I don't want to share. I want people to think, hey, Facebook, I'm going to share what I'm saying. So thinking on what's usable and what's not, and creating something that solves some of the basic problems, to me that is difficult to do, and that's creative. That's not so much data journalism, I don't know, it's creating tools to solve problems. So in that sense, it's not 80% cleaning data. I'm not cleaning any data there, But I think that in anything we do, it's important to have traceability. So in order to be able to collaborate together in data work, even in cleaning work and so on, we've had to fall into tools and processes that allows us to trace what is being done and push it, send it elsewhere. So for example, we're relying on a tool called Talend, which is an open source solution, ETL tool, extract, transform, and load solution. When we're basically building databases from different sources and producing a different database, everything is done with Talend. So all these jobs could be exported and sent somewhere else and traced back. So if there are tools that allow us to trace these things, it's kind of easy then to collaborate on that part. So it's not so much about sitting down for those tasks that can be traceable. Journalists are, once you have the tool, or that's our experience, journalists are used to kind of chatting about what they're doing. And if they need something about the German colleague, they will, get it done. If we produce a platform that, asking the German colleague is very easy, then that happens. I don't know if I've kind of scattered answer,
we can
but
chat a little bit more afterwards.
Yeah.
But I want to thank our dialoguers here today. And I think Bernd and maybe Larry also are going to do a final little wrap-up session for us.
We're going to call this the long and the short of it.
And now you already know why it's the two of us who are doing this. Otherwise, we were trying to figure out why they would ask two techies at a meeting like this to have the last word. But I guess here
it's
we
diverse
are.
Enough, yeah.
Exactly. So, the call for papers, we're going to spend maybe 10 minutes or so to summarize and wrap up. Think of this, if you write scientific papers as the conclusion section, which is always really hard to write, right? And if you have to summarize a whole rich and very interesting workshop of 2 days, it's even harder, right? So
yeah.
We're going to try hard, but I don't think we're going to do justice. And that's of course the reason why there are drinks afterwards, right? So you can fill in all the things that we forgot to talk about. But if you look at the call for papers, it talked about the interface between computation and journalism. Now, one of the things I think that's very clear from the 2 days is there isn't just one interface. There aren't even just two interfaces. I count at least 5. So here's my list of the 5 interfaces between computation and journalism. It's computation in support of journalism, computation analyzing journalism, computation replacing journalism, computation as the subject of journalism, and computers as a conduit of journalism. Okay? And you can probably add to this, but we heard about all of these aspects, a lot more about some than about others. In fact, we mostly heard about computation in support of journalism, and data journalism ran as a theme through a lot of the sessions and presentations, basically mining data sets to discover stories. And my conclusion was that the leading news organizations have actually pretty much figured that out already, or at least are close to that. The New York Times, the Post, the BBC, ProPublica, Wall Street Journal, etc. And the formula, I guess, Basil formulated this very nicely. Is he still here? Oh, there he is. It's hacks and hackers. It's about bringing people with different backgrounds together, and if you have an interesting problem, this actually works. Now it's mostly, when you do these projects, about finding the data and the data wrangling, right? Which is kind of the dirty and ungrateful part of the work, but it consumes a lot of time. It's very labor intensive. The data analysis part is usually pretty simple, at least today. Maybe it has to be that way because the public understands means, and they understand percentages and maybe rankings, but not much beyond that. So there's a limit to the sophistication of the type of statistical analyses you can actually publish. Now, having said that, there are a lot of challenges and opportunities, and I'm sure in future years we're going to hear more about those. And there was interesting ideas discussed and presented. One really essential facets of this, which is different from other areas, is stream processing. News need to be timely, so you need to come up with things really, really fast. So real-time alerts as data come in, right? I mean, that's something that is essential. Another aspect, visualization. How do you show these data? It should look good, speak for itself. A great area where journalism and computation can come together. There's also, today a lot of people look at heaps of numbers, essentially, right? But there's a lot more than analyzing heaps of numbers. There's troves of documents. Using natural language processing, where you want to tickle out a story and discover things, and I think we're going to see a lot more along those lines. And quite frankly, this is also going to make it a lot more engaging for the academic computer scientists, because they're not that interested in computing the percentages and means and big heaps of numbers, but there are real challenges that push the state of the art of computer science and natural language processing and analyzing these documents. And last but not least, I thought there's a really interesting discussion about actually reverse engineering, those big algorithms that filter the information and present it for us today, and the public needs to know about this, and it's a very important area for journalists to report on and understand. So, moving from numbers to text documents to algorithms, web scale algorithms, basically. I mean, I think there's a great path there. If you don't find the data, you can generate it yourself. So there's this cousin of sensor journalism, right? It's my favorite application of this is always in sports. And there's a very rich application for sensor journalism in sports, but also in other areas. Think about environmental monitoring. And all this is labor intensive, expensive. So that question may be best discussed over drinks, right?
Yeah.
Is who's going to pay for this? I think the universities can play a real role in this. With centers that come up on computation and journalism. Some of these projects could be great master's theses.
I think students can do a lot of work, absolutely.
Students can do a lot of work. Nonprofits should play a role there. There's probably maybe less we can expect from the news businesses, right? So.
Right. Thanks, Bernd. I have a couple of observations. I guess this counts as the diverse. Maybe I'm the reporter today. I have this. Bernd is on the machine, and I'm doing this. But there were a lot of apologias about. I know this is very simple, or my problems are very unchallenging, or my methods are very straightforward. I think people don't need to apologize for doing simple things. I think simple's great. I mean, a big message I tell my students is, being complicated does not make an algorithm interesting. What's interesting about an algorithm is the ratio of how interesting its output is to how simple the program is. A complicated algorithm that does something simple is not at all interesting, but a simple algorithm that does something interesting or complicated is very interesting. I mean, about as interesting as anything can get, actually. So that's actually a very important thing. I saw a kind of a gap here still, and maybe this is the gap that we always have to work on. There's a gap in a lot of work in machine perception called the semantic gap. I still saw a gap between platforms and tools on the one hand and storytelling on the other hand, and that's somehow working to narrow that gap, I think, is a lot of what we're all trying to do here. I think that there's a sense in which people who are not computer scientists don't understand that there's a crushing reality of computer science, which is that scalability trumps everything else. I've had a lot of projects that I loved and I thought were much better than other things that ended up winning because they scaled better than what I did. And that's just a sort of a brutal reality of the computational world. Whatever scales the best will win. And that's something that we need to keep in mind as we move forward. I mean, we can negotiate that, but we can't beat it. And that actually leads to a couple of interesting, I think, situations. One is, I think we're still negotiating again the difference between the story as a kind of craft item, as a kind of individuated thing that's a really beautiful thing, and then things that scale on the other hand. I think related to this is actually tolerance for failure and error, which, a couple times this came up, on one of the panels before, error is not an option. I heard that, and the thing is that the reality of computational methods right now is, first of all, many of the methods that are being used in this area are statistical in nature. And almost by definition, they actually, I mean, you can quantify how accurate they're going to be, but they're not going to be perfect. They're just not. And I think learning to live with that is actually going to be an issue. I think the second thing is the diversity of situations in which these mechanisms are finding themselves now is, I think, pretty broad. Maybe, I mean, they're out there in the world and people are interacting with them all the time. And this came up in the issue of accountability. Can you foresee how a program that you're creating and the data that it creates or co-creates with people operating with it in the world is going to end up behaving? And the answer is, we can't. And there are a lot of other mechanisms in the world, obviously very complicated algorithms out there that work on helping to fly aircraft or do all kinds of things that are actually life and death decisions. And obviously errors or lack of foresight there can lead to some catastrophic consequences. But there's something about the parameters in which they operate are generally more narrowly controlled than I think some of the things that we're doing now, because they're out in the social world and really kind of doing something that is very new. I think the numbers of people who are interacting with these things, it just becomes really difficult to do that. So a little bit of, I think a little sympathy for algorithm designers wouldn't be amiss. They're usually not trying to do the wrong thing. They're just not smart enough to do the right thing. And then finally, there was I think an interesting, and Bernd touched on this, there was a lot of work on data journalism and censor journalism, and I saw a lot of discussion about tools for journalists and tools for storytelling. I didn't see so much about tools for publishers or tools for readers. And for example, even though social media came up a lot, it was really about things like how does fact chase fiction and beat it more than, there was a little bit on this, but the opportunity to create new kinds of news out of these things, or even something as prosaic as commenting systems was really touched on only in passing. But this is a gigantic challenge and a very interesting challenge to sort of take these situations as they are and make them valuable to people and valuable to publishers and valuable to readers. So I think there's just a huge, this is not a criticism of the program, which I thought was, by the way, fantastic and really exciting the whole 2 days. But I think it just shows how much opportunity there is in this space and how many great problems there are that we get to work on together. So I'm looking forward to that.
Yeah. I mean, social media is really a unique opportunity, right, to peek into the minds of the reader or the viewer or the news consumer. And I mean, we heard a little bit about this this research frontier of trying to understand how information spreads in network, looping back to our keynote address. But I mean, there's a very profound question there for journalists and journalism. Traditional rules of newsworthiness are now suddenly replaced by the dynamics of sharing, right? So it's what does that mean? I mean, it's really a radical departure from editorial responsibility, and is there a happy medium? There's some kind of a combination of curating content and letting people vote on what's really, what should be passed on among their friends. Boundaries blur between the author and the reader. Clearly, people add on commentary. We didn't really hear much about this, and which in a way is encouraging, right? I mean, there are still a lot of topics here in these at least 5 interfaces that I mentioned earlier that we want to explore, and a lot of opportunities for interesting and original work there. We heard a little bit about crowdsourcing, of course, particularly here in the last panel, but we didn't hear much about the rise of the citizen journalist, and that's in a way, just the absence of that topic here at this meeting. I thought was noteworthy. In my mind, very unclear how all this is going to play out. But that's of course exciting for us as academics. So we'll see where this is going to go.
And as citizens, actually.
And as citizens, of course, yeah. So I think enough said. What we are left with is really to thank our organizers. So let me just begin by thanking the reviewers, the technical program committee that read the papers. They're too numerous to be named individually, but I think we should, many of them are here, so I think we should give them a hand. So. And then, of course, there are the 3, Irfan. Here's Irfan. Why don't you get up? And Nick, Irfan. Nick. And Mark. So I think they did a terrific job, and bringing all of us together. I mean, what a wonderful and exciting meeting. And I think the plan is to do another one of these actually here in the same building a year from now, before it then moves to the West Coast and is hosted at Stanford. Okay. So
I just want to take
Mark,
this opportunity before Mark gets up to first thank both of you. I've known both of you since I was a graduate student, so it's an honor to have you guys close this, so thank you. And again, Mark is going to get up and say a few things, but before we go anywhere, Mark and Mike Hirsch, where is he?
Michael, I guess, is
probably
downstairs.
Downstairs getting ready. We should really thank all of them, because it's an honor to be actually in this room, the Pulitzer Hall, talking about completely crazy form of journalism, computational journalism. Thank you, Mark, for organizing this.
All right, well, thank you all, Bernd and Larry, Irfan, Nick, and all of you for staying to the bitter end. That is an awesome thing. It is a beautiful day outside, though, and so Michael has suggested that we assemble for happy hour at Bernheim and Schwartz, which is a brand new bar, which is between 113th and 114th on Broadway, so it's just across the street, 113th, 114th on Broadway. Lovely thing about a grid, Broadway's just out there. I also wanted to thank specifically Michael Krish, the Deputy Director of the Brown Institute, because without him, I would be lost and this event would be lost. And I also wanted to give a heads up for Sean, who's been live blogging the whole event from the American Journalism Review. His live blog is amazing and a nice summary of what's been happening here, so you can go back and have a look. And it also links to a lot of the abstracts that they're publishing. So yeah. All right, so with that, I call this symposium officially adjourned, and we will see you over across the street. Thank you so much.
Well done.